Welcome to our AI Full Course. Get ready to discover how AI is changing the world by teaching machines to think and learn like humans. In this course, we'll cover everything from AI basics to advanced topics like machine learning, large language models, and generative AI agents. You will learn key concepts like reinforcement learning, deep learning, and agentic AI. We'll also work on tools like N8N and LangChain and explore how to build AI websites, benchmark LLMs, and run Llama for your projects. Along the way, you'll gain hands-on experience with beginner-friendly machine learning projects, learn how to evaluate models, and dive deep into topics like AI bias and multimodal AI. Plus, we will show you the top AI tools for 2025 and how to profit with AI agents. By the end, you'll be ready to use AI and innovate and grow in this exciting field. So, let's get started. Before we commence, if you are interested in mastering the future of technology, the professional certificate course in generative AI and machine learning is the perfect choice for you. This is offered in collaboration with IIT Kanpur and ENICT Academy. This 11-month live and interactive program provides hands-on expertise in cutting-edge areas like generative AI, machine learning, and tools such as ChatGPT, DALL-E 2, and Hugging Face. You'll gain practical experience through 15 plus projects, integrated labs, and live masterclasses delivered by esteemed IIT Kanpur facility. Alongside earning a prestigious certificate from IIT Kanpur, you will receive official Microsoft badges for Azure AI courses and career support through Simplilearn's Job Assist program. Hurry up and enroll now. Find the course link in the description box and pin comments. So, let's get started.
Hi everyone and welcome to the course of AI Foundation for Everyone. In this world rapidly shaped by artificial intelligence, understanding AI is becoming essential for everyone, not just experts. This course is your non-technical guide to clarify AI and equipping you with practical job-ready skills. We will be covering fundamental concepts of AI, explore the exciting new frontier of generative AI, and how to effectively communicate with it using prompt engineering. And finally, we will be diving into building powerful AI chatbots all without any programming. Let's begin our journey into the world of AI for everyone. AI is no longer a futuristic concept. It's transforming numerous industries and aspects of our lives. In healthcare, AI is aiding in more accurate diagnosis, accelerating drug discovery, and enabling personalized treatment plans. In finance, it's being used to detect fraud, drive algorithm trading, and assess risk. The transportation sector is witnessing the rise of self-driving cars and AI-powered traffic management systems. Retailers are leveraging AI for personalized recommendation and optimizing their supply chains. Even in entertainment, AI is shaping what we watch and listen to through recommendation systems and even the creation of a new content. Like any powerful technology, AI comes with both benefit and limitation. On the plus side, AI can significantly increase efficiency and productivity, automate tedious and repetitive tasks, improve the accuracy of decision, and drive new discoveries and innovations that were previously impossible. However, there are also challenges to consider. Developing AI systems can be expensive and they often require vast amounts of data to function effectively. Current AI systems can sometimes lack the common sense that humans possess, and there are valid concerns about the potential for job displacement as automatic increases. AI is already deeply woven into fabric of our daily lives and the operational of business. We interact with AI every time we use virtual assistants like Siri or Google Assistants, rely on navigation apps to get around, scroll through social media feeds curated by algorithms, or use email services that filter out spam. In the business world, AI is being used to enhance customer services through chatbots, predict equipment failures to enable productive maintenance, automate marketing campaigns, and analyze vast amount of data to gain valuable insights, generate and manipulate human language. They are trained on large datasets of text to learn the statistical patterns of how words, phrases, and sentences are structured. As AI become more powerful and pervasive, it's essential to address the ethical concerns it raises. One major issue is biases in AI systems, which can perpetuate and even amplify existing societal predictions. Privacy and data security are also paramount as AI systems often rely on large amount of personal data. The potential for job displacements due to automation is significant society challenge. And there are other concerns such as development of autonomous weapons and need for explainability and transparency in how AI systems arrive at their decision. A critical ethical challenge is the issue of biases in AI systems. AI systems learns from the data they are trained on, and if that data reflects existing societal biases, the AI will likely perpetuate and even amplify those biases. We have seen example of this in facial recognition systems that perform less accurately on individuals with darker skin tones and in hiring algorithms that inadvertently favor candidates from certain backgrounds. Addressing this requires careful attention to the data used to train AI, ensuring it is diverse and representative, and a commitment to fairness and accountability throughout the AI development process. Many AI systems, especially those involve personalized services, rely on vast amount of data, often including sensitive personal information. This raises significant concerns about privacy and data security. The risk of data breaches and the potential of misuse of this information are very real. It's crucial that we implement robust data protection measures, priority transparency in how data is collected and used, and empower users with control over their own data. To mitigate the risk and ensures that AI benefits society as a whole, it's essential to embrace responsible AI development. This involves adhering to a set of ethical principles such as fairness, ensuring that AI systems don't discriminate, transparency, so we understand how AI systems make decisions, accountability, establishing who is responsible when things go wrong, safety, ensuring AI systems function reliably, and of course, protecting privacy. Developing ethical guidance and regulation is a crucial, and this is a shared responsibility involving AI developers, organizations, and policymakers. The field of AI is evolving at a rapid pace, and seven exciting trends are shaping its future. We can expect continued advancement in deep learning leading to even more sophisticated AI systems. Generative AI, which can create new content like text, images, and music, is poised to revolutionize creative industries. Explainable AI or XAI is becoming increasingly important as we seek to understand how AI systems arrive at their decision. We are also seeing a shift towards AI at the edge, where processing is done closer to data source. And in the longer term, the convergence of quantum computing and AI cloud unlock entirely new possibilities. The rapid growth of AI is creating a surge in demand for skilled professionals. There are a wide range of exciting career paths emerging in this field. Some of the key roles include machine learning engineers who design and build AI systems, data scientists who analyze data to extract insights, AI researchers who push the boundaries of AI knowledge, AI ethicists who help ensure responsible AI development, NLP specialists who work on language based AI, and computer vision engineers who develop systems that can see. These roles typically require a strong foundation in computer science, mathematics, and statistics, as well as specialized knowledge in AI related areas. Let's move on to the next topic, which is Gen AI or Generative AI. Generative AI or Gen AI is a type of artificial intelligence that creates new original content like text, images, audio, and video. It learns patterns from vast amount of existing data to generate novel outputs that resembles the data it was trained on. The next question is, how do these models achieve such a feat? It happens in two main phases. First, the learning, the distribution phase. The model is fed vast amount of existing data, perhaps millions of images, articles, or audio clips. It meticulously analyzes this data to understand its statistical properties and hidden rules, and the fundamental patterns that define it. For example, when I'm learning about human faces, it understands things like a common placement of eyes, nose, and mouth, and how they can relate to each other. Once it has learned this deep understanding, we move to the generating new samples phase. The model can then sample from this internal representation. It does not just copy and paste, it uses its learned understanding to originate new data instances that are statistically similar to what it was trained on, making them appear incredibly realistic and novel. To truly grasp generative AIs, it's essential to understand how it stands apart from discriminative AI. Let's look at a quick comparison. For learning objective, discriminative AI aims to map inputs to specific labels or values. It learns the boundary between different categories. Generative AI, on the other hand, aims to model the underlying data distribution. It learns the entire data space. Regarding the output type, discriminative AI output is typically a prediction, a classification, or a score. Think of yes or no, cat or a dog, or even any numerical value. Generative AI's output is a new data itself. This could be a new image, a new piece of text, a new sound, or a new code. The question it asks is also differs. You can imagine discriminative AI asking, what is this? Or is this X or Y? Generative AI is asking, what could this be? Or more directly, create something like this. Finally, their prime task diverge. Discriminative AI's primary task as prediction, classification, and regression, while generative AI's primary tasks are generation, synthesis, and data augmentation. This fundamental distinction highlights their different purposes and approaches. Let's solidify this with some concrete examples. For discriminative AI, a image recognition system that tells you this is a cat in a photo, it identifies what's already there. A spam filter classifies an incoming email as either spam or not. It distinguishes between two categories. A fraud detection system predicts if the credit card transaction is fraudulent based or historical patterns. Now, for generative AI, instead of just identifying if it's just a cat or a dog, generative AI can create a completely new image of a cat that has never existed before. Perhaps a cat wearing a tiny hat. Instead of just filtering spam, it can write an entirely new email draft for you from a few keywords. For a fraud detection, generative AI can synthesize new realistic but fake transaction data to train a discriminative fraud detection model more effectively, especially if the real fraud data is scarce. These examples clearly show the shift from analysis to creation. The capabilities of generative AI are truly vast and continue to expand. It's moving far beyond just predicting outcomes to actively shaping and creating the digital world around us. Here's a glimpse at the spectrum of what generative AI can accomplish. It can generate human-like text, astonishingly realistic images, functional code, natural sounding speech and audio, and even dynamic video. Beyond direct content creation, it's also incredibly powerful for data augmentation, which is crucial for training other AI models. Let's dive into each other capabilities. First up, we have text generation or natural language generation, which is NLG. This is one of the most recognized capabilities today, powering much of the public's interaction with AI. Generative AI models can produce human-like text on various topics in various styles. Some of the use cases are wide-ranging, from content creation like generating articles, blog posts, marketing copy, or social media updates, to summarization, condensing long documents. It's behind smarter chatbots and virtual assistants enabling more natural and coherent conversations. And it's a powerful tool for creative writing, helping with poems, stories, or scripts. Next, we have generating images or visual creation. This is perhaps where generative AI has captured the most public imagination. These models can create entirely new images, photos, and artistic works from simple text description or modify the existing ones. Some of the use cases include art and design for generating unique artwork, illustration, or concept art, product prototyping, rapidly visualizing product variation, or architectural designing. It is also used in photo editing, which performs tasks like image implanting, which is filling the missing parts, style transfer, and upscaling resolution, and even creating realistic textures and environments for virtual worlds in gaming and simulation. Generative AI is increasingly powerful for generating code, effective automatic parts of the development process. AI can act as a programming assistant, generating code snippets, functions, or even basic programs based on natural language description or the context of your existing code. Some of the use cases include code completion, which is auto-suggesting lines of code as you type, significantly speeding up the development. It also fixes bugs, identifying comma errors, and purposing correction. And also we are boilerplate generation, creating standard function structures, class definitions, or common configuration, and transforming natural language to code, allowing developers to describe what they want in plain English, and the AI converts into functional code. Now let's talk about generating speech and audio or voice and sound synthesis. This capability allows AI to produce realistic human speech, compose original music, and generate diverse sound effects. Some of the use cases include text to speech, converting any written text into natural sounding speech, perfect for virtual assistants, audiobooks, or narrations. It is also used for voice cloning, which replicates specific voice. It also includes music generation, composing original melodies, harmonies, or even full instrumental tracks, and creating custom sound effects for games, films, or user interacts. Imagine having a AI narrator your presentation slides or compose a unique background score for your video. This is a new power of audio generation. The most complex but rapidly advancing capability is generating video, which enables dynamic content creation. This involves producing new video content, animating still images, or manipulating existing video footage to create dynamic and compiling sense. Some of the use cases include video synthesis, which is creating short video clips from text, description, or images. And it also plays a vital role in animations, assisting animators by generating character movement, lip syncing. This capability also is in virtual avatars, generating realistic talking head videos from text, and advanced special effects, enhancing or altering video content in ways previously thought impossible. While still a frontier, the process in AI video generation is astonishing, allowing for unexpected creative control. Finally, let's discuss data augmentation, a critical behind the scene capability that enhances the performance of other AI models. Data augmentation is a process of increasing the amount and the diversity of the training data. Generative AI plays a vital role here by creating modified versions of existing data or more powerful synthesis entirely, which is new realistic data that adheres to the patterns learned from the real data. Why is it even important? It overcomes data security when real world data is limited. It provides model robustness by making models less sensitive to minor variations. It helps address data imbalance, ensuring models learn effectively from underrepresented categories. And it's crucial for privacy, allowing the use of synthetic data when the real data is sensitive. Generative AI helps teach other AI models by creating more varied and comprehensive learning material. Let's see some examples where I'm going to create images and videos from a prompt.
NLP in the next 10 minutes. So what can you expect from this video? What's in it for you? First, we'll give you a basic understanding of NLP. We'll tell you why we need NLP and we'll talk about what NLP exactly is. Next, we'll look at NLP pipelines. NLP pipelines cover the basic processes involved in text passing in NLP, which means converting text to a form suitable for machines to understand as humans would understand it. And finally, we'll talk about some real-world applications of NLP which are all around us and a lot more common than you might have realized. So, let's get started. So what exactly is NLP? Before we talk about NLP, let's talk about how humans talk and interact with each other. Humans communicate with each other mostly via speech or text. To convey your intent to someone, you may directly talk to them or send them a message. The human way of communicating is known as natural language. Around the globe, many languages are spoken and messages are shared virtually every single day. All these conversations, feedbacks, and messages are data in themselves. This data is extremely valuable as it can give us customer information and insight into human sentiment. However, this data is not useful to computers as it is not in a form that can be understood by machines. Machines communicate using ones and zeros and not via words. They cannot understand English, French, or Spanish, only binary. And this is where NLP comes into the picture. NLP stands for Natural Language Processing. Natural language processing is a branch of artificial intelligence that deals with the interactions between humans and computers using the natural language. The ultimate objective of NLP is to read, decipher, understand, and make sense of human languages in a manner that is valuable, and to build systems that can make sense of text and perform tasks like translation, grammar checking, or topic classification. NLP basically is the task of processing written forms of languages and making a computer understand them. Companies are increasingly using NLP-equipped tools to gain insights from data and to automate routine tasks. A sentiment analyzer, for instance, can help brands detect emotions in text, such as negative comments on social media. NLP at the end of the day is nothing more than a accumulation of artificial intelligence, computer science, and the human language. The next topic that we'll be looking at are NLP pipelines. So what exactly are pipelines? A pipeline is a set of data processing elements which are connected in series, where the output of one element is the input of the next one. It basically represents the various steps which have to be taken in a computation and the order in which they occur. In this pipeline, we are going to be parsing our data. Parsing means converting our data from one form to another. In this case, we are parsing our input text data to a file which can be understood by a computer. The text is first broken into segments, and the segments are then converted into even smaller tokens. The word stems of all of these tokens are found, followed by finding the root words of these stems in a process known as lemmatization. We will then recognize which part of speech the word belongs to, which means if the word is a verb, a noun, or a pronoun. And finally, we will separate the instances of everyday popular entities from our words to better understand what the sentence is trying to convey. The final file that we'll get will be a file which will be understood by a computer. Segmentation. The first process of a pipeline is segmentation. Now, what exactly is segmentation? Sentence segmentation or text segmentation is basically dividing the given text into logically decipherable units of information. We divide the sentence into its constituent sub-sentences, usually along the punctuations like full stops or commas, or along line breaks and page components for HTML files. Dividing a document into its constituent sentences allows us to process it without losing its essence and the necessary information that it contains. In this case, let's consider a sentence, "The lemonade quenched her thirst but not her longing." After sentence segmentation, we are going to divide the sentence into two. The first sentence is going to be "The lemonade quenched her thirst," and the second one is going to be "but not her longing." The next step of our pipeline is called tokenization. Tokenization is nothing but the process of dividing a sentence into its constituent words. The sentence that is given to us will be separated and all the words in the sentence will be stored separately. This is done so we can understand the syntactic and semantic information contained in each sentence. Thus, we decipher the relevance of a sentence by analyzing it word by word, thereby making sure that no loss of information occurs. The computer does not understand punctuations and special characters. Hence, we can remove any punctuations and special characters which may occur. Let's take a part of a previously segmented sentence. Over here, let's consider the lemonade quenched her thirst. After tokenization, we are going to separate every single word in this sentence. So, after tokenization, we are going to get 5 different tokens: the, lemonade, quenched, her, and thirst. All of these are going to be treated as separate entities. After tokenization, we perform stemming. Stemming is a process of obtaining the word stems of a word. Word stems are also known as the base form of a word, and we can create new words by attaching affixes to them in a process known as inflection. Stemming is a process of recognizing the word stems of individual words. This is done by removing affixes such as ing, s, ed, etc. For example, consider our sentence jump. Jump is the word stem of various different words like jumping, jumped, and jumps. If we remove all of these affixes, we will get our basic word stem, which is jump. This is basically what we want at the end of stemming. The next process in our pipeline is called lemmatization. Lemmatization is the process of figuring out the root form or root word, which is nothing but the most basic form, also known as the lemma, of each word in the sentence. Lemmatization is very similar to stemming, where we remove word affixes to get the base form of a word. The difference is that the root word is always a word which is present in the dictionary, but the root stem may not be so. Lemmatization uses a knowledge base called WordNet. Let's consider 3 different words: went, going, and gone. At the end of the day, all of these words have originated from a single word, which is go. In this case, go is our lemma. All the other words which are derived from go can be traced back to it. The next part of our pipeline is called part of speech tagging. Part of speech tagging is a process of converting a sentence to different forms. It can be a list of words or a list of tuples. The tag in case of is a part of speech tag and signifies whether the word is a noun, adjective, verb, and so on. We are basically splitting our verbs into their grammatical components. To understand the meaning of any sentence or to extract relationships and to build a knowledge graph, part of speech tagging is a very important step, as the same word can have different part of speeches in different sentences. For example, let's consider the sentence, give me your answer. In this sentence, answer is a noun, but if we consider another sentence, answer the question, over here answer will be a verb. Using part of speech tagging, we can take our different tokens and find the different part of speech that it belongs to. In this case, the is a determiner, lemonade is a noun, quenched is a verb, her is a pronoun, and thirst is a noun. The final step in our NLP pipeline that we are looking at here is nothing but named entity recognition. Named entity recognition, also known as named entity identification, entity chunking, and entity extraction, is a subtask of information extraction that seeks to locate and classify named entities which are mentioned in unstructured text into predefined categories. Extracting the main entities in a text helps us sort unstructured data and detect important information, which is crucial if you have to deal with large data sets. The subcategories that we are considering are person, whether the named entity is a person, whether it's a quantity like kilograms, a location, an organization, the name of a movie, or whether it's a monetary value like dollars or euros. So far, we've looked at what NLP is and how we can perform natural language processing. But what are some applications of it and where is it used in the real world? One of the applications of NLP is in chatbots. Chatbots can help you solve issues while performing natural language generation. In other words, they can hold a conversation in plain English. A chatbot is nothing but a software application which can be used to conduct an online chat conversation, either through text or speech, in place of providing direct contact with a live human agent. You might have seen those "talk to one of our agents" section on websites. Those are usually chatbots. A lot of companies also use WhatsApp chatbots to make the process seem less mechanical. Another application of NLP is speech recognition. Probably the most popular example of NLP in action are virtual assistants like Google Assist, Siri, and Alexa. Natural language processing understands and translates the human language, like "Hey Siri, where is the nearest gas station?" into numbers, making it easy for machines to understand. They recognize when you are talking, converting speech to text, and understand what you requested. Over the years, virtual assistants have become streamlined enough to be able to emulate human speech patterns almost flawlessly. Another application of NLP is autocorrection. Autocorrection, also known as text replacement, replace as you type, or simply autocorrect, is an automatic data validation function commonly found in word processors and text editing interfaces for smartphones and tablet computers. It acts as a spell check and corrects any spellings or grammar mistakes which may arise as you are typing. Some language check softwares like Grammarly, Paperator, Reverso, and others can even check how unique and engaging your articles are. And all of this is done using NLP.
So as you can see, I have headed over to the homepage of InVideo AI. So I would say that InVideo AI is a fantastic tool for creating high quality videos and personally my favorite. Directly from your text prompts or images, it's incredibly versatile. So we'll just see from this navigation bar here. So we have got these plugins of voices, text to clip, text to image. So we'll just be clicking on text to clip from here because we want to generate. So we'll just be clicking on this create AI video from scratch, and after we click on this, we have to provide a topic or any detailed instruction of what video you want to create. So we also have this other option of creating a short video, whether your topic is about making an explainer video, or if you want to create an animated film, or you want to just simply use your script or whatever. So right now we will just be giving off a prompt, a cat sneaking out of the house and exploring the city from its point of view. And this is the visuals I would want to show, sneaking into the fish market and then returning home just in time. So I will say I'll just create, and if you want to create an animated film, but then we don't have this in our free version. So we'll just be clicking on generate video from here. And we'll wait for a few seconds. Now, as you can see, it is analyzing our video from here. So after it has analyzed, it has also given a title name of like the secret life of a sneaky cat mission tune, and this is really impressive. And then from here, we'll just select on the visual style, whatever visual style you want, whether it's realistic, animation, anime. So I'll just click on realistic, and I want my video to be under 30 seconds. And in which platform are you wanting to post your video? So I'll just click on YouTube Shorts, and I'll just be clicking on continue. So you can see you have this plus version where you can select any visual style you want, which is $35 per month. Now we will be using the free version, so we can just proceed with the stock media, and then we'll just continue. We'll wait for a few seconds till our video is being created fully. So now that our video is being created, I'll just play and show you our video.
If your cat's got a secret agent vibe, you're in for a wild ride. Meet Whiskers, our fearless feline adventurer. Today, he's sneaking out for a top-secret mission, exploring the bustling streets of Bengaluru. First stop, the rooftops. Whiskers leaps from one to another like a furry superhero. He pauses, tail twitching, spying on the world below. Next, it's the classic car dodge. Whiskers weaves through the traffic like a pro, earning his stripes as a street-savvy kitty. Meow-nificent. What's this, the fish mark?
So now that you see, the result is really impressive and it's really amazing. Within just a single prompt, just a text, you can create a wholly working video in front of you, and I personally liked it the most.
So first we'll see what is prompt engineering. So let's demystify what prompt engineering actually is. In the simplest terms, it's the art and science of crafting inputs or prompts to effectively communicate with AI models like GPT-3, DALL-E, and others. It's about being precise, creative, and strategic to elicit the best possible responses. But why does it matter? Well, with the right prompt, you can unlock the full potential of AI, from generating artistic masterpieces to solving complex problems. Let's break it down into the basics. A good prompt should be clear, concise, and directed. And you should avoid ambiguity and be as descriptive as necessary. Remember, you are guiding the AI to understand exactly what you want. Here's where the magic of prompt engineering really comes into play. By tweaking just a few words, you can dramatically change the output. As you delve deeper into various instances and uses of prompt engineering, it becomes evident that a prompt is composed of several key components. And now, we'll see those components. A prompt may include any combination of the following components, that is, instruction, a precise action or directive you wish the model to execute. And then comes context, that is, background information or supplementary context that can guide the model towards more accurate responses. And then we have input data, the specific inquiry or data for which you seek a response. And then comes output indicator, the desired structure or nature of the response. Not all four components are necessary for every prompt, and their utilization varies based on the specific task. We will explore more detailed examples in the future tutorials. So, are you ready to level up your prompt engineering skills? Here are some pro tips. Use specific and detailed language, experiment with different phrasings, and consider the model's limitations. And don't forget to iterate. The best prompt engineers constantly refine their prompts based on the AI's responses. Alright, it's time to put theory into practice. I will walk you through a live demonstration of crafting prompts for different scenarios. Watch closely as I adjust the wording and structure to achieve the desired outcomes. Feel free to follow along with your own AI tool. So here we will use the ChatGPT, and that is the GPT-4 version. And before starting, I want to tell you that even experts make mistakes. Here are some common pitfalls to avoid in prompt engineering. Overcomplicating your prompt, being too vague, or misunderstanding the AI's capabilities can lead to unexpected and sometimes hilarious results. Learn from these missteps to perfect your technique. So now we'll start with the demo, and first we'll open our ChatGPT. So let's start with the first prompt, and we name it as text condensation and refinement. So in this, text condensation is a critical skill that is used in natural language processing and serving as a broad spectrum of domains. Among the most exciting applications for language models is their ability to distill complex models and complex articles and concepts into brief, easy to understand summaries. Let's dive into an enhanced text condensation exercise using prompts. Suppose you are curious about the role of antioxidants in the body. You might craft a prompt like this, that I will write, summarize the role of antioxidants. So now let's see what our ChatGPT gives us the output. So you can see that the ChatGPT has completed its response, and to refine this information further, you might instruct the ChatGPT or your model to encapsulate the essence in a shorter format. So for that, you can write a prompt that use the above context and summarize this into some 100 words or some 200 words, or just condense this into a brief explanation. So we will do that. So now you can see that the ChatGPT has taken our query or the prompt, and it has condensed the above content into a brief explanation. So accordingly, you could use different prompts. And now we'll move to DALL-E and we'll generate a image, and here we'll use the condensed format only to give a prompt to DALL-E. So we'll write generate a highly detailed image of a futuristic city, and we can specify what time of day we want that at dusk, and featuring towering skyscrapers with glowing windows or flying cars and a sky filled with neon colored clouds. So we can give the prompt or generate prompt like that only. So we will write the prompt for that, that is detailed image of a futuristic city, and here we'll specify the time for the day, that would be at dusk, and featuring towering skyscrapers with glowing windows, flying cars, and what you need to specify, you could do that. So let's see what DALL-E respond to us, and you could see that it's repeat, and you could see that DALL-E is creating image now with the prompt we entered, and this is the response. So it has given us that here are the images of the futuristic city at dusk, featuring towering skyscrapers with glowing windows, flying cars, and a sky filled with neon colored clouds. You could see the picture here. So similarly, you can give prompts to DALL-E or any other AI tool, and you can get the output as expected, and you can iterate your prompts according to the AI's capabilities. And now moving back to ChatGPT. So here we will come to another type of prompt, that is information synthesis and retrieval. So these language models excel not only in language generation but also in extracting and synthesizing information from text. So we will consider this prompt that is designed to pull specific details from a given narrative. So we will ask it that researchers often use various AI tools including LLMs like OpenAI's GPT in their studies. So I have a prompt written, we will use that, and let's see what ChatGPT gives the response for this prompt. So you could see here that researchers often use various AI tools including LLMs like OpenAI's GPT in their studies. A transparent disclosure of these tools helps maintain integrity in specific publication. So it's important for authors to disclose the context and extent of AI assistance in their research, and journals should be upfront about their AI usage in the review process. So identify the specific LLM, that is large language model, mentioned in the text. So let's see if he can guess. So you could see that ChatGPT has given the response that the specific language model LLM mentioned in the text is OpenAI's GPT. So this was about the prompt information synthesis and retrieval. Now moving to the next prompt. So our next prompt here is enhanced query response. So optimizing how models respond to queries involves crafting more intricate prompts that guide the AI to deliver precise and useful answers. So for this we'll write a prompt that would be provide an answer based on the context given. So be succinct and clear. If uncertain, respond with cannot confirm. So we'll write the prompt for this, and I have written the prompt earlier. So I'll show you guys. This is the prompt, and we'll ask ChatGPT about the enhanced query response. So we have pasted the prompt here, and our prompt is provide an answer based on the context given, that is be succinct and clear. If uncertain, provide with cannot confirm. So our prompt is here, the innovative drug Alzamab was developed as a result of collaborative efforts between several biotech firms. So this drug aimed at treating autoimmune disorders represent a significant breakthrough in biomedicine. So we'll ask the ChatGPT the question, what is the purpose of Alzamab? So let's see what it responds to us. So you could see that the ChatGPT has responded, the purpose of Alzamab is to treat autoimmune disorders. So this is the type of prompt that is named as enhanced query response. So it optimizes how models respond to queries, involve crafting more intricate prompts that guide the AI to deliver precise and useful answers. So now we'll move to the next type of prompt, that is advanced text categorization. So to handle more complex tasks, combining detailed instructions with context and examples can significantly enhance the model's performance. So here we will write the prompt to assess the sentiment of the following statements. So we'll write some statements and ask a ChatGPT or AI model to assess them and classify them as negative, positive, or neutral. So let's see, we'll write a prompt here. Assess the sentiment of the following statement as positive, negative, or neutral. And after this, we will provide a statement to ChatGPT. So our statement would be, the movie's stunning visuals overshadow its weak storyline. So let's see how ChatGPT classifies this statement as positive, negative, or neutral. So you could see that the ChatGPT has generated its response, and it stated that the sentiment of this statement, the movie's stunning visuals overshadow its weak storyline, is mixed. It acknowledges a positive aspect, that is stunning visuals, and a negative one, weak storyline. So you could see here that the ChatGPT can be used for sentiment analysis. So you could provide statements and ask ChatGPT whether it's positive, neutral, or negative. Now moving to the next prompt. So our next prompt is dynamic conversations. So creating conversational systems that adapt to various tones and complexities is a fascinating application of prompt engineering. So here's how you might design a system to provide simplified, friendly response. So for this, we'll write a prompt and let's see what your AI model and our ChatGPT will give a response. So this is a conversation. So here we'll write a prompt and start a conversation with our AI model. So first we'll write, hi there, what's your role? So let's see what it responds. So as our AI model ChatGPT, it states that, hello, my role is to assist you by providing information, answering questions, and helping with a wide range of tasks. How can I assist you today? So you can continue the conversation here, and we'll continue and ask him whether you know about photosynthesis. If yes, kindly explain it to me. So you could see that our ChatGPT has started generating the response, and it has stated that yes, I can explain photosynthesis, and it's a process used by plants, algae, and certain bacteria to convert light energy, usually from the sun, into chemical energy. Repeat. Usually from the sun into chemical energy, and it is giving us some examples. You could go through that and you can continue your conversation with your AI model. So this is the another kind of prompt. Now we'll move to the next prompt type, that is the innovative code generation. So expanding on the potential of LLMs, that is large language models, in code generation, let's explore a more intricate example, that is we'll ask them to write a code for us. So we'll write a prompt that would be, write a Python function that calculates the factorial of a number and prints the result. So let's see what our ChatGPT will respond to this. So you could see that ChatGPT is showing analyzing. So it's analyzing a statement, and after that it will start generating the code for us. And you could see that it has generated the code, and It has the prompts or the statements that explain the code itself. So if you want this code as understandable, you could ask the ChatGPT to explain it line by line. And you could see that the ChatGPT has done the task for you. So you could see that it has completed its response and it has explained each line of the code with all the necessity concepts. So moving now, so these enhanced prompts and examples showcase how versatile and powerful language models can be, and within well-structured and throughout instructions. As we continue to explore and experiment with these prompts, the potential for creating sophisticated, nuanced, and highly functional AI-driven applications become increasingly evident. So these are the types of prompts you could try on.
Let's move on to the next topic, which is building AI powered chatbots without programming. For many, the idea of building AI powered chatbot might immediately conjure images of complex code and specialized programming languages. But I'm here to tell you that the landscape has fundamentally shifted. Today's generative AI and no code tools mean that sophisticated chatbots are no longer exclusive domain of developers. You can go far beyond simple question and answer bots, building dynamic intelligent assistants. Our focus is on empowering you with the job ready skills that businesses are actively seeking. Skills centered around understanding user needs, designing logical conversational flows, and integrating various AI components, all without needing to write a single line of code. So, why are businesses so eager to adopt AI powered chatbots? The benefits are compelling. Firstly, they are offer 24/7 availability, meaning your customer can get answers or assistance around the clock regardless of time zones. This leads to improved efficiency as routine inquiries and tasks are automated, freeing up your human customer service agents to handle more complex or sensitive issues. The result is significantly enhanced customer experience, faster response, consistent information, and reduced wait time. All of this contributes to cost reduction and allows businesses to scale their customer service operations without proportional increase in staffing. One of the most powerful ways to elevate your chatbot is by embedding an AI powered recommendation system. This moves your chatbot beyond generic responses to truly personalized customer services. So, what exactly are recommendation systems? They are AI algorithms that analyze data to suggest relevant products, services, or information to individual users. In a no code chat environment, this means you configure your chatbot to listen for cues from the users. Perhaps they started preferences, browse history if integrated, or previous interaction, and then using predefined rules or simple integrations, the chatbot platform displays tailored suggestion from your product or service catalog. The benefits are clear. Increased sales through targeted recommendation, improved user satisfaction because they feel understood, and the ability offer proactive help assistance. Now let's talk about building complex workflows. This is where your chatbot really comes alive and handles diverse user needs beyond a simple back and forth. A workflow is essential the structured part of a conversation that based on user inputs and system logic in no-code platforms. You will be working with key elements like intents which help AI understand the user goals. For example, I want to check my order status. Then there are entities to check my order status, which are pieces of crucial information extracted from the user's request like an order number. Based on this, the chatbot performs actions which could be displaying information, asking follow-up questions, or even connecting to an external system. All of this is driven by conditional logic. Essentially, if the user says X, then do Y. Throughout this process, Rigorous testing is absolutely crucial to ensure smooth, logical, and error-free interaction. Designing complex workflow is an art form. It often stays with mapping out conversation, literally drawing out potential user journeys and how your chatbot will respond to each step. You will then move to prototyping, building early versions to test the core functionalities. For testing, don't just rely on yourself. Engage in self testing by running through every possible scenario you can think of. Then do peer testing. Ask colleagues to try and break your boat by asking unusual questions or trying unexpected paths. If possible, involve user acceptance testing, which is UAT, with actual end users to gather authentic feedback. This entire process is highly interactive. You'll continually refine your chatbot based on insights gained from testing, ensuring it's robust and user friendly. Finally, the moment of truth, deploying your chatbot in a real world scenario. This involves several key steps. First, you will need to choose the right channel where your target audience communicates. Whether it's your website, Facebook Messenger, WhatsApp, or other platform, no platforms make integration incredibly straightforward, often requiring just a simple copy paste of the embedded code or configuration of an API key. Once live, it's crucial to monitor your chatbot's performance, tracking user interaction, identifying common queries, and spotting any errors. Chatbots are not set it and forget it. They require ongoing maintenance, updates to content, and continuous improvement based on real user data. And always remember to consider security and privacy, especially when handling sensitive customer information, even when you're writing the code. Here are some of the platforms that provide intuitive drag and drop interface where you can build conversational flows, connect to data sources, and deploy your chatbot on websites, apps, or messaging platforms. Here are popular no-code chatbots builders. Each one has its pros and cons. TDO is great for customer support and lead generation. It can integrate with website, messenger, Instagram, and more. It also offers templates and AI-based responses. Whereas Chatfuel is popular for Facebook Messenger bots, it is ideal for e-commerce and customer engagement. ManyChat focuses on marketing and sales bots. It also works well with Messenger, Instagram, and WhatsApp. Landbot has powerful drag and drop builder. It can create web-based chatbots and WhatsApp bots. It's a clean UI for designing chat experience. Coming to WordPress Cloud, it offers AI capabilities and multilingual support, ideal for more complex workflows with integration. Let's just give a short look on how TDO makes chatbot available without using any code. So as you guys can see, this is TDO. So initially, it is going to ask you an email and what is the purpose of your visit, what you are wishing to create, whether it's a chatbot or a messenger integrated with chatbot, Instagram used for Instagram or WhatsApp chats. So here I'll give you a small example of how easily you can create a chatbot. So there is an inbuilt Lyro AI agent here. So these are the steps you need to follow to create a chatbot. So it includes adding the knowledge by providing the URL of your site. So you have to add on which site this chatbot is going to go. So I'll give Simplilearn website. I'm just going to press import knowledge so it gets all the information of the website. So you can chat with the Lyro, which is an AI chatbot created by TDO. It will take some time. It will assess all the links related to simplilearn.com. It is accessing all the pages under simplilearn.com, whether it's the contact us page or about us page, every information it should be knowing. So now the AI is getting trained, the chatbot is getting trained. So after this is done, you can move on to test Lyro. If you do not want any particular link to be accessed in this data, you can just click here and delete it. So since I don't want, and I'm going to test the chatbot now, whose name is Lyro. So here's the chatbot. So here it is saying, hi, how can I help you? So here are pre-built question. So it is okay for you to choose and test the knowledge. So you can see it is providing questions and answers. So let me type in something specific to see if the knowledge is there. And I'm going to send this. Let me see if it will suggest any course which will upskill my current position. So yeah, to recommend the most suitable course, you could please tell me your current position or field of work. We offer various specializations. So it's asking me input. So I'll say my current position is data analyst. So it has suggested me few of the courses. For your data analyst role, I recommend for our business analyst course featuring Excel and Power BI training and Tableau certification. These courses will enhance your data visualization and analysis skills. Or it is regarding alumni also, and the salaries and the certification, every information is being provided. So this you can integrate to your original website and you will have a chatbot without even coding one single sentence. As we conclude AI Foundation for everyone, I hope you feel not just informed but empowered. You have gained a fundamental understanding of what AI is, explored incredible creative power of generative AI, learn how to communicate effectively with these models through prompt engineering, and discover how to build practical AI-powered chatbots, all without writing a single line of code. The world of AI is constantly evolving, but you have a solid foundation to navigate it confidently. Remember, AI is a tool, and with the knowledge you have gained, you are better equipped to leverage its potential, responsible, and creativity. Thank you for being a part of this journey. We encourage you to continue exploring, experimenting, and applying what you have learned. The future is exciting, and you are now a part of it, shaping it. We look forward to seeing amazing things you'll achieve.
Today, we'll take you through the exciting roadmap of becoming an AI engineer. If our content piques your interest and helps fuel your curiosity, don't forget to subscribe to our channel. Hit that bell icon so you never miss an update. Now let's embark on this AI journey together. As artificial intelligence continues to revolutionize various industries, AI engineers stand at the forefront of this technological wave. These professionals are essential in crafting intelligent systems that address complex business challenges. AI projects often stumble due to poor planning, subpar architecture, or scalability issues. AI engineers play a crucial role in overcoming these hurdles by merging cutting-edge AI technologies with strategic business insights. So in this video, we'll guide you through the essentials of becoming an AI engineer. Let's start with the basics. What does an AI engineer do? An AI engineer builds AI models using machine learning algorithms and deep learning neural networks. These models are pivotal in generating business insights that influence organizational decision making. From developing applications that leverage sentiment analysis for contextual advertising to creating systems for visual recognition and language translation, the scope of an AI engineer's work is vast and impactful. So to succeed as an AI engineer, you need a blend of technical prowess and soft skills. So now let's break down this 8-month plan. Month 1, Computer Science Fundamentals and Beginners Python. So before we delve into AI, it's crucial to establish a strong foundation in computer science. This month, you should focus on the following topics. Data representation. Understanding bits and bytes, how text and numbers are stored, and the binary number system is foundational for everything in computing. This knowledge helps in comprehending how computers interpret and process data. Now next comes computer networks. Learn the basics of computer networks, including IP addresses and internet routing protocols. It's essential to understand how data travels across networks using UDP, TCP, and HTTP, which form the backbone of the internet and the World Wide Web. Next comes programming basics. Begin with the basics of programming like variables, strings, numbers, conditionals, loops, and algorithm basics. These fundamentals will allow you to write and understand simple programs. Simultaneously, you'll also start with Python, the preferred language for AI. So learn about variables, numbers, strings, lists, dictionaries, sets, tuples, and control structures like if conditionals and for loops. And then move on to functions and modules. Understand how to create functions, including Lambda functions, and work with modules by using pip install to add functionality to your projects. Next comes file handling and exceptions. You should also practice reading from and writing to files, as well as handling exceptions to make your programs more robust. Finally, grasp the basics of classes and objects, which are crucial for writing organized and efficient code. So this comprehensive overview sets the stage for more complex programming tasks that you'll encounter in the following months. Now in month 2, you'll move on to data structure algorithms and advanced Python. So building on the foundations from month 1, we'll now delve into data structure and algorithm. So familiarize yourself with the concept of big O notation to understand the efficiency of different algorithms and data structures. Learn about arrays, linked lists, hash tables, stacks, queues, trees, and graphs. Mastering these structures will allow you to store and manipulate data effectively. Now next comes algorithms. You should explore algorithms such as binary search, bubble sort, quick sort, merge sort, and recursion. These are essential for optimizing your code, and parallelly you'll advance your Python skills. So you can dive into inheritance, generators, iterations, list comprehensions, decorators, multi-threading, and multiprocessing. These topics will enable you to write more efficient and scalable code. So this month's learning prepares you to handle complex data operations and enhance your coding efficiency. Now in month 3, you'll move on to version control, SQL, and data manipulation. So in the third month, the focus shifts to collaboration and data management. Number 1, version control. So understand the importance of version control systems, especially Git and GitHub. So learn basic commands such as add, commit, and push. You should also learn how to handle branches, reword changes, and understand concepts like head, diff, and merge. So these skills are invaluable for tracking changes and collaborating with other developers. Next, pull requests. Master the art of creating and managing pull requests to contribute to collaborative projects. Next, we'll dive into SQL for managing databases. So first, we'll start with SQL basics. So learn about relational databases and how to perform basic queries. And then you'll move on to advanced queries. Understand complex query techniques such as CTEs, subqueries, and window functions. And then comes joins and database management. So study different types of joins like left, right, inner, and full join. You should also learn how to create databases, manage indexes, and write stored procedures. Additionally, you will use NumPy and Pandas for data manipulation and learn basic data visualization techniques. This comprehensive skill set will be crucial as you move into more advanced data science topics. So now in month 4, you'll deal with maths and statistics for AI. So mathematics and statistics are the backbone of AI, and this month is dedicated to these critical subjects. So first, learn about descriptive versus inferential statistics, continuous versus discrete data, nominal versus ordinal data, measures of central tendency like mean, median, mode, and measures of dispersion like variance and standard deviation. After that, understand the basis of probability and delve into normal distribution, correlation, and covariance. After which, you should move on to advanced concepts. So you can study the central limit theorem, hypothesis testing, p-values, confidence intervals, and so on. In parallel, you should also study linear algebra and calculus. So in linear algebra, learn about vectors, matrices, eigenvalues, and eigenvectors. And in calculus, cover the basics of integral and differential calculus. So this mathematical foundation is essential for developing and understanding AI models, setting you up for success as you transition into machine learning. Now in month 5 comes exploratory data analysis, which is EDA and machine learning. So with a solid foundation in math and statistics, you are now ready to delve into machine learning. Number 1, pre-processing. Learn how to handle NA values, treat outliers, perform data normalization, and conduct feature engineering. You should also understand encoding techniques such as one-hot and label encoding. You'll also explore supervised and unsupervised learning with a focus on regression and classification, and learn about linear models like linear and logistical regression and non-linear models like decision tree, random forest, etc. And then understand how to evaluate models using metrics such as mean squared error, mean absolute error, MAPE for regression and accuracy, precision recall, etc. Then comes hyperparameter tuning. Learn about techniques like grid search CV and random search CV for optimizing your models. After which, you'll move on to unsupervised learning. Here you can study clustering techniques like K-means and hierarchical clustering and delve into dimensionality reduction with PCA. So this month's focus on EDA and model building will prepare you for more complex AI applications. Transitioning to the next phase, you will begin to work on deploying these models and real-world scenarios. So in month 6 comes ML Ops and machine learning projects. So this month will cover the operational aspects of machine learning and work on practical projects. So in ML Ops basics, learn about APIs, particularly using Fast API for Python and server development. understand DevOps fundamentals, including CI/CD pipelines and containerization with Docker and Kubernetes. You should also gain familiarity with at least one cloud platform like AWS or Azure. Now, in month 7 comes deep learning. So, in this month, we delve into the world of deep learning. So, number 1 comes neural network. So, learn about neural networks, including forward and backward propagation, and build multi-layer perceptrons. After which, you'll move on to advanced architectures. So, here explore convolutional neural networks, which are CNNs, for image data, and sequence models like RNNs and LSTMs. So, this deep learning knowledge will be crucial as we move into specialized areas of AI in the final month. Now, in the final month, the 8th month, comes NLP or computer vision. So, the final month, you have the option to specialize in either natural language processing, NLP, or computer vision. So, first we'll level NLP track. So, here you should learn about regex, text representation methods like count vectorizer, TF-IDF, Bow, word2vec, embeddings, and text classification with naive Bayes. And familiarize yourself with the fundamentals of libraries like Spacy and NLTK and work on end-to-end NLP project. And talking about computer vision track, focus on basic image processing techniques like filtering, edge detection, image scaling, and rotation. Utilize libraries like OpenCV and build upon the CNN knowledge from the previous month. Practice data preprocessing and augmentation. So by the end of this month, you should have a solid foundation in your chosen specialization, ready to embark on your AI engineering career. So in conclusion, adopting AI is more than just a trend. It's a strategic move that can transform your organization's approach to machine learning. So do check out our professional certificate course in AI and machine learning, which is designed to equip you with the skills needed to excel in this dynamic field. Through live classes led by industry experts, masterclasses from IIT Kanpur faculty, and hands-on projects, you'll gain a competitive edge in AI. To enroll in this program, candidates should have a bachelor's degree with a 50% or higher average, preferably 2 or more years of work experience and foundational knowledge in programming and mathematics. Check out the course link in the description box below. So that's all for today's video on becoming an AI engineer. We hope you found this guide valuable and informative.
Have you noticed how AI is popping up everywhere lately? Like seriously, it's everywhere. And here's the thing. In just few months, everything is going to change. The folks making the big bucks, they won't be just coders or marketers anymore. It's going to be the people who really know how to work AI like a pro. Pretty exciting, right? Or maybe a little intimidating. Either way, stick around because I'm about to share the top 10 AI skills that will actually help you make serious money. I'll walk you through each skill in detail, what it is, how to get started, and even if you're a complete beginner, the kind of salary you can expect in both US and in India, and exactly how you can land jobs or freelance gigs using these skills. So let's get started. Alright, so let's talk about first skill, which is prompt engineering. Let's kick things off with a quick explanation. What exactly is prompt engineering? It's the art of crafting the right questions and instructions to get the best output from AI. Think of it like a genie, super powerful, but you have to be very clear about what you want. If you just mumble or ask vaguely, the answer won't help you much. But if you're precise and detailed, AI can deliver magic. For example, let's suppose you are typing to ChatGPT that write me a marketing plan. The ChatGPT will just give you some basic boring stuff. This might be frustrating, right? Now, instead of this, you can just try writing something like act a marketing expert and create detailed 3-month marketing plan for a fitness app targeting young adults. Now, suddenly you see you get a thoughtful, detailed plan tailored to exactly what you want. And this is called prompt engineering in action. Now let's talk about which tools do prompt engineers actually use. So the most popular and the most powerful tools right now are, first we have ChatGPT by OpenAI, which is the king of conversation AI, and it's perfect for experimenting with prompts. Then we have Jasper AI, which is great for marketing copy and blog posts with built-in prompt templates. Then we've got this OpenAI playground where you can test and refine advanced prompts with control over AI settings. These tools let you try out different prompts, tweak them, and learn how AI responds. This is super important for mastering prompt engineering. Now let's talk about what kind of jobs can you actually get with these skills. So prompt engineers work in various roles like AI content creator or specialist, chatbot trainer or developer, marketing strategist using AI generated campaigns, or an AI prompt consultant for businesses. And here's the juicy part, which is called freelancing. Now, how to freelance as a prompt engineer? Well, platforms like Upwork, Fiverr, freelancer have tons of clients looking for people who can actually write clear AI prompts to generate content or ideas, or train chatbots to answer customer questions better, and also create AI driven marketing or sales copy. You can start small, maybe helping a local business automate emails with AI or generating social media content using your prompt skills. And as you build your portfolio, clients will pay more. Now, let's have a look at some real world examples where prompt engineering actually shines. So, at first, we've got a startup which hires prompt engineers to generate hundreds of product descriptions every week, which saves hundreds of hours manually writing. Then we've got marketing agencies who use prompt engineers to create personalized email campaigns and social ads in minutes and not days. Then we've also got customer support bots, which are trained by prompt engineers to answer tricky questions correctly and politely. Now, the demand is only growing because AI is becoming a part of every business. Now, the question arises that how you can start learning prompt engineering. Well, you can just open ChatGPT and start experimenting. You can try different ways of asking the same questions, see what works better. Then you can practice telling AI to use act as different experts or personas. You can learn to include clear instructions about what format you want, like give me 5 bullet points or summarize in 3 sentences. Then you can also use free resources and tutorials online. OpenAI's website has great guides. Now, once you're confident, you can try freelancing small gigs to get hands on experience. Now, let's talk about money. Well, in the US, prompt engineers typically make between $60,000 to $120,000 per year, depending on experience and role. And in India, you can expect around 6 lakh to 12 lakh per year, with freelancing rates growing as AI adoption rises. And remember, guys, these numbers grow as you can gain expertise and you can build a reputation. Now, let's move on to a second skill, which is AI assisted app and software development, where you can build powerful apps without coding. Alright, here's some great news. You don't have to be a coding expert to build apps or software anymore. Thanks to AI and no code tools, anyone can now create apps that can solve real world problems and even make good money doing it. So there's one awesome AI tool here which is called GitHub Copilot. Now think of it as a helpful buddy sitting next to you, suggesting codes as you type and fixing mistakes before you even notice them. Then we've got no code platforms like Bubble and Directual, where you can actually drag and drop stuff to build apps. No coding needed at all. Seriously, you can now just create app fully functional app by just moving blocks around. Now, talking about how you can actually get started, well, you can have to just play around with no code platforms. You can take some time to learn how to build simple workflows and move things around on screen. Then the next step is you can just simply jump over to ChatGPT or similar AI chatbots, and then you can ask questions like, hey, how do I build a scheduling app on Replit? And it will give you step-by-step instructions, making it easy to follow. And your best part is to start small, build apps that solve specific problems like booking appointments, managing stock, or helping with sales. And guess what? You can even create apps that people pay monthly for. Now, let's talk about money. Well, in the US, people do this kind of AI assisted app development and they make around $100,000 to $200,000 per year. And in India, you're looking at around 12 lakh rupees to 24 lakh per year, and that can grow as you get better and take on more clients. So, if you want to build apps, automate tasks, or even start a small software business but don't know how to code, this skill is your golden ticket. Now, let's talk about a third skill, which is AI powered photo and video editing. So, whether you're creative at heart or just looking to start freelancing with real money on the table, this skill would be your total game changer. Now think about it. Photographers, influencers, YouTubers, and content creators are producing tons of photos and videos every day. But editing all that, it takes forever and can get pretty boring. And that's where AI comes in to do the heavy lifting and help you work faster and smarter. Let's say a photographer sends you 200 photos from a single shoot, doing all that editing manually, fixing the lighting, removing unwanted backgrounds would take hours and hours. But now with AI tools like Photoshop Generative AI Fill or Topaz Photo AI, you can enhance those photos quickly and professionally with just a few clicks. And talking about video editing, remember when video editing meant sitting for hours, cutting footage, trimming silences, and adding effects? And now AI editors like FlexClip in video can automatically pick out the best parts of your videos, and it can create short, engaging clips, which is perfect for TikTok, Instagram Reels, and even YouTube Shorts. Even cooler, some AI tools can create avatars, talking avatars, so you can just make videos without even recording yourself. Now, here's how you can just get started with freelancing in this skill, where you can set your profiles on popular freelance platforms like Fiverr, Upwork, or Freelancer and start offering AI assisted photo and video editing services. Now, make sure to highlight how you can deliver professional quality edits much faster than traditional editors, of course. And then you can package your services, let's say around get 15 hands photo delivered in 24 hours, viral ready video clips edited with AI magic, and don't forget building a reputation with fast turnaround and top-notch quality that will keep clients coming back. So I'll be showing you a video which I had created using AI functionally, just the AI tools, and it's pretty amazing. So I'll just play and show this
In the
video.
heart of the jungle, a young tiger cub feels unsure, wondering if it will ever find its roar. But wisdom walks softly. A gentle elephant shares words of strength and patience. With encouragement from friends, the cub begins to believe in its own power. On a sturdy rock, the cub takes a deep breath and lets out its very first roar.
Now you see the quality of the image and the video, and this is all just created using AI, the voiceover, the animations, and everything, even the story. So you can just check out my another video. I'll just mention in the description box how I created using the AI tools. So now let's talk about money, that how much you can actually earn. Well, in the US, you can freelance photo and video editors using AI, and they earn around between $60,000 to $170,000 per year, depending on obviously your skills and the client's base. And in India, if you're looking at around 6 lakh rupees to 16 lakh per year, and that can grow fast. This skill is your go-to choice. You can gain much more experience if you become an expert doing this using AI tools to create videos and even images. Now let's talk about a fourth skill on our list, which is AI agent development, building your AI employees. So let's talk about something really next level, AI agent development. Imagine you're creating AI agents which is working for you 24/7, handling tasks like qualifying leads or answering customer support questions, all without breaks, complaints, or even mistakes. So how does it actually work? So first, you need to map out the job that AI agent needs to do. What exactly should it handle? For example, qualifying sales lead for answering FAQs. Next, you can train the agent using real examples like past phone calls, chat transcript, or emails so it learns how to do the job right. And then you can just keep feeding its feedback so the AI gets smarter and better every time. For example, the sales team uses AI chatbots that can learn from every customer conversation to improve their pitch and close more deals, making sales smoother and much more efficient. Now, how much can you actually make money using this? So, in the US, the AI agent developers can earn between around $160,000 to $300,000 a year. That's some serious cash. And in India, the range is roughly anywhere around 20 lakhs to 40 lakhs per year, and that's only expected to rise as AI adoption grows. So, how do you get started with this? Well, you just begin by learning some of the basics of AI workflows and conversational AI platforms. You can experiment with tools like Dialogflow, Rasa, BotPress, and create simple chatbots. Then you can practice by mapping out tasks you want to automate and train small AI agents. So here's a quick challenge for you. Think about a simple repetitive task you or someone you know does daily, maybe answering the same question over and over. How would you teach an AI agent to handle it? Now jot down the points and the steps you would like to give it to it. So let's talk about why does this skill rocks for freelance and jobs where companies need people who can design, build, and improve AI agents. So this job is perfect for someone who is learning, who wants to learn the AI technologies. So this is your perfect choice. Now the next skill is the AI powered writing and copywriting, where you can create contents that sell fast. You have probably heard the saying that content is the king, and it's very true. Every website, businesses, and brands need fresh, engaging content to grab attention and grow. But there's no catch. Writing takes time and takes a lot of time. And that's where AI-powered writing tools like Jasper, WriteSonic, and ChatGPT are game changers. They help you crack out blogs, emails, newsletters, and sales copy super fast without sacrificing quality. This means businesses get what they want, which is they get the content quickly and then the writers can produce more in less time. Let's talk about how you can start with this. So first, you don't have to think AI will write everything for you. So it's a tool, it's not a magic wand. The secret is to combine the creativity with AI generated draft. Use AI to get ideas flowing or draft outlines, and then you can add your unique style and then you can polish it up. So first of all, you can write SEO friendly blogs that help website rank higher. You can create cold email sequences that get responses and sales. You can also craft sales funnels, step by step marketing emails or pages that turn visitors into customers. Now, mastering these areas can really set you apart. Now let's talk about the salary. Well, in the US, you can expect around $60,000 to $120,000 per year. And in India, freelance and full-time writers can earn around 5 lakh to 12 lakh annually, depending on their expertise and clients' base. Now, the sixth skill on our list is building and managing AI chatbots for businesses, which is the customer service that never sleeps. Now, why this is actually hard? Because think about this. Businesses get tons of customers' questions every single day. Things like, what is your opening hours? Can I book an appointment? And handling all these takes a lot of time and effort and also staff. And that's where AI chatbot comes in. Now, these smart assistants work 24 by 7, answering FAQs, booking appointments, helping sales team, and guiding customers. So how you can get started with this? So first of all, you need to learn the basics of popular chatbot platforms like BotSonic, which is great for building natural conversational bots. Then we've got Chatbase, which lets you upload documents and train your bot to answer specific questions. Then we've got this TDO, which is an easy to use platform that integrates well with e-commerce and websites. So it's very easy. First, you have to learn the basics of building popular chatbot platforms. You can have a look how to create them, and then you can train a chatbot, and then you can deploy the chatbot. These are the very simple steps which you need to follow. Now, talking about the salary, then in the US, you can expect around between $90,000 to $160,000 per year, and in India, you can expect salaries around 8 lakh rupees to 18 lakh per year. Now, with growth as AI chatbots become more widespread, building and managing AI chatbot is a fantastic way to jump into AI development without needing to code. So it's also a skill in very high demand because every business wants faster, better customer service, and chatbots deliver just that. Now, the seventh skill on our list is AI-driven paid advertising management, which makes your ad work smarter and not harder. So if you've ever tried running ads on Facebook, Google, or Instagram, you know it's not just about clicking boost. It takes money and time and a lot of testing to get that ads that actually bring customers. And that's where marketers are turning to AI tools like AdZuma and Pencil to do the heavy lifting. Now, these AI powered platforms help you automate ad optimization, which means they can adjust your ad targeting, budget, and even the creative content itself to get the best results possible. The AI looks at tons of data and figures out who to show your ads to, when and how, so that you can spend less time and get more customers. So let's talk about how you can start with this. So you can start by becoming an expert in these AI tools and platforms. Then you can learn how they work and then set up campaigns that make money for small businesses. Many small businesses owners don't have the time or knowledge to manage these ads, so they need someone who understands AI advertising inside and out. You can position yourself as an AI advertising consultant who can help businesses run profitable ad campaigns while saving time and cutting costs. So let's talk about the salary. Well, in the US, you can expect around $80,000 to $150,000 per year, depending on experience and client success. And in India, you can expect skilled consultants earning around 8 lakh rupees to 15 lakh per year. And this is growing as more businesses realize the power of AI ads. Now, the eighth skill on our list is CRM and sales consulting using AI, which is to unlock the hidden gold mine in sales automation. Yes, if you have ever talked To salespeople, you should know one thing for sure, that they hate doing the same repetitive task over and over. Things like tracking leads, updating sales records, and managing follow ups can eat up a ton of their time. And that's where businesses are turning to AI powered customer relationship management system, or CRMs, that uses software AI tools like Apollo and Seamless AI. Now, these smart systems automate tedious tasks like lead management, sales tracking, and even finding new prospects. So, how do you get started with this? Well, to get started in this field, you want to specialize in integrating AI into CRM. That means helping businesses set up, automate their CRM system, and not to work harder but smarter. So, your work will include cleaning up messy customer data so that the AI can work with accurate information, using AI tools to find and qualify new leads, automating outreach campaigns, and sending them the follow up emails like scheduling calls. Now, by automating these tasks, you can help businesses save time and close more sales, making you incredibly valuable. So, many consultants have built their careers by designing AI enhanced sales workflows for companies. So, this is like a very important skill if you want to make your career in CRM, and you can use this AI to leverage your work. So, let's talk about salary now. Well, in the US, you can expect around $100,000 to $180,000 per year, and in India, you can expect around 10 lakh to 20 lakh annually. Now, if you enjoy problem solving and working with tech that directly impacts revenue, this skill is fantastic way to build a rewarding career. Now, the next skill on our list is managing social media brands with AI. Managing social media for businesses is not easy. Social media managers have to create posts, reply to comments, check analytics, run ad campaigns all at the same time. And that's where tools like Okuya are becoming super popular. Now, these tools can actually automate content creation and even schedule them, which means they can help you write posts and plan when they should go live automatically. Now, this saves a tons of time and lets you focus on bigger things like planning strategies to grow your client's brand. So, how do you get started with this? So, first, you need to learn how to use AI for content creation tools and social media scheduling apps. Now, these will be your best friends for managing multiple accounts. You can start with managing a few brands at once using AI to keep posts fresh, interacting, and consistent. Then you can make sure to check what posts are working well by looking at the analytics. So there are freelancers who manage social media for several brands at the same time using AI tools, and they save hours of work every day, and they can also take on more clients. Let's talk about the money. So in the US, you can expect around $70,000 to $130,000 per year, and in India, you can expect around 6 lakh to 13 lakh per year. Now let's talk about a 10th skill on a list, the last but not the least, which is the AI translation and SEO services, which will help businesses grow globally and rank higher. Why is this important? Because many businesses want to reach customers worldwide. To do this, they need to translate their website products and content into different languages. Human translation takes a lot of time and money, but AI translation tools speeds this up. At the same time, businesses want to rank high in Google to attract more visitors, and that's where search engine optimization comes in, and tools like SEMrush can help you analyze website, find the best keywords, and boost your rankings. So how do you get started? Well, you have to use AI to create the very first draft of translation or SEO reports, and you can use your own knowledge to refine and improve them. You can offer your services to companies wanting them to translate content for international audiences, improving SEO to get more traffic. So these are the tools you can get started with. So first you've got ChatGPT, which is great for drafting translations and writing SEO content ideas. Then you've got Google Translate and DeepL, and even SEMrush that handles all-in-one SEO platform, which I showed you before. Then you've got the Surfer SEO, which will help you optimize content for Google ranking using AI recommendation. Talking about the money, then in the US, you can expect around $60,000 to $120,000 per year as an AI translator SEO expert. And in India, you can earn around 5 lakh to 12 lakh annually, growing as you gain experience.
LLMs. If you ever wondered how machine learning can now understand and generate human-like text, you are in the right place. From chatbots like ChatGPT to AI assistant that powers search engines, LLMs are transforming how we interact with technology. One of the most exciting advancements in this space is Google's Gemini or OpenAI ChatGPT, a cutting-edge large language model designed to push the boundaries of what AI can achieve. In this video, we will explore what LLMs are, how they work, and why models like Gemini are critical for the future of AI. Google Gemini is part of a new wave of AI models that are smarter, faster, and more efficient. It is designed to understand context better, offer more accurate responses, and integrate deeply into services like Google Search and Google Assistant, providing more human-like interactions. So we will break down the science behind LLMs, including their massive training datasets, transformer architecture, and how models like Gemini use deep learning innovation to change industries. Plus, we will compare Google Gemini to other popular LLMs such as OpenAI ChatGPT models, showing how each of these technologies is used to power chatbots, virtual assistants, and other AI-driven applications. By end of this video, you will have a clear understanding of how large language models like Gemini work, their key features, and what they mean for their future AI. Don't forget to like, subscribe, and hit the bell icon to never miss any update from Simplilearn. So without any further ado, let's get started. So what are the large language models? Large language models like ChatGPT 4, Generative Pre-trained Transformer 4, O, and Google Gemini are sophisticated AI systems designed to comprehend and generate human-like text. These models are built using deep learning techniques and are trained on vast datasets collected from the internet. They leverage self-attention mechanism to analyze relationship between words or tokens, allowing them to capture context and produce coherent, relevant responses. LLMs have significant application, including powering virtual assistant, chatbots, content creation, language translation, and supporting research and decision making. Their ability to generate fluent and contextually appropriate text has advanced natural language processing and improved human-computer interaction. So now let's see what are large language models used for. Large language models are utilized in scenarios with limited or no domain-specific data available for training. These scenarios include both few-shot and zero-shot training approaches, which rely on the model's strong inductive bias and its capability to derive meaningful representation from a small amount of data or even no data at all. So now let's see how are large language models trained. Large language models typically undergo pre-training on a board, all-encompassing dataset that shares statistical similarities with the dataset specific to the target task. The objective of pre-training is to enable the model to acquire high-level features that can later be applied during the fine-tuning phase for specific tasks. So there are some training processes of LLM which involve several steps. The first one is text pre-processing. The textual data is transformed into a numerical representation that the LLM model can effectively process. This conversion may involve techniques like tokenization, encoding, and creating input sequences. The second one is random parameter initialization. The model's parameters are initialized randomly before the training process begins. The third one is input numerical data. The numerical representation of the text data is fed into the model of processing. The model's architecture, typically based on transformers, allows it to capture the contextual relationship between the words or tokens in the next. The fourth one is loss function calculation. A loss function calculation measures the discrepancy between the model's prediction and the actual next word or token in a sentence. The LLM model aims to minimize this loss during training. The fifth one is parameter optimization. The model's parameters are adjusted through optimization technique. This involves calculating gradient and updating the parameters accordingly, gradually improving the model's performance. The last one is iterative training. The training process is repeated over multiple iterations or epochs until the model's output achieve a satisfactory level of accuracy on that given task or dataset. By following this training process, large language models learn to capture linguistic patterns, understand context, and generate coherent responses, enabling them to excel at various language-related tasks. The next topic is how do large language models work? So large language models leverage deep neural network to generate output based on patterns learned from the training data. Typically, a large language model adopts a transformer architecture which enables the model to identify relationship between words in a sentence irrespective of their position in the sequence. In contrast to RNNs that rely on recurrence to capture token relationship, transformer neural network employs self-attention as their primary mechanism. Self-attention calculates attention scores that determine the importance of each token with respect to the other token in the text sequence, facilitating the modeling of intricate relationships within the data. Next, let's see application of large language models. Large language models have a wide range of applications across various domains. So here are some notable applications. The first one is natural language processing, NLP. Large language models are used to improve natural language understanding tasks such as sentiment analysis, named entity recognition, text classification, and language modeling. The second one is chatbot and virtual assistant. Large language models power conversational agents, chatbots, and virtual assistant, providing more interactive and human-like user interaction. The third one is machine translation. Large language models have been used for automatic language translation, enabling text translation between different languages with improved accuracy. The fourth one is sentiment analysis. LLMs can analyze and classify the sentiment or emotion expressed in a piece of text, which is valuable for market research, brand monitoring, and social media analysis. The fifth one is content recommendation. These models can be employed to provide personalized content recommendations, enhancing user experience and engagement on platforms such as news website or streaming services. So these applications highlight the potential impact of large language models in various domains, improving language understanding, automation, and interaction between humans and computers.
We will get started by a brief introduction to LLMs and chatbots. Later, we will dive into setting up the development environment. Then, we will understand data collection and preparation. Followed by that, we will understand the implementation of LLMs. Later, we will check into chunking and embedding for vector search or RAG. Followed by that, we will learn implementing query processing and recommendations. Next, we have zero-shot text classification, and lastly, the sentiment analysis with LLMs. Hope I made myself clear with the agenda. Now handing over the session to our experts.
Hi, welcome all. Welcome to Simplilearn session on how to create LLM chatbot. In this course, we are going to talk about what is LLM, what are chatbots. We'll try to see how do we start developing a chatbot using large language models, where we'll try to understand how do we set up the environment. Then we talk about how do we collect and prepare the data for LLMs to understand. Then how do we implement LLMs? Chunk and embedding vectors that is required for retrieval augmentation. So that is the embeddings of the data chunks. I'll talk about those things. We'll further talk about how do we implement query processing and recommendation systems. We'll give an understanding on prompt engineering of zero-shot text classification, which is a type of prompt engineering. And we talk about finally with the sentiment analysis with LLMs. So we can create multiple types of LLMs and we can create sentiment analysis LLM. At the end of the session, we'll try to develop or go through with a piece of code using LangChain to create a chat model using OpenAI APIs, and we will work on that and try to put that into production environment using Streamlit. That would be the agenda for the day. So, how do we create LLM chatbots? And we'll start with what is an LLM. LLMs are nothing but large language models which are trained on very huge amount of text, and they have the capability of generating human-like text. So they are slightly enhanced version of the natural language processing tools that we have seen before in the deep neural network architectures, wherein those architectures using LSTM models or GRU models or similar models with respect to or the RNN models, these models were able to understand the text and give an understanding of those texts, that what exactly is the inherent meaning about those text messages. However, the large language models are a step ahead of the previous versions, and they are able to not only understand the text, but they are able to generate the text based upon the information given to them. So that is what we call as a large language models. These are primarily trained on a very huge amount of data. They do not have any kind of predefined resources. They are trained on a very humongous amount of data. Now, how it works? If I talk about how LLM works, LLM typically takes up the huge amount of text and breaks it down into the pieces. We call them as the tokens. Now, what is the tokens? As a very small level, a very basic level, I can say that tokens are nothing but the words. At a very broader perspective, you can understand tokens as words. So words in any context, in any paragraph, let's say you have 10 words or 20 words or 1000, each word can be considered as one token. At times, we can also consider an entire sentence as a word, as a token. So that is dependent upon which kind of modeling technique being used. We are using sentence tokens or we are using word tokens. But yes, At a very basic level, at a very grassroots level, you can think of tokens as simple words which are lemmatized or stemmed. So stemmed or words. Stemming and lemmatization are the basic concepts which are coming from the natural language processing part, where we try to cut down the words to a basic root level, grassroots level words. So that is the idea behind stemming, so that we get similar words for every problem. So just for an example, you can think of a simple example. If I write down few words for you, I can write down a word break. So we were talking about how LLM works. So in general terms, if we talk about how LLM works, LLM will be trying to process my entire text data and create tokens out of it. So out of those tokens, the tokens can be considered as single words or sentences at times, depending upon the mechanism that is being used. But you can, at a very broader level, we can consider tokens as the piece of words which are at a root level words. For example, breaking will become break, or into will remain into, or breaks will also become break. So depending which are the root words which generates other words, we'll try to contextualize all words into a single entity which are of similar nature. The word transformer might become a transform, architectures might become just an architect. So depending upon different kind of words, we might have some basic root words that will come to the picture. That is what we call as a tokenization, stemming, and natural language processing. So that's what we're trying to do. After tokenization, we get smaller words, as I've mentioned, you words or subwords, and we try to convert them into a vector representation, and we call them as numerical representation of those words. Let's say every single word in my entire word dictionary, I will give them a particular number. Let's say A is at number 1, B is at 2, lamb is at 3, so on and so forth. So each particular word out of my entire contextual words will have a number associated with them. I'm giving a random example. And with that, we can assume that those numbers I can represent in different form, maybe in hex code form, or in a binary coded form, or some other form I can represent them. And we can use that numerical representation of each word in order to understand those words in numerical form, because it would be the numerical representation of the data that will help in making things clearer and understandable, right? After this, LLMs, once we got the relevant tokens, then it uses the attention mechanism. Now, what is an attention mechanism? There's a famous research paper on this, which is Attention is All You Need, published in 2017 from Google Brain team. That paper talks about a self-attention mechanism, which is the primary source of all transformer models. LLMs also use transformer modeling approach. So that is where it contains of a self-attention layer and masked multi-attention layers. So that's the basic underlying principle behind all the LLMs. So we have an encoder block and we have a decoder block, and we work on those two blocks together in order to understand what is the input being given and what could be the potential text that could be generated for the given input. That is what attention mechanism allows us to do. We can discuss the self-attention mechanism in detail in another separate video. That's what transformer talks about. So these are very different deep learning architectures, which actually does not use a neuron kind of thing. If you have studied about deep learning architectures, you would have seen that every deep learning architecture at the hidden level has certain neurons at the center, which takes the input and processes it and gives the output. In LLMs, we use a self-attention mechanism module where we replace those neurons by self-attention blocks. The self-attention blocks has two important portions. One is an encoder, other one is a decoder. And again, certain LLMs may be just coder module, certain LLMs might be just a decoder module, certain would be a combination of both. All the generative ones are the models that are combination of both encoding and decoding part. If I talk about types of chatbots, the chatbots is another example of using large language model. What does chatbot do for us? We ask a question, we put up a prompt, we put up a query in front of a machine, and then machine is able to respond back based upon the query being put up. And there can be two classifications of the chatbot based upon these two versions. The first is the rule-based chatbot, and the second one is AI-based chatbot. What are the rule-based chatbots? So rule-based chatbots are those where they have a defined set of rules and pre-written scripts for a particular question. Let's say, how are you? So if I have mentioned already or defined, if someone asks you, how are you? It will give me a particular answer. If that question is not into the vocabulary, it will say that, sorry, I'm not able to answer that question. I'm not trained onto that part. So those are called as rule-based chatbot or rule-based LLMs. Typically, these kind of rule-based LLMs use decision algorithms or random forest or based algorithms in order to understand and create rules and then give the answers. Typically, that's the underlying logic that goes behind the rule-based chatbots. Typically not into practice too much these days. We have AI-powered chatbots, which are much more responsive and much more better. So we'll use in this class as well, we will work on AI-based chatbot. The rule-based chatbots, which are very simple to implement and very easy to put up through. They will not be able to handle very complex wordings because you will not be able to give sufficient amount of examples. Right? Then you have AI-based chatbots. You can put up any kind of queries. I'm pretty much sure most of us would have used AI-based chatbots like ChatGPT or Anthropic, right, or Gemini. You would have used, some of you might have used those, some common names that I've taken up. So all these are AI-based chatbots, right? Depending upon my requirement, what requirement that we have, what kind of chatbot should I use is very much important, because I need to look at many factors like how much customization is required, what is the cost involved, how do I'm on a deployment, what is my deployment requirements, how much open source do I want it, make it to be the open source availability for this. Last and most important factor is how much is a private data. That means a data which is not available publicly for OpenAI models or open source models to learn from. So do I want to include that data or not? That is also an important factor. If I have to include the data, the type of AI-based chatbots will also vary, because there will be two types of AI-based chatbot. One that we use with the pre-trained models, which will work in this class, and the other one that uses pre-trained models. Along with that, it also takes up a chunk of data, or it can also get trained from some other data as well. That is what we call as RAG approach, retrieval augmented approach. All right. So this is what we have seen so far. Now, setting up the development environment. In order to create a development environment, we can choose many things. There are multiple APIs which are available, but in this particular section, we will use OpenAI API. It is easily and freely available. Right. So we require a coding environment. I'm going to use Jupyter Lab for it. Some institutional libraries. To name few of them, I'm going to use Streamlit. We are going to use LangChain. What else? That would be more than sufficient. NumPy and Matplotlib would also be required. That's it. So these are the few libraries. Whether I want to do a cloud-based deployment or on-premises deployment depends. That dependency needs to be understood, because cloud-based deployments would require a little more resources. We need to ensure about the correct API access. The API access that I'm going to use is my own personal OpenAI access. So I would mention OpenAI key at the place of the code where it is required to put up the OpenAI key. All right. Thank you. We'll require understanding of basic Python understanding. How do we write Python scripts? How do we integrate APIs with the Python scripts? Two important things. We'll use Jupyter Notebook in this case, and VS Code, or either you can use any technology, because we are going to write down a .py file. So whatever you're comfortable with, Jupyter Notebook, VS Code, or just Python working environment, I'm okay with that Python editor. So API access can be requested from OpenAI, Cohere, or Hugging Face. I'm going to use OpenAI in this class. So I'll show you how to gain OpenAI access. You can go to platform.openai.com, register yourself, and you can generate your OpenAI API key. right? So transformers, I can use LangChain, which will require me to develop the chatbot logic, and that's what we're going to do. We can use Llama Index for data retrieval, or you can use Fast API, Grad.io, that can allow Fast API and Grad.io will allow me to put the deployment part. But we're not going to use that. You can use cloud-based services like AWS, Azure, or Cloud. We're not going to cover that too as well because it's not within the scope. So data collection and preparation part. So we need to collect the data in the form of either CSV, JSON, or web scraping data. Go to NumPy, Pandas, create the data and refine the data. But in this particular section, we are not going to deal with NLTK or Spacey library. We are not going to train the model as of now. We're going to use pre-trained models from OpenAI API. So how do we create LLM chatbots? So that will be little practical parts that we'll try to understand how do we can create LLM chatbots. What we require is few understanding. If I'm going to train up a model, for example, I'm going to train up an LLM model, we need a model architecture which can be implemented, which can be downloaded from transfer learning methodologies. You can get all those models either from Hugging Face or directly from Transformers library or directly from TensorFlow or PyTorch, whichever way you're trying to implement. We can get them from there. Apart from that, what kind of model is required? That is also an important thing. Because if I'm doing a sentiment analysis, I'll require a sentiment analysis. If I'm looking for a question answering approach, I would require a question and answering approach. If I'm requiring general question answers, generic models, I can use generic model like ChatGPT. So depending upon my requirement, I would have to choose the correct model and correct APIs accordingly. That is the first important task that we need to, right? That's we have talked about. If I'm trying to use different LLMs, I require different kind of things. For general versatility, GPT is good. Open source customization, Llamas are good. Mistral for efficiency, Falcon for scalability. So right model will depend on many factors like performance, cost, and deployment needs. We can get right models, whatever models that you want from Hugging Face or API-based models. API-based models would include like I have Open API access, and on Open API we have a Chat GPT's 4.0 mini version which is available for access with me. So I'll use that. Now, how to create an LLM chatbot? For this, we need to understand what is retrieval augmented generation. So what is that? Retrieval augmented generation. Suppose I'm trying to do a search. For example, I typed in a query. What is the role of Python? Just a simple word. What is the role of Python? In this scenario, it will try to find out of my entire context that I've given, what is the role of Python. It will try to find out what are the most relevant words with respect to the question being asked, the meaning that it has, and based upon that, it creates a architecture of most important keywords, and that keyword is called as RAG, or retrieval augmented generation. So after that, it finds out what are the most important keywords, and based upon that, it performs the extensive search through the data that it has and finds out the correct responses, matching keywords from different resources. Then from all different resources, it will learn everything and then come back with my solution. So that is what it is going to do for us. What it allows us to do is the RAG approach is my model or my LLM is not going to give me random vague answers. It's not going to create or generate answers without any context. It will always try to find out some semantic information and give good contextual answers. Same thing happens with the chunking and embedding in vector search. It tries to break down the entire text into smaller manageable pieces. We call them tokens. Again, converted to numbers are called as vectors. Again, it can be done through many other libraries, like chunking and embedding can be done by LangChain's character text splitter. We can do through NLTK, or we can do it from TikToken. TikToken is not to be misunderstood with TikTok. It's a different entity altogether. Token is a library that allows us to tokenize my text. Then we have transformers, like sentence transformers available, which allows me to create the vectors. Vectors means again numerical representation of my text. Then we store that in the database. Any simple database can work for us. Then we look for the similarity scores like cosine similarity, Euclidean similarity scores, or product similarity scores to find out what kind of matching architectures. As I've told you, RAG uses this approach, finds out similar context words. So from there, it will try to get me those similarity words and find out similar contextual information. Then we talk about the implementation of query processing and recommendation. In query processing, the idea again changes nothing but you ask a question, LLM works around with that, again breaks it down into a text form. From text, it converts vectors, and since it's a question, so it becomes a question answer kind of approach. So it will find out 10 answers and try to filter out the best suitable answer for any query that is being done. Now, what is zero shot text classification? In a zero shot text classification, I do not train my model explicitly, right? So what that is zero shot classification, where I'm not putting up any additional resource. What is that meaning is I have a pre-trained model like GPT that is being trained on very generic knowledge that may not be very specific about the context that I'm asking. Say, for example, I have ChatGPT, which is trained on almost everything in the world, but it might not be trained on my organization's specific issues. But I can still ask this question about my organization. It may not be able to give me a very specific answer, but it will be able to give me a generic answer. That is what we call a zero shot text classification, where I'm not training a LLM on a specific data. Rather, I'm just creating an LLM from a pre-trained model and asking it for new data installation, right? How can you find out some classification models? There are lots and lots of available. I can just show you very quickly. Pre-trained classification model, you can go on to huggingface.co. That would be a place you can find a lot of pre-trained classification models available. You can find out models based upon your requirement. You can go to the models and you can click for the task, whatever task that you're looking. Let's say I'm trying to do some text natural language processing. That's a zero shot classification. I have many models here. But just for zero shot classification, these are the models available. I have BART large MNLI from Facebook. That's one of the zero shot classification model. You can look at that. Go to files and versions. This is the entire model. You can see that you can read out this readme.md file and find out the information about it. So there are a lot of models which are available, which you can use. Again, it's a GitHub, so you can clone this entire part and you can clone it from directly from Hugging Face, clone the repository and use it locally. Okay. So any model can be used. So BART large mini MNLI, that's one classification model that can be used out. There can be a lot of things that can be done in zero shot classification. Apart from that, you can create transformer pipelines wherein I'm trying to do one transformation followed by another one, and so on. So that can be created up. We can use a scikit-learn matrix like precision, recall, or F1 scores to find out we have correct classification. We can implement those two. Finally, we'll talk about the sentiment analysis with LLMs. LLMs can also be very much useful in doing the sentiment analysis part. So in sentiment analysis, we try to look at how we can determine the emotional tone of any text, allowing or enabling chatbots to understand the user sentiment. So we try to train the chatbots on emotional on data which contains emotional aspects. We can define it whether it's a positive or emotion or a negative emotion or sad emotion or a happy emotion. We can train the LLMs on that. And based upon that training, my LLMs would be able to tell me whether any particular emotions being reflected is what kind of emotion it is. It may not be able to mimic that emotion, but it will be able to tell me what emotion has been reflected in the context. It can be with the audio, it can be with the video, or it can be text as well. That is the sentiment analysis. Again, Distilbert is one of the very good classification model for sentiment analysis. That is what we can use. Sentiment analyzer is available with many other. Sentiment analyzer is available with Distilbert, Robert, Lama. Everywhere we have a sentiment analyzer available. It's one of the class in a pre-trained model which is available to analyze the sentiments. So this is what we will talk about through the entire understanding of your LLMs theoretically. Let's try to practically look at how do we implement that. So I will open up Let me open up my Anaconda Navigator. So I'm going to open up Anaconda Navigator here. I have a pre-written script. I'll walk you through that and I'll explain you each line what it is doing. Hopefully that helps. So here it is. I have just got my Anaconda Navigator opened up. I'm going to open up my Jupyter Lab environment from here. Wait for that to open up. Should be up and running in a moment from now. So once that opens up, we will be able to start doing the coding part of creating a chat GPT kind of approach, where that would be in the implementation of chat GPT through chat GPT open API that we can use at our own local servers or at our own particular end. Essentially, that is a replica of chat GPT that you can put up. Okay, I already have this piece of code written down for you. So what are we going to do here? So I'll put down a certain piece of codes here. This file will be made available in the description too, or you can copy it from here. Okay. So what is each of these things that we're going to do? So I have named that as I have created a Python script here. For that, I've gone to File, New, and I've used a Python file. I went into that option and I create a Python file. First line I wrote down is import Streamlit SST. So this will allow, I'll put up certain libraries to be done. Libraries. Import. Prior to that, you might be wondering if I don't have those libraries. So you need to install these. I'm putting that as a comment, pip install. Or if you're using an environment, you need to put that into your environment. So I'll put up that pip install. You need to put up LangChain. I'm using LangChain here. Space. You would require Streamlit, OpenAI. That should be good. Just these two would be good. Okay, you need to install these two libraries, LangChain and Streamlit. What I'm using Streamlit for? So LangChain, I'm just putting these notes. LangChain supports or LangChain for the purpose of building chatbot logic. Okay. And Streamlit for designing UI. So I'm not going to give too much into designing part. I will take a simple UI as of now. Idea is not to do the designing part, designing the user interface. Okay, so a web-based user interface, I'll say that designing a web-based user interface. A separate session on Streamlit can be taken up to design all that part. So Streamlit is a separate library altogether. So we will import Streamlit as ST. That allows me to import Streamlit from LangChain.chat models. Now this submodule allows me to open or connect or call up the keys or open API keys from the OpenAI servers. Okay. So that is a class that is available, Chat OpenAI, that will allow me to create or contain my OpenAI tools. Then another thing that I need to put up LangChain.chains conversation. Now what does that do? It allows me to create a chain of conversations. That means suppose if I ask one question, there's an answer given. Then I can ask up a probing question further. So that allows me to remember the previous past as well in context with the current conversation. It allows me to create a conversation chain rather than one question, one answer and stops. Instead of that, allows me to repeat things on a simultaneous basis. LangChain.memory, that allows me to remember the buffer memory. It allows me to remember my previous conversation. Suppose I have started with one conversation and then I want to continue with another conversation. So my previous conversation can be saved and used. It can be reloaded. OS I'm using for very generic purpose to create environment variables. If you want to create environment variables, otherwise it's your choice. If you can avoid OS as well if you're not using environment variables. So first thing is to set up your OpenAPI key securely. So for that, I'm creating a variable OpenAI API key and I'm putting that into my Streamlit secrets. Now, where are these Streamlit secrets? So these are typically stored in a TOML file. I'll just show that. So that will be in your default folder where your Anaconda is installed. You will have a .streamlit folder. You need to go into that and install. Will be in default user account. Inside that, you will find a under Streamlit folder. You can find there is a file by the name secrets.toml. If it is there, you can put it up. If it is not there, you need to create a new text document like this. Inside this, I just open it up. You need to write down anything. I have used the word OpenAI underscore API underscore key is equal to, and you need to mention within quotes your API key, whatever you are using. Put it up here and save this document. Save as, and you go to this place, select all files, and save this document as secrets.toml. So that allows you to take your key into or transmit it into your network or transmit it to your model with encryption. So that can be saved up. So you can just need to save that file. I have already done that, secrets.toml. This file contains my API key, right? I already have that file here. So that allows me to tell it, Streamlit, go to the secrets and find Open API key if it is available in Open Secrets. If it is available in there, else you can get it from the environment variable. Or else otherwise you can create up here os.environment. Those who do not want to use that, you can put up os.environ and create up the same variable by the name open. This is an optional thing. So open underscore API underscore key, and you can mention is equal to quotes your API key, whatever you want to use, your OpenAI API key. That should work. So I'll put a comment. This is an optional thing, right? We'll get this thing work. I have put this again in statement. This is for the purpose of else os.get environment open API key. So if we do not have a key available in secrets, it will try to fetch it from the environment. All right. Now we need to initialize our LLM model. How do we initialize my LLM model? My LLM is equal to chat OpenAI. That's the name of the function that will connect me to OpenAI servers. OpenAI.API key is equal to OpenAI.API key. I have kept my API key. If you do not have anything else available, just write down your OpenAI key directly here. You don't have to create anything at all. Right? You can paste it up directly here as well. That will expose your OpenAI key, and you may not want to expose that securely. Then the temperature, it's the amount of randomness that we want. Now, what does that mean? It means how much randomly generic answers I want to create. The temperature part. Higher the number, more is the randomness I'm trying to bring into my answers. The bigger the temperature value is, the better your answers would be. Lastly, the model name. Based upon your access to OpenAI API, you would be able to access either some of the models. I am able to access GPT-4 or mini model. I have mentioned that model. If you're able to access GPT-4, you can just mention GPT-4 or whichever model you have an access, or 3.5 turbo, depending upon your access. You can use that particular model. After we have initialized the LLM part, we will move on to the next part where I'll set up the memory part. Now, what is that memory part? In this, on my Streamlit platform, I just wanted to make sure if there is any previous memory available, it should be able to bring that memory for me. If it is not available, I'll start my conversation from a new piece. So I've created a variable memory, if memory not in session state, right? st.session state. A session state is a variable that creates my value, and I'm looking for memory part. If there would be any memory, this flag will be true, whether it will be false. So if memory not in session state, if it is not present, I want to create a memory that I can assign a memory value to it using conversation buffer memory. So whatever memory that we have, I'll start with that memory. So that will be blank at the moment. Then I'll start my conversation. Now this function conversation chain, it actually allows me to create the chain of conversation. The model that I'm going to use is LLM model. The memory is the current memory state, that is blank, currently blank. So as soon as we keep on moving, the memory states gets on updated. Verbose will try to make sure that if there is any kind of warnings or something in between, these are not being displayed. So the verbose false that ensures that part. So we do not see any warnings or anything. Apart from that, now we need to design the interface. That's the model LLM model part done. We will design our interface. st.set page config. So whatever the web browser page that I'm going to design, I want to put the title as LLM chatbot. Page icon, if you want to put something, let's say put up anything. You can put up a GIF image or whatsoever you want. If I can have, you can leave it. I'm writing down one Simplilearn. I do not have that small images right now. So you can put a page icon like this. Then title. Now this title will appear up in the center of your page, right on the first page on your screen. The LangChain chatbot by Simplilearn. Okay. So that will appear up in there. Now we will now use the same place that will create my interface. That means I'll get a web page whose title will be LLM chatbot. Page icon will look like Simplilearn's name written onto that. Title would be LangChain chatbot by Simplilearn. That will appear up somewhere in the center of my screen. Then I'll put up a blank box to receive user input. So user input is equal to, the name of the function is st text input. St is my Streamlit library. In text input, I'm asking this part to display. Asking you to display the word u followed by key is equal to input. So it will display up a box and the key input will be displayed up within the box. So you get to know that here I have to put in the input value. Then, if I get a user input, my response is conversation, which is my conversation chain model that we have created here. Conversation.predict the user input. So based upon the input that I gave, it will create up a response. Once it gets the response, I will add to the memory, to the chat memory. So session state memory dot chat memory dot add user message, predefined function. So I'll put up user input and add AI message as response. I have added two functions there, and then I'm writing up the response. So I'm putting up now on my screen st.write is going to put my response. So I'm writing down a formatted string with a markdown language of bot that will appear in bold and the response. So whatever the response from LLM model that has came up, that will be printed up here. At the last, I'm putting up, this is an optional thing, completely optional, wherein I'm trying to tell you, if you want to see the previous histories, you can put that up by doing this. How? So there is a checkbox I'm creating. If st.checkbox show chat history, that will be displayed in front of it. There will be checkbox. So if I select it, this becomes true. If I do not select it, that remains false. For message in st state memory, chat memory messages, I will try to see. See, I have added user messages and AI messages. So that is available in my session state memory, chat memory, right? So I'll go to session state memory, chat memory, and I want to recollect all messages. So I'll retrieve all messages from there, and I'll put up what the role this particular u, if message dot type is human, else bot, and I'll put down the entire content. So that's what will be printed out on my screen. That completes your entire LLM creation part. Let's try to work around this. Now for this, you need to save this file as chatbot.py. Once you have done this, open up your terminal. I'll open up a terminal that is nothing but my Windows terminal, PowerShell terminal, and I'll run this command by putting up Streamlit space run space name of my Python script. So it's chatbot.py. That is my Python script. When I execute this, I press enter key on my keyboard and say that you can now see your Streamlit app. I'll just show you this. You can now view your Streamlit app. It's starting up the app on the back end, but I'll just show you here on your browser. So that has already opened up an app on my browser. I'll show you that. But it says that local URL HTTP localhost 8505 and my network URL is this. So it has got me an IP address URL as well. I can use either one of those. But if I go to my web browser and see, it says that my window title of, I'll show you. You see that LLM chatbot here. That's my title on the top. up, I had an emoji to come up, but that did not come up, alas. But you can see here, LangChain Chatbot by Simplilearn. That's what I put up here. That's the name. And it has a context box of you, and I have a box to write down. I have a show chat history option. Let's try to search. What is, or let's say, today's news, I'll win Champions League 2025. Now that's a very generic question. I'm pressing enter to apply. If everything is good, my API is running, I would get an answer. It says, I cannot predict the future, so I don't know who will win the Champions League 2025. The tournament is filled with so many talented teams, and anything can happen in football. So you can ask me any question, you can put up any questions. If you don't like, you can put up a new question here. Tell me the names depending upon how much availability of all participating. So depending upon your prompt, you can create up. So it tells me does not know the top teams from various European leagues, including Premier League, La Liga, Serie A, Bundesliga, and League One, along with some lesser known leagues compete for a spot. So we can see some team names that can be there. Essentially, you can also see below, so show chart history. If I put that on, you can look at all the things that has been done in this particular. You can see my chart history is available. So that can be viewed. I removed that show chart history. The chart history will be part now. Again, depending upon the machine that you're using, it is running on my local server. So depending upon hardware, it might be slow or fast. That is how you can do it. The next option that we can do is to deploy this. In order to deploy this, you need to go on to deploy option. You have multiple choices available. Like you can go on Streamlit Community Cloud, you can go on Snowflake, or you can deploy on your custom platforms. If I want to go on Community Cloud, I can click on deploy now. I need to access to my GitHub account. I need to put this code onto GitHub and then I can deploy. That can be discussed in a separate session altogether. So that would be it, everyone. And I would really like you to think of questions and answers. If you have something, put them up into your comment section and we'll definitely respond back. Thank you very much.
So today we are going to build the free AI web scraper. Now let's begin with understanding what exactly is web scraping. Web scraping is an automated process of extracting data from websites that involves using software tools or scripts to access a web page, read its HTML content, and retrieve specific pieces of information such as text, images, links, or structured data like tables. All these days in data analytics, web scraping was common. For example, Tableau, Power BI, Excel, and many more, they used to have an API attachment or they used to have a connection established with websites and they used to scroll over the web page and then extract the HTML content. But what if you had to build your own? It would be a time-taking task, but with AI, it is really simple. There are multiple AI tools like Browser AI, AI Scraper, Firecrawl, Octascrape, Crawl4AI, and many more. Today, we will be using the LLM-friendly tool, which is Crawl4AI, and it is completely open source. Now, let's switch to the demonstration part of it. So let's get started with the demonstration. We will proceed with one of the most popular open source tool, which is Crawl4AI. So you just need to search for Crawl4AI, and you will be having the first two links, which are the GitHub link, and the next one is the official documentation of Crawl4AI. So as you can see, this is awarded as the top repository from GitHub. So you're on the front page, the quick start page, which will explain you the installation procedures. So the basic installation, you just need to run some pip commands, and you can also find the same in the GitHub page as well. Let's go through a quick walk around. So the basic installation and the initial setups, diagnostics, which is nothing but checking the version or something like that and verifying the installation. All basic and simple techniques, and advanced installations in case if you're going with the additional functionalities. You can just go through the entire documentation, and you also have some feature called as Ask AI. So they've got their own chatbot where you can ask some questions regarding installation or any other questions if you have about Crawl for AI. And now to the home page. Now, if you see the GitHub page, you also have the similar approach, the same procedures, open source web crawler, web scraper, ranked as #1 on GitHub. So here you have some basic why you should proceed with crawl for, and also the installation steps as mentioned in the official documentation, pip install command and everything. Everything is similar. There you go. Verified installation and everything else. And you might also need some additional tools like Playwright and all the other things, and Python environment, virtual environment, everything. So you just, all the things are mentioned below as similar to the official documentation. Now we will proceed with one of the IDEs. So I'd recommend Cursor AI, because Cursor AI will help you regarding any of the errors in the practical demonstration. Start everything from the fresh, open a new project. We'll also create an entirely new file together. So we'll name it as, that's a trial one. We'll eliminate that. We'll delete that. We'll now create a new folder on the name free AI web scraper or web crawler is good. Yeah. Enter. Select the file location. So you just have to copy paste the templates from the GitHub page. So this particular GitHub page will only have the sample documentation, not an exact, code documentation. You just have to copy this and paste it on Cursor AI. So what Cursor AI will do is it will go through the entire detailed procedure. It will go through the sample code, so that if you just give it a command that I want to prepare something similar to this, and you're the one who's going to handle everything, so it will just understand it and then it will build you one. So we've pasted the entire documentation from GitHub. But before we enter it to the agent of Cursor AI, we'll be writing a small prompt, and the prompt will be really simple. Create me a multi-URL crawling project, which takes homepage of a website and then crawl up to 20 found pages using Crawl for AI. Also allows .csv downloads and solves all the previous downloads in cookies section of the browser. That's it. And now, apart from the GitHub page, to just add a few more details, we'll go to the home page of Crawl for AI, and here we'll go to Fit Markdown. So why Fit Markdown? So you already know whenever you are working on a web page, you'll have a mix and match of HTML, CSS, and all those things, right? So we don't want to focus on all those things. We just want to focus on the markdown part of it, the major details which are included inside the comments, right? The markup language. We just want to focus on that so that it minimizes the processor effort. So we'll just copy this and paste it back on the web page. But before that, let's also go to another file, which is also the multi-URL. So you can also copy this and paste it on the prompt. And first, let's paste the beginning one. And let's now copy and paste this as well. In case if you want, for right now, we're working on one single URL. So for safer side, I'll just go with one input as well. But if you're working with multi-URL, then you can copy and paste it as well. And also, you can also proceed with LLM. In case if you don't want the LLM to be functioning there, then you can also go ahead with that. So here you can see the key benefits as highlighted. Back to introduction. Yeah, that's the one which I was talking about, LLM free strategies. So in case if you don't want LLM to be functioning in the background, why you should avoid LLM being for the basic extraction? These are the few reasons. So yeah, that's the one. So one of the Crawl Force AI is more faster. That's the reason you can choose the Crawl for AI instead of any other LLM. Now let's go back to Cursor AI and continue with our prompt. Just enter, and it will automatically create all the classes and all the code documentations for you, along with a README file which includes all the requirements and everything and the steps that you're following. Right? You already got the requirements.txt, which will have all the requirements that you need to execute this project. Now let's create the main crawler script. So it's writing a Python script for you. In the meantime, it will also give you some recommendations to follow. Here you can see that it wants to uninstall the existing Python, and it wants to reinstall a new one and restart Cursor all by its own. You can see it is also generating the HTML template. There you go. You have the crawler.py ready and requirements.txt ready. You can see it also created a README file. That's the one. And now it's writing a few more codes that are responsible in or play a key role in execution of this project. So that's your main code, crawler.py. It has the main functionalities that this particular project should go ahead with. The post, get, and other functions that you regularly have on the web page. And this is your README file. And here you have the requirements. So you'll be needing crawl for AI and other requirements. So this is your HTML file. I can just proceed and run. And obviously you will face errors because this was just a templatized code that Cursor AI has created for you based on the documentation that you gave to it. But worry not. Whenever you run the code, it will give you the requirements which are needed to execute, and it will automatically install those for you using the pip commands. And by the end, it will automatically fix everything for you. Now it's running, and you can see it already has set up a user interface on the local host. Just click on the link, open. Yeah, so your first error, the web page or the local host is not responding, or maybe that's an internet connectivity issue. You can just copy this particular error or try to refresh. So let me write down a prompt. Can you check the warning errors and fix them all? And next, run the entire project. Now it goes through each and every file that it created and also cross-verifies the requirements and then executes everything. Let me delete this terminal. Yeah, so it found it needs a couple of templates. Okay, the templates directory exists, but we need to ensure it's properly set up. There you go. It's trying to relate every single file and fulfill the requirements that we need to execute this project. And the following changes are applied. You need to accept the file, accept the modified file, and then now it is installing the requirements. Python pip install our requirements.txt. If there are any requirements, it will do and it will automatically install. Yep, there you go, the playwright, right? So we did not manually install it. It identified the blank space there and it identifies it as an important prerequisite. So it is installing it. And it is also asking for an interpreter path. So we'll be going with Python 64-bit version 3. And is also installing Chromium. And if you see on the left hand side, it is also creating a virtual environment, creating when we upgrading PIP. You can see the status on the left hand side as well as on the right hand side. So crawler.py is our main file. It has started executing it on localhost back again. So the best part about using Cursor AI is you will have an agent which you can work with. So we are currently working on the Cursor AI's AI. If you want, you can switch from Cursor AI to ChatGPT, Claude, or any of the LLM of your choice, and you can get started with it. Now let's try to run our localhost once again. Okay, so let's copy the error this time and paste it there. Now what this does is Cursor AI's agent will try to analyze what could be the problem and tries to decode or debug the entire problem and improvise the code and fix it for you. Now it says that it has understood the issue and it tried to fix it, and now it wants to run the file once again. Just click on run and check for yourself. It's a type of trial and error, but I'm sure it will help you work it out. So I've done it once and I'm doing this once again. It's not a big deal at all. There you go. Okay, it has found a little bit of error. Now it wants to install the requirements once again. Okay, Ginger. So I think we missed out on Ginger. So Ginger is like a pre-version of Crawler for AI, and you can consider Crawler for AI as an advanced version or evolution of Ginger 2. So this is also one of the requirements. So I think Cursor AI wants to make sure that it works in parallel with both, so that it doesn't have to find a hiccup while running and executing this project. There you go. It's downloading a few other requirements it needs: tokenizers, Hugging Face, FSPec, file lock, and everything. Meanwhile, let's go through the libraries that Cursor AI has imported for us. So it has UV, con, logging, async, JSON, everything else. It is also taking date and time. And here we have basic config. And apart from that, here we have the main file, which is crawl manager, and save caches for the prompt request that we have placed to save the previous downloads and everything in the browser cache. And crawl URL is where you paste the URL of any random website that you wish to have. And apart from that, here you can see the data frame, which is for the CSV file, which we are going to download. And apart from that, here we have some exceptions. If the crawl was successful or the web scraping is successful or not, it'll let us know. And once everything is done, it'll automatically shut down. And here we have also dedicated the localhost address and the port number for us. So here you can see the files are getting downloaded. We are at 50 out of 68. Might take a little while, not to worry. There you go. I think we're at 66. A little more time and we are done. I think 67 and one last file. We are done. So it's also installing the Chromium, which is required for us, the browser, or the browser interface at least. I think now we are ready to run our main file, crawler.py. There you go. The event already got started, and you might want to refresh our local host. Let's check the status. Just click on the link, and we should be redirected to the link. Or you can also copy paste the address, localhost colon 8000, which is the port number. I think it's not working, or there might be a little connectivity issue. This is common, but don't worry about it. If it's not executing, you can manually write down the address as well. So earlier we had copied the error, right? You can just paste the same error and just remove all the stuff and keep the URL. Or let's try once again. Some loading error, not a big deal to worry about. Let's go with the manual way. I'll erase everything else apart from the address, the localhost address. I'll have the HTTP. So we have the page here. This is where we paste the URL, and maximum pages as we described, it is 20. Let's say you have opened the Amazon website, right? So like I have opened here the Flipkart website that we will be dealing with, and also I have opened the Simplilearn's website as well. Now, before we get started, I want to explain you something about CAPTCHA. Now, this is a straightforward web crawler that we have designed. But in case if you want to crawl through some web pages, like if you log in to incognito mode without logging into your account, let's say Amazon.in, then in that scenario, what happens is it will not have the user address or anything. It'll just go to the login page and it'll ask you to log in with a captcha. So here you can see the captcha code, right? So this particular web crawler that we have designed is not designed actually to crack the captcha things. So for that, you might have to do some additional coding, or you can just write a prompt to the Cursor and it will get it done for you. So so far so good. We will just paste the URL and let's see. I am guessing that we have an error. So don't worry if you didn't get any errors. So few parameters, you can see the max pages, right? That particular parameter is not properly defined here. So in that case, you can just copy paste the error. It'll automatically, Cursor AI will automatically go through the error and the entire code, cross verify it and change the file name. So you can see it already fixed it, right? Accept the changes, and there you go. The code is automatically updated from its end. Accept the code. And now we are ready to run the code again. You can just refresh the local host, copy the address of the web page and paste it there. Okay, just refresh it. Sometimes you just face this connectivity issue, but not to worry. Once it establishes a connection, it will automatically reload. Okay, I think we missed out on HTTP. No. Let's just keep on refreshing it. Yeah, there you go, you found it. Now we will paste the URL that we earlier copied. So let's say you have about 20 to 30 web pages, right? It'll automatically crawl to the end of the page and then it chooses the next page, something like that. But in few scenarios, it might end up in the first page as well. We might never know. So just have to check the code for it and optimize it, and you will be fine with it, right? Let's see. I think we might face, okay, a small error again, another parameter, max depth. So you might face a couple of such errors down the line. You just have to copy paste them on the terminal or on the prompt. It'll automatically go through the code and fix it for you. Just a couple of more. The max pages has been fixed, as you can see here on the left hand side of the code file. Now we are dealing with the max step. It'll also help you fix that, right? It's still going on a search mode to fetch a solution this online, and also after that it'll implement the solution to the code. Yeah, it found the solution. Is already started to build the solution. Let me apply this fix for you. Accept the suggestion. Done. The code is fixed. You can restart, or you can just click on the localhost browser. Run. Or let me just click on the link, right? It'll automatically redirect me there. There you go, multi-URL crawler. Let's give it another trial. Small errors. Even in the first trial, I went through such errors. It was not a big deal. It'll take like 4 to 5 iterations, so max to max 6 to 7 iterations to fix all the errors in your code. That because this particular code was created by AI, right? So it'll take a little time to understand and go through the process and fix itself, and then you'll have a fully functional project. Okay, the code has already corrected now. Restart the server. I think it's asking, okay, in a few scenarios, if you're constantly facing such issues, don't worry much about it. It might be related to, some settings which might have some configurations which might have been requiring a restart of the application altogether. So if you even do that, it'll fix it. Okay, now we're back on the web page. So I think make sure there are no references to max step. Okay. So I think it's a better option to try a restart of the application altogether. So I just close it. Now let's go to Windows and type down cursor here. That's the app. So the app got restarted once again. Okay, it's now asking for a confirmation. Would you like to make this edit for me? Okay. Let us write down, yes, please confirm. Yes, confirm. Let's see if it gets done. So I have my web pages that I want to scroll or scrape. Let's run the code once again. Python crawl.py is getting executed. That was my first website, a Flipkart website and Simplilearn website. It's taking some issue again. It's not able to reload. Okay. We'll copy paste the same website. Okay, now deep crawl was the error. Okay, it's again downloading some requirements. I see some new crawl results on the left hand side. I think these were the results from the previous executions. Starting all crawls. Let's check the crawl results. Okay, complete. Data scraped. There you go. We can see the output here. Status success. Okay, we have successfully scraped the websites and the data has also already been downloaded. So here you can see on the left hand side of the editor, you can see some scroll or crawl results. So let me write down a prompt. Open in a local browser. If it can load the local host or web user interface to see the results on the web page with a proper user interface, that would be better. But we can practically see the results on the left hand side, and it already shown us the execution report on the terminal. Give me the link to user interface UI. So we tried to install the requirements again. Okay, let me close this shell or terminal. Let's check the requirements once again. let it download the requirements. What I was thinking is, let's check the crawled results. So here you can see the first website, which was Simplilearn website. So it has downloaded some data. It is in the format which an LLM can read, but turned out you can see the Flipkart website as well. Every bit of data, the phone details, name of the phone, the display size, camera size, everything has been successfully scraped, and it also has been downloaded. So you can see an actual replica. The iPhones that we have filtered out, it has successfully downloaded, and even the link to each and every particular product from the website. So these are the scroll results, or the scraped results. Crawl or scrape, you can call it both. And this is the previous one. So this is the first one which it scraped out for us. The Simplilearn's official website of generative AI courses and few other websites as well. There you go. This was the Simplilearn's data. Let's open this in the form of CSV, which it is supposed to do actually, right? Once the data has been downloaded, it should be supposed to be represented in the form of a CSV or tabular format in Excel. So do you want to install the recommendation for Rainbow CSV? Yes, install. I think we can have a look at the downloaded data in CSV format in downloads. So here we are on the download section. So these are the CSV files that we just scraped or crawled. Results 1 and results 2. So let's open this file. So here we have the data from Flipkart. I think it scrolled through just one web page. Not a problem. So this was the web page that we were talking about. So I think it started off from the first entry and went all the way up to the last entry of this particular web page. I think it took a snapshot of this particular web page starting to the end, and then tried to scrape the data and enter it into the form of a CSV file. Not bad. Let's go back to this. There you go. And now let's go back to downloads and check the data for Simplilearn.com for generative AI courses. Yes, I think some missing data. Okay. So it missed out on a few date and times of cohort dates. So here it also has the URL for the particular course name. So we have about 14 courses available. Apply generative AI, specialization, few professional courses and executive courses, and some certifications related to data analytics with generative AI. And it also scraped out the URL links to that particular program, and it also cared for entering the UTM parameter, the source generative, event name, mega meaning, right, everything. And it also has entered the duration of the course, which is pretty good, how many number of months or years, and the cohort date. A few of them were unable to get scraped off, but rest of them, we have got them right here, the cohort date. And it also has a fee in INR for this. For some reason, I think it couldn't scrape it off. And also the partner university. So here we have Purdue, and ICT Academy, IIT Guwahati, Kanpur, Purdue, and a lot more, right? So far, so good. So that's how you can build a web crawler or web scraper using AI, which can automatically scrape the website for you and download the data in terms of CSV, .csv or Excel format.
Why reinforcement learning? Training a machine learning model requires a lot of data, which might not always be available to us. Further, the data provided might not be reliable. Learning from a small subset of actions will not help expand the vast realm of solutions that may work for a particular problem. You can see here we have the robot learning to walk. Very complicated setup when you're learning how to walk, and you'll start asking questions like, if I'm taking one step forward and left, well, what happens if I pick up a 50-pound object? How does that change how a robot would walk? These things are very difficult to program because there's no actual information on it until it's actually tried out. Learning from a small subset of actions will not help expand the vast realm of solutions that may work for a particular problem. And we'll see here it learned how to walk. This is going to slow the growth that technology is capable of. Machines need to learn to perform actions by themselves and not just learn off humans. And you see the objective climb a mountain. A real interesting point here is that as human beings, we can go into a very unknown environment and we can adjust for it and kind of explore and play with it. Most of the models, the non-reinforcement models in computer machine learning, aren't able to do that very well. There's a couple of them that can be used or integrated. To see how it goes is what we're talking about with reinforcement learning. So what is reinforcement learning? Reinforcement learning is a sub-branch of machine learning that trains a model to return an optimum solution for a problem by taking a sequence of decisions by itself. Consider a robot learning to go from one place to another. The robot is given a scenario and must arrive at a solution by itself. The robot can take different paths to reach the destination. It will know the best path by the time taken on each path. It might even come up with a unique solution all by itself. And that's really important as we're looking for unique solutions. We want the best solution, but you can't find it unless you try it. So when we're looking at our different systems, our different model, we have supervised versus unsupervised versus reinforcement learning. And with the supervised learning, that is probably the most controlled environment. We have a lot of different supervised learning models, whether it's linear regression, neural networks, there's all kinds of things in between, decision trees. The data provided is labeled data with output values specified. And this is important because when we talk about supervised learning, you already know the answer for all this information. You already know the picture has a motorcycle in it. So you're supervised learning. You already know that the outcome for tomorrow, for going back a week, you're looking at stock, you can already have like the graph of what the next day looks like. So you have an answer for it. And you have labeled data which is used. You have an external supervision and solves problems by mapping labeled input to known output. So very controlled. Unsupervised learning, and unsupervised learning is really interesting because it's now taking part in many other models. They start with you can actually insert an unsupervised learning model in almost either supervised or reinforcement learning as part of the system, which is really cool. Data provided is unlabeled data. The outputs are not specified. Machine makes its own predictions. Used to solve association with clustering problems. Unlabeled data is used. No supervision. Solves problems by understanding patterns and discovering output. So you can look at this and you can think some of these things go with each other. They belong together. So it's looking for what connects in different ways. And there's a lot of different algorithms that look at this. When you start getting into those, there's some really cool images that come up of what unsupervised learning is. How it can pick out, say, the area of a donut. One model will see the area of the donut, and the other one will divide it into 3 sections based on its location versus what's next to it. So there's a lot of stuff that goes in with unsupervised learning. And then we're looking at reinforcement learning. Probably the biggest industry in today's market in machine learning, or growing market. It's very infant stage as far as how it works and what it's going to be capable of. The machine learns from its environment using rewards and errors. Used to solve reward-based problems. No predefined data is used. No supervision. Follows trial and error problem solving approach. So again, we have a random, at first you start with a random, I try this, it works and this is my reward, doesn't work very well maybe, or maybe it doesn't even get you where you're trying to get it to do, and you get your reward back, and then it looks at that and says, well, let's try something else, and it starts to play with these different things, finding the best route. So let's take a look at important terms in today's reinforcement model. And this has become pretty standardized over the last few years, so these are really good to know. We have the agent. Agent is the model that is being trained via reinforcement learning. So this is your actual entity that has, however you're doing it, whether you're using a neural network or a Q table or whatever, combination thereof. This is the actual agent that you're using. This is the model. And you have your environment. The training situation that the model must optimize to is called its environment. And you can see here, I guess we have a robot who's trying to get a chest full of gems or whatever, and that's the output. And then you have your action. This is all possible steps that can be taken by the model, and it picks one action. And you can see here that it's picked 3 different routes to get to the chest of diamonds and gems. we have a state, the current position condition returned by the model. And you could look at this if you're playing like a video game. This is the screen you're looking at. So when you go back here, the environment is a whole game board. So if you're playing one of those Mobius games, you might have the whole game board going on, but then you have your current position. Where are you on that game board? What's around that? What's around you? If you were talking about a robot, the environment might be moving around the yard, where it is in the yard and what it can see, what input it has in that location. That would be the current position condition returned by the model. And then the reward. To help the model move in the right direction, it is rewarded. Points are given to it to appraise some kind of action. So, yeah, you did good, or if didn't do as good, trying to maximize the reward and have the best reward possible. And then policy. Policy determines how an agent will behave at any time. It acts as a mapping between action and present state. This is part of the model. What is your action that you're going to take? What's the policy you're using to have an output from your agent? One of the reasons they separate policy as its own entity is that you usually have a prediction of different options, and then the policy, well, how am I going to pick the best? Based on those predictions, I'm going to guess at different options, and we'll actually weigh those options in and find the best option we think will work. So it's a little tricky, but the policy thing is actually pretty cool how it works. Let's go ahead and take a look at a reinforcement learning example. And just in looking at this, we're going to take a look, consider what a dog that we want to train. So the dog would be like the agent. So you have your puppy or whatever. And then your environment is going to be the whole house or whatever it is where you're training them. And then you have an action. We want to teach the dog to fetch. So action equals fetching. And then we have a little biscuit, so we can get the dog to perform various actions by offering incentives such as a dog biscuit as a reward. The dog will follow a policy to maximize this reward, and hence will follow every command and might even learn new actions like begging by itself. So you have, so we start off with fetching. It goes, oh, I get a biscuit for that. It tries something else, and you get a handshake or begging or something like that, and it goes, oh, this is also reward based, and so it kind of explores things to find out what will bring it as biscuit. And that's very much like how a reinforced model goes. Is it looks for different rewards. How do I find? Can I try different things and find a reward that works? The dog also will want to run around and play and explore its environment. This quality of model is called exploration. So there's a little randomness going on in exploration. And it explores new parts of the house. Climbing on the sofa doesn't get a reward. In fact, it usually gets kicked off the sofa. So let's talk a little bit about Markov's decision process. Markov's decision process is a reinforcement learning policy used to map a current state to an action where the agent continuously interacts with the environment to produce new solutions and receive rewards. And you'll see here's all of our different vocabulary we just went over. We have a reward, our state, our agent, our environment, and our action. And so even though the environment kind of contains everything, that you really, when you're actually writing the program, your environment's going to put out a reward and state that goes into the agent. The agent then looks at this state, or it looks at the reward usually first, and it says, okay, I got rewarded for whatever I just did, or I didn't get rewarded. And then it looks at the state, and then it comes back, and if you remember from policy, the policy comes in, and then we have a reward. The policy is that part that's connected at the bottom. And so it looks at that policy and it says, hey, what's a good action that will probably be similar to what I did, or sometimes they're completely random, but what's a good action that's going to bring me a different reward? So taking the time to just understand these different pieces as they go is pretty important in most of the models today. And so a lot of them actually have templates based on this you can pull in and start using. Pretty straightforward as far as once you start seeing how it works, you can see your environment says, hey, this is the agent did this. If you're a character in a game, this happened, and it shoots out a reward in a state. The agent looks at the reward, looks at the new state, and then takes a little guess and says, I'm going to try this action. And then that action goes back into the environment. It affects the environment. The environment then changes depending on what the action was. And then it has a new state and a new reward that goes back to the agent. So in the diagram shown, we need to find the shortest path between node A and D. Each path has a reward associated with it, and the path with the maximum reward is what we want to choose. The nodes A, B, C, D denote the nodes to travel from node A to B is an action. Reward is the cost of each path, and policy is each path taken. And you can see here A can go to B, or A can go to C right off the bat, or it can go right to D. And if you explored all three of these, you would find that A going to D was a 0 reward, A going to C and D would generate a different reward, or you could go A, C, B, D. There's a lot of options here. And so when we start looking at this diagram, you start to realize that even though today's reinforced learning models do really good at finding an answer, they end up trying almost all the different directions you see. And so they take up a lot of work or a lot of processing time for reinforcement learning. They're right now in their infant stage, and they're really good at solving simple problems. And we'll take a look at one of those in just a minute in a tic-tac-toe game. But you can see here, once it's gone through these and it's explored, it's going to find the A, C, D is the best reward. It gets a full 30 points for it. So let's go ahead and take a look at a reinforcement learning demo. In this demo, we're going to use reinforcement learning to make a tic-tac-toe game. You will be playing this game against the machine learning model. And we'll go ahead, and we're doing it in Python. So let's go ahead and go through, not always, I actually have a lot of Python tools. Let's go through Anaconda, which will open up a Jupyter notebook. Seems like a lot of steps, but it's worth it to keep all my stuff separate, and it also has a nice display when you're in the Jupyter notebook for doing Python. So here's our Anaconda navigator. I open up the notebook, which is going to take me to a web page, and I've gone in here and created a new Python folder. In this case, I've already done it and enabled it to change the name to tic-tac-toe. And then for this example, we're going to go ahead and import a couple things. We're going to import numpy as np. We'll go ahead and import pickle. Numpy, of course, is our number array, and then pickle is just a nice way sometimes for storing different information, different states that we're going to go through on here. And so we're going to create a class called state. We're going to start with that. And there's a lot of lines of code to this class that we're going to put in here. Don't let that scare you too much. There's not as much here. It looks like there's going to be a lot here, but there really is just a lot of setup going on in our class state. And so we have up here, we're going to initialize it. We have our board. It's a tic-tac-toe board, so we're only dealing with 9 spots on the board. We have player 1, player 2 is end. We're going to create a board hash. We'll look at that in just a minute. We're just going to store some information in there. Symbol of player equals 1. So there's a few things going on as far as the initialization. Then something simple, we're just going to get the hash of the board. We're going to get the information from the board on there, which is columns and rows. We want to know when a winner occurs, so if you get 3 in a row, that's what this whole section here is for. Let me go ahead and scroll up a little bit. And you can get a copy of this code if you send a note over to Simplilearn. We'll send you over this particular file, and you can play with it yourself and see how it's put together. I don't want to spend a huge amount of time on this because this is just some real general Python coding. But you can see here we're just going through all the rows, and you add them together, and if it equals 3 in a row. Same thing with columns. Diagonal, so you got to check the diagonal. That's what all this stuff does here, so it just goes through the different areas. Actually, let me go ahead and put, there we go. And then it comes down here and we do our sum, and it says true, -3 just says did somebody win, or is it a tie? So you got to add up all the numbers on there anyway, just in case they're all filled up. And next we also need to know available positions. These are ones that no one's ever used before. This way when you try something, or the computer tries something, it's not going to give it an illegal move. That's what the available positions is doing. Then we want to update our state. And so you have your position going in. We're just sending in the position that you just chose. And you'll see there's a little user interface we put in there. You can pick the row and column in there. And again, I mean, this is a lot of code. So really it's kind of a thing you'd want to go through and play with a little bit and just read through it, get a copy of it. A great way to understand how this works. And here is a given reward. So we're going to give a reward, result equals self winner. This is one of the hearts of what's going on here, is we have a result self.winner. So if there's a winner, then we have a result. If the result equals 1, here's our feedback. If it doesn't equal 1, then it gets a 0. So it only gets a reward in this particular case if it wins. And that's important to know because different systems of reinforced learning do rewarding a lot differently depending on what you're trying to do. This is a very simple example with a 3x3 board. Imagine if you're playing a video game, certainly you only have so many actions, but your environment is huge. You have a lot going on in the environment. And suddenly a reward system like this is going to be just, is going to have to change a little bit. It's going to have different rewards and different setup. And there's all kinds of advanced ways to do that as far as weighing, you add weights to it. And so they can add the weights up depending on where the reward comes in. So it might be that you actually get a reward. In this case, you get the reward at the end of the game. And I'm spending just a little bit of time on this because this is an important thing to note. But there's different ways to add up those rewards. It might have, like if you take a certain path, the first reward is going to be weighed a little bit less than the last reward because the last reward is actually winning the game or scoring or whatever it is. So this reward system gets really complicated in some of the more advanced setups. In this case, though, you can see right here that they give a 0.1 and a 0.5 reward just for picking the right value and something that's actually valid instead of picking an invalid value. So rewards, again, that's like key. It's huge. How do you feed the rewards back in? Then we have a board reset. That's pretty straightforward. It just goes back and resets the board to the beginning because it's going to try out all these different things while it's learning. It's going to do it by trial and error, so you have to keep resetting it. And then, of course, there's the play. We want to go ahead and play rounds equals 100. Depends on what you want to do on here. You can set this different. You can obviously set that to higher level. But this is just going to go through, and you'll see in here that we have player 1 and player 2. This is the computer playing itself. One of the more powerful ways to learn to play a game or even learn something that isn't a game is to have two of these models that are basically trying to beat each other. And so they keep explore new things. This one works for this one, so this one tries new things. It beats this. We've seen this in chess, I think was a big one, where they had the two players in chess with reinforcement learning. It was one of the ways they trained one of the top computer chess playing algorithms. So this is just what this is. It's going to choose an action, it's going to try something, and the more it tries stuff, the more we're going to record the hash. We actually have a board hash where you yourself get the hash set up on here where it stores all the information. And then once you get to a win, one of them wins, it gets the reward. Then we go back and reset and try again. And then kind of the fun part we actually get down here is we're going to play with a human. So we'll get a chance to come in here and see what that looks like when you put your own information in. And then it just comes in here and does the same thing it did above. It gives it a reward for its things, or sees if it wins or ties, looks at available positions, all that kind of fun stuff. And then finally we want to show the board. So it's going to print the board out each time. Really, as an integration, is not that exciting. What's exciting in here is, one, looking at this reward system. Whoops, play one more up. The reward system is really the heart of this. How do you reward the different setup? And the other one is when it's playing, it's got to take an action. And so what it chooses for an action is also the heart of reinforcement learning. How do we choose that action? And those are really key to right now where reinforcement learning is in today's technology, is figuring this out. How do we reward it, and how do we guess the next best action? So we have our environment, and you can see the environment is or the state, which is kind of like what's going on. We're going to return the state depending on what happens. And we want to go ahead and create our agent, in this case our player. So each one is, let me go and grab that. And so we look at a class player. This is where a lot of the magic is really going on, is how is this player figuring out how to maneuver around the board, and then the board of course returns a state that it can look at and a reward. So we want to take a look at this. We have name, self-state, this is class player, and when we say class player, we're not talking about a human player, we're talking about just the computer players. And this is kind of interesting, so remember I told you depending on what you're doing there's going to be a decay gamma, explore rate. These are what I'm talking about, is how do we train it. As you try different moves, it gets to the end, the first move is important, but it's not as important as the last one. And so you could say that the last one has the heaviest weight, and then as you get there, the first one, let's see, the first move gives you a 5 reward, the second gives you a 2 reward, and the third one gives you a 10 reward, because that's the final ending. You got it. The 10's going to count more than the first step. And here's our, we're going to get the board information coming in, and then choose an action. This was the second part that I was talking about that was so important. So once you have your training going on, we have to do a little randomness, and you can see right here is our NP random uniform. So it's picking out a random number. Take a random action. This is going to just pick which row and which column it is. And so choosing the action, this one you can see we're just doing random states, choice, length of positions, action position, and then it skips in there and takes a look at the board. For P in positions, it's actually storing the different boards each time you go through. So it has a record of what it did, so it can properly weigh the values. And this simply just appends a hash state. What's the last state? Append it to the to our states on here. Here's our feedback reward. So the reward comes in, and it's going to take a look at this and say, is it none? What is the reward? And here is that formula. Remember I was telling you about up here that was important because it has decay gamma times the reward. This is where, as it goes through each step, and this is really important, this is kind of the heart of this, of what I was talking about earlier. You have step 1, and this might have a reward of 2. You have step 2, I probably should have done ABC. This has a step 3, step 4, and so on until you get to step N, and this might have a reward of 10. So reward of 10, we're going to add that, but we're not adding, let's say this one right here, let's say this reward here right before 10 was, let's say it's also 10. That just makes the math easy. So we had 10 and 10. We had 10, this is 10 and 10n, whatever it is, but it's 0.9. So instead of putting a full 10 here, we only do 9. That's 0.9 times 10. And so this formula, as far as the decay times the reward minus the cell state value, it basically adds in, it says here's 1, or here's 2, I'm sorry, I should have done this ABC, it would have been easier. So the first move goes in here and it puts 2 in here. Then we have our self set up on here. You can see how this gets pretty complicated in the math, but this is really the key, is how do we train our states? And we want the final state, the win, to get the most points. If you win, you get most points. And the first step gets the least amount of points. So you're really training this almost in reverse. You're training it from the last place where you have, like it says, okay, this is now where I need to sum up my rewards, and I want to sum them up going in reverse, and I want to find the answer in reverse. Kind of an interesting play on the mind when you're trying to figure this stuff out. And of course we want to go ahead and reset the board down here and save the policy, load policy. These are the different things that are going in between the agent and the state to figure out what's going on. Let's go ahead and load that up. And then finally we want to go ahead and create a human player. And the human player is going to be a little different in that you choose an action, row and column. Here's your action. If action in positions, meaning positions that are available, you return the action. If not, it just keeps asking you until you get the action that actually works. And then we're going to go ahead and append to the hash state, which we don't need to worry about because it returns the action up here. And feed forward. Again, this is because it's a human. At the end of the game, propagate and update state values. This part isn't being done because it's not programming the model. The model is getting its own rewards. So we've gone ahead and loaded this in here. So here's all our pieces, and the first thing we want to do is set up P1 player 1, P2 player 2, and then we're going to send our players to our state. So now it has P1, P2, and it's going to play, 50,000 rounds. Now we can probably do a lot less than this, and it's not going to get the full results. In fact, you know what? Let's go ahead and just do 5, just to play with it, because I want to show you something here. Oops, somewhere in there I forgot to load something. There we go. I must have forgot to run this. Run. Oops, forgot a reference there for the board, rows and columns, 3 by 3. There's actually in the state, it references that. We can just tack it on the end. It was supposed to be at the beginning. So now I've only set this up with, let's see, where are we going here? I've only set this up to train 5 times. And the reason I did that is we're going to come in and actually play it, and then I'm going to change that, and we can see how it differs on there. There we go. And it didn't even make it through a run, and we're going to go ahead and save the policy. So now we have our player 1 and our player 2 policy. The way we set it up, it has 2 separate policies loaded up in there. And then we're going to come in here and we're going to do player 1 is going to be the computer, experience rate 0, load policy 1, human player human, and we're going to go ahead and play this. Now remember, I only went through it just 1 round of training, in fact minimal training. And so it puts an X there, and I'm going to go ahead and do row 0, column 1. You can see this is very basic on here. And so I put in my 0, and then I'm going to go 0, block it, 0, 0. And you can see right here, it let me win. Just like that, I was able to win. 0, 2, and woo, human wins. So I only trained it 5 times. We're going to run this again, and this time, instead of 5, let's do 5,000 or 50,000. I think that's what the guys in the back had. And this takes a while to train it. This is where reinforcement learning really falls apart. Look how simple this game is. We're talking about a 3 by 3 set of columns. And so for me to train it on this, I could do a Q table which would go much quicker. You could build a quick Q table with almost all the different options on there, and you would probably get the same result much quicker. We're just using this as an example. So when we look at reinforcement learning, you need to be very careful what you apply it to. It sounds like a good deal until you do like a large neural network where you're doing, you set the neural network to a learning increment of 1. So every time it goes through, it learns. And then you do your actions. So you pick from the learning setup, and you actually try actions on the learning setup until you get what you think is going to be the best action. So you actually feed what you think is right back through the neural network. There's a whole layer there, which is really fun to play with. And then it has an output. Well, think of all those processes. I mean, that is just a huge amount of work it's going to do. Let's go ahead and skip ahead here. give it a moment. It's going to take a minute or two to go ahead and run. Now, to train it, we went ahead and let it run, and it took a while. This took, I got a pretty powerful processor, and it took about 5 minutes plus to run it. And we'll go ahead and run our player setup on here. Oops, it brought in the last, whoops, it brought in the last round. So give me just a moment to redo the policy save. There we go, I forgot to save the policy back in there. And then go ahead and run our player again. So we've saved the policy, and then we want to go ahead and load the policy for P1 as a computer. And we can see the computer's gone in the bottom right corner. I'm going to go ahead and go 1, 1, which is the center. And it's gone right up the top, and if you have ever played tic-tac-toe, you know the computer has me. But we'll go ahead and play it out. Row 0, column 2. There it is, and then it's gone here, and so I'm going to go ahead and go row 0, 1, 2, no, 0, 1, there we go, and column 0. That's where I wanted. Oh, and it says, okay, your action, there we go, boom. So you can see here, we've got didn't catch the win on this, it said tie. Kind of funny that it didn't catch the win on there. But if we play this a bunch of times, you'll find that it's going to win more and more. The more we train it, the more the reinforcement happens. This lengthy training process is really the stopper on reinforcement learning. As this changes, reinforcement learning will be one of the more powerful packages evolving over the next decade or two. In fact, I would even go as far as to say it is the most important machine learning tool and artificial intelligence tool out there, as it learns not only a simple tic-tac-toe board, but we start learning environments. And the environment would be like in language. If you're translating a language or something from one language to the other, so much of it is lost if you don't know the context it's in, what's the environments it's in. And so being able to attach environment and context and all those things together is going to require reinforcement learning to do. So again, if you want to get a copy of the tic-tac-toe board, it's kind of fun to play with. Run it, you can test it out, you can do test it for different values. You can switch from P1 computer where we loaded the policy 1 to load the policy 2 and just see how it varies. There's all kinds of things you can do on there. So what is Q-learning? Q-learning is reinforcement learning policy which will fill the next best action given a current state. It chooses this action at random and aims to maximize the reward. And so you can see here's our standard reinforcement learning graph. By now, if you're doing any reinforcement learning, you should be familiar with this, where you have your agent takes an action, the action affects the environment, and then the environment sends back the reward or the feedback, and the state, it's the new state the agent's in. Where is it at on the chessboard? Where is it at in the video game? If your robot's out there picking trash up off the side of the road, where is it at on the road? Consider an ad recommendation system. Usually when you look up a product online, you get ads which will suggest the same product over and over again. Using Q-learning, we can make an ad recommendation system which will suggest related products to our previous purchase. The reward will be if user clicks on the suggested product. And again, you can see you might have a lot of products on your web advertisement or your pages, but it's still not a float number. It's still a set number, and that's something to be aware of when you're using Q-learning. And you can see here that if you have 100 people clicking on ads and you click on one of the ads, it might go in there and say, okay, this person clicked on this ad. What is the best set of ads based on clicking on this ad or these two ads afterwards based on where they are browsing? So let's go ahead and take a look at some important terms when we talk about Q-learning. We have state. The state S represents the current position of an agent in an environment. The action A is the step taken by the agent when it is particular state. Rewards. For every action, the agent will get a positive or negative reward. And again, when we talk about states, we're usually not, when you're using a Q table, you're not usually talking about float variables. You're talking about true, false. And we'll take a closer look at that in a second. And episodes, when an agent ends up in a terminating state and can't take a new action. This might be if you're playing a video game, your character stepped in and is now dead or whatever. Q values used to determine how good an action A taken at a particular state S is Q A of S. And temporal difference, a formula used to find the Q value by using the value of the current state and action and previous state and action. And there's Bellman's equation, which basically is the equation that kind of covers what we just looked at in all those different terms. The Bellman equation is used to determine the values of a particular state and deduce how good it is to be in take that state. The optimal state will give us the highest optimal value. Factor influencing Q values, the current state and action, that's your SA, so your current state and your action. Then you have your previous state and action, which is your S, I guess prime, I'm not sure how they reference that, S prime, A prime. So this is what happened before. Then you have a reward for action, so you have your R reward, and you have your maximum expected future reward. And you can see there's also a learning rate put in there and a discount rate. So when we're looking at these, just like any other model, we don't want to have an absolute final value on here. We don't want it to, if you do absolute values instead of taking smaller steps, you don't really have that approach to the solution. You just have a jump, and then pretty soon if you jump one solution out, that's what's going to be the new solution, whichever one jumps up really high first. Kind of ruining the whole idea of doing a random selection. I'll go into the random selection in just a second. Steps in Q learning. Step 1. Create an initial Q table with all values initialized to 0. Again, we're looking at 0, 1. So here's our action. We start, we're in idle, we took a wrong action, we took a correct action, and end. And then we have our actions, fetching, sitting, and running. And of course, we're just using the dog example. And choose an action and perform it. Update values in the table. And of course, when we're choosing an action, we're going to kind of do something random and just randomly pick one. So you start out and you sit, and you have then depending on that action you took, you can now update the value for sitting after you start, from start to sitting. Get the value of the reward and calculate the value Q value using the Bellman equation. And so now we attach a reward to sitting. And when we attach all those rewards, we continue the same until the table is filled with or an episode ends. And I mentioned I was going to come back to the random side of this. And there's a few different formulas I use for the random setup to pick it. I usually let whatever Q model I'm using do their standard one, because someone's usually gone in and done the math for the optimal spread. But you can look at this. If I have running has a reward of 10, sitting has a reward of 7, fetching has a reward of 5, just kind of without doing like a means, using the bell curve for the means value, and like I said, there's some math you can put in there to pick so that you're more likely, so that running has even a higher chance. But even if you were just going to do an average on this, you could do a random number by adding them all together. So you get 10 plus 7 plus 5 is 22. You could do 0 to 22, or 0 to 21, but 1 to 22. 1 to 5 would be fetching, and so forth, the last 10. So you can just look at this as what percentage are you going to go for that particular option. And then that gets your random setup in there, and then as you slowly increment these up, you see that if you're idle, where's one? Here we go. Sitting at the end. If you're at the end of wherever you're at, sitting gets a reward of 1. Where's a good one on here? Oh, wrong action. Running for a wrong action gets almost no reward. So that becomes very, very less likely to happen, but it still might happen. It still might have a percentage of coming up. And that's where the random programming and Q learning comes in. The below table gives us an idea of how many times an action has been taken and how positively correct action or negatively wrong action it is going to affect the next state. So let's go ahead and dive in and pull up a little piece of code and see what this looks like in Python. In this demo, we'll use Q learning to find the shortest path between two given points.
If getting your learning started is half the battle, what if you could do that for free? Visit Skill Up by Simplilearn. Click on the link in the description to know more.
If you've seen my videos before, I like to do it in the Anaconda Jupyter Notebook setup, just because it's really easy to see and it's a nice demo. And so here's my Anaconda. This one I'm actually using Python 3.6 environment that I set up in here. And we'll go ahead and launch the Jupyter Notebook on this. And once we're in our Jupyter Notebook, which has the kernel loaded with Python 3, we'll go ahead and create a new Python 3 folder in here. And we'll call this Q Learning. And to start this demo, let's go ahead and import our NumPy array. We'll just run that so it's imported. And like a lot of these model programs, when you're building them, you spend a lot of time putting it all together, and then you end up with this really short answer at the end. And we'll take a look at that as we come into it. So we go ahead and start with our location to state. So we have L1, L2. These are our 9 locations, 1 to 9. And then of course the state is going to be 0, 1, 2, 3, 4. It's just a mapping of our location to a integer on there. And then we have our actions. Our actions are simply moving from one location to another. So I can go to location 0, I can go to location 1, 2, 3, 4, 5, 6, 7, 8. So these are my actions I can choose. These are the locations of our state. And if you remember earlier, I mentioned that the limitation is that you don't want to put in a continually growing table, because you can actually create a dynamic queue table where you continually add in new values as they arise. Because if you have float values, it just becomes infinite, and then your memory in your computer is gone, or it's not going to work. At the same time, you might think, well, that kind of really limits the queue learning setup. But there are ways to use it in conjunction with other systems. And so you might look at, well, I've been doing some work in stock. And one of the questions that comes out is to buy or sell the stock. And the state coming in might be, you might take it and create what we call buckets, where anything that you predict is going to return more than a certain amount of money, the error for that stock that you've had in the past, you put those in buckets, and suddenly you start creating these buckets, you realize you do have a limited amount of information coming in. You no longer have a float number. You now have bucket 1, 2, 3, and 4. And then you can take those buckets, put them through a queue learning table, and come up with the best action. Which stock should I buy? It's like gambling. Stock is pretty much gambling if you're doing day trading. You're not doing long-term investments. And so you can start looking at it like that. A lot of the current feeds say that the best algorithms used for day traders, where you're doing it on your own, is really to ask the question, do I want to trade the stock? Yes or no? And now you have it in a queue learning table, and now you can take it to that next level, and you can see where that can be a really powerful tool at the end of doing a basic linear regression model or something. What is the best investment? And you start getting the best reward on there. So if we're going to have rewards, these rewards we just create. It says if you're this should match our queue table, because it's going to be you have your state and you have your action across the top, if you remember from the dog. And so we have whatever state we're in going down, and then the next action and what the reward is for it. And of course, if you were actually doing something more connected, your reward would be based on the actual environment it's in. And then we want to go ahead and create a state to location so we can map the indexes. So just like we defined our rewards, we're going to go ahead and do state to location. And you can see here it's a dictionary setup for location state and location to state with items. And we also need to define what we want for learning rates. You remember we had our two different rates. as far as like learning from the past and learning from the current. So we'll go ahead and set those to 0.75 and the alpha set to 0.9. And we'll see that when we do the formula. And of course, any of this code, send a note to our Simplilearn team. They'll get you a copy of this code on here. And let's go ahead and pull. There we go. Well, the next two sections. Since we're going to keep it short and sweet. Here we go. So let's go ahead and create our agent. So our agent is going to have our initialization where we send it all the information. We'll define our self gamma equals gamma. We could have just set the gamma rate down here instead of submitting it. It's kind of nice to keep them separate because you can play with these numbers. And our self alpha. Then we have our location state. We'll set that in here. We have our choice of actions. We're going to go ahead and just embed the rewards right into the agent. So obviously this would be coming from somewhere else instead of from self-generated. And then a self state to location equals our state to location dictionary. And we go ahead and create a Q learning table. And I went ahead and just set the Q learning table up to 0 to 0, what the setup is, location to state, how many of them are there. And this just creates an array of 0 to 0 setup on there. And then the big part is the training. We have our rewards new equals a copy of self.rewards. Ending state equals the self location state in location. So this is whatever we end up at. Rewards new equals ending state plus ending state equals 999. Just kind of goes to a dead end. And we start going through iterations. And we'll go ahead, let's do this. So this, we're going to come back and we're going to call it on here. Let me just erase that. Switch it to an arrow. There we go. So what we're doing is we're going to send in here to train it. We're going to say, hey, I want to iterate through this 1,000 times and see what happens. Now this part would actually be, instead of iterating, you might have your external environment and they're going back and forth and you iterate through outside of here. But just for ease of use, our agent's going to come in here and iterate through this. Sometimes I'll put this iteration in here and I'll have it call the environment and say, hey, this is what I did, what's the next state? And the environment does its thing right in here as I iterate through it. And then we want to go ahead and pick a random state to start with. That's what's going on here. You have to start somewhere. And then you have your playable actions. We're going to start with just an empty thing for playable actions and we'll fill that up. So that's what choices I have. And so we're going to iterate through the rewards matrix to get the states. Directly reachable from the randomly chosen current state. Assign those states to a list named playable actions. And so you can see here we have range 9. I usually use length of whatever I'm looking at, which is our locations or states as they are. We have a reward. So we want to look at the rewards. The new reward is is in our chart here of rewards underscore new current state plus J. J being what is the next state we want to try. And so we go ahead and do our playable actions and we append J. And so what we're doing is we're randomly trying different things in here to see what's going to generate a better reward. And then of course we go ahead and choose our next state. So we have our random choice playable actions. And if you remember, I mentioned on this, let me just go ahead and, let's do a free form. When we were talking about the next state, this right here just does a random selection. Instead of a random selection, you might do something where whatever the best selection is, which might be option 3 here, and then so you can see that it might use a bell curve, and then option 2 over here might have a bell curve like this. Oops. And we start looking at these averages and these spreads, or we can just add them all together and pick the one that kind of goes in all of those. So those are some of the options we have in here. We just go with a random choice. That's usually where you start, play with it. And then we have our reward section down here. And so we want to go ahead and find, well, in this case, the temporal difference. So you have your rewards new plus the self gamma, and this is the formula we were looking at. This is Bellman's equation here. So we have our current value, our learning rate, our discount rate involved in there, the reward system coming in for that, and we can add it all together. This is, of course, our maximum expected future setup in here. So this is all of our Bellman's equation that we're looking at here. And then we come up in here and we update our Q table. That's all this is on this one. And that's right here. We have self Q, current state, next state, and we add in our alpha because we don't want to train all of it at once in case there's slight differentials coming in there. We want to slowly approach the answer. And then we have our route equals the start location, and next location equals start location. So we're just incrementing. We took a step forward. And then finally, remember I was telling you how we're going to do all this and just have some simple thing at the end where it just generates a simple path. We're going to go ahead and get the optimal route. We want to find the best route in here. And so we've created a definition for the optimal route down here. Just scroll down for that. And we get the optimal route. We go ahead and put the information in, including the Q table, self, start location, end location, next location, route, Q. And it says while next location is not equal to end location, so while we can still go, our start location equals self location to state start location. So we already have our best value for the start location. The next state looks at the Q table and says, hey, what's the next one with the best value? And then the next location, we go ahead and pull that in and we just append it. That's what's going on down here. And then our start location equals the next location. And we just go through all the steps. And we'll go ahead and run this. And now that we have our Q table, our Q agent loaded, we're going to go ahead and take our Q agent, load them up with our alpha, gamma that we set up above, along with the location step, action, reward, state to location. And our goal is to plot a course between L9 and L1. And we're going to go through 1,000 iterations on here. And so when I run that, it runs pretty quick. Why is this so fast? If you've been running neural networks and you've been doing all these other models, you sit here and wait a long time. Well, we're a very small amount of data. These are all integers. These aren't float values. The math is not heavy on the processing end, and this is where Q tables are so powerful. If you have a small amount of information coming in, you very quickly get an answer off of this, even though we went through it 1,000 times to train it. And you'll see here we have L9, 8, 5, 2, and 1, and that's based on our reward table we had set up on there. And this is the shortest path going between these different setups in here. And if you remember on our reward table, you can see that if you start here, you can go to here. There's places you can't go. That's how this reward table was set up. So I can only go to certain places. So kind of a little maze set up in there. And you can play with it. This is really fun setup to play with. And you can see how you can take this whole code and you can, like I was saying earlier, you can embed it into another setup and model and predictions where you put things into buckets and you're trying to guess the best investment, the best course of action. As long as you can take that course of action and reduce it down to a yes, no. Or if you're using text, you can use a one-hot encoder, which word is next. There's all kinds of things you can do with a Q table, depending on just how much information you're putting in there. So that wraps up our demo. In this demo, we've found the shortest distance between two paths based on whatever rules or state rewards we have to get from point A to point B and what available actions there are.
Hello and welcome to this tutorial on deep learning. My name is Mohan, and in the next about 1.5 hours I will take you through what is deep learning and into TensorFlow environment to show you an example of deep learning. Now, there are several applications of deep learning, really very interesting and innovative applications, and one of them is identifying the geographic location based on a picture. And how does this work? The way it works is pretty much we train an artificial neural network with millions of images which are tagged, their geolocation is tagged, and then when we feed a new picture, it will be able to identify the geolocation of this new image. For example, you have all these images, especially with maybe some significant monuments or significant locations, and you train with millions of such images, and then when you feed another image, it need not be exactly one of those that you have trained. It can be completely different. That is the whole idea of training. It will be able to recognize, for example, that this is a picture from Paris because it is able to recognize the Eiffel Tower. So the way it works internally, if we have to look a little bit under the hood, is these images are nothing but this is digital information in the form of pixels. So each image could be a certain size. It can be 256 by 256 pixel kind of a resolution, and then each pixel is either having a certain grade of color, and all that is fed into the neural network, and it then gets trained in, and it's able to, based on these pixel information, it is able to get trained and able to recognize the features and extract the features, and thereby it is able to identify these images and the location of these images. And then when you feed a new image, it kind of, based on the training, it will be able to figure out where this image is from. So that's the way, a little bit under the hood, how it works. So what are we going to do in this tutorial? We will see what is deep learning and what do we need for deep learning, and one of the main components of deep learning is neural networks. So we will see what is neural network, what is a perceptron, and how to implement logic gates like AND, OR, NOR, and so on using perceptrons, the different types of neural networks, and then applications of deep learning. And we will also see how neural networks works. So how do we do the training of neural networks? And at the end, we will end up with a small demo code which will take you through in TensorFlow. Now, in order to implement deep learning code, there are multiple libraries or development environments that are available, and TensorFlow is one of them. So the focus at the end of this would be on how to use TensorFlow to write a piece of code using Python as a programming language. And we will take up an example which is a very common one, which is like the hello world of deep learning, the handwriting number recognition, which is a MNIST, commonly known as MNIST database. So we will take a look at MNIST database and how we can train a neural network to recognize handwritten numbers. So that's what you will see in this particular video. So let's get started. What is deep learning? Deep learning is like a subset of what is known as a high-level concept called artificial intelligence. You must be already familiar, must have heard about this term, artificial intelligence. So artificial intelligence is like the high-level concept, if you will. And in order to implement artificial intelligence applications, we use what is known as machine learning. And within machine learning, a subset of machine learning is deep learning. Machine learning is a little bit more generic concept, and deep learning is one type of machine learning, if you will. And we will see a little later in maybe the following slides a little bit more in detail how deep learning is different from traditional machine learning. But to start with, we can mention here that deep learning uses one of the differentiators between deep learning and traditional machine learning is that deep learning uses neural networks. And we will talk about what are neural networks and how we can implement neural networks and so on and so forth as a part of this tutorial. So a little deeper into deep learning. Deep learning primarily involves working with complicated unstructured data compared to traditional machine learning where we normally use structured data. In deep learning, the data would be primarily images or voice or maybe text file. So and it is large amount of data as well. And deep learning can handle complex operations. It involves complex operations. And the other difference between traditional machine learning and deep learning is that the feature extraction happens pretty much automatically. In traditional machine learning, feature engineering is done manually. The data scientists, we data scientists have to do feature engineering, feature extraction. But in deep learning, that happens automatically. And of course, deep learning, for large amounts of data, complicated unstructured data, deep learning gives very good performance. Now, as I mentioned, one of the secret sources of deep learning is neural networks. Let's see what neural networks is. Neural networks is based on our biological neurons. The whole concept of deep learning and artificial intelligence is based on human brain, and human brain consists of billions of tiny stuff called neurons, and this is how a biological neuron looks, and this is how an artificial neuron looks. So neural networks is like a simulation of our human brain. Human brain has billions of biological neurons, and we are trying to simulate the human brain using artificial neurons. This is how a biological neuron looks. It has dendrites, and the corresponding component with an artificial neural network is, or an artificial neuron, are the inputs. They receive the inputs through dendrites. And then there is the cell nucleus, which is basically the processing unit in a way. So in artificial neuron also there is a piece which is an equivalent of this cell nucleus, and based on the weights and biases, we will see what exactly weights and biases are as we move. The input gets processed, and that results in an output. In a biological neuron, the output is sent through a synapse, and in an artificial neuron there is an equivalent of that in the form of an output. And biological neurons are also interconnected. So there are billions of neurons which are interconnected. In the same way, artificial neurons are also interconnected. So this output of this neuron will be fed as an input to another neuron, and so on. Now, in neural network, one of the very basic units is a perceptron. So what is a perceptron? A perceptron can be considered as one of the fundamental units of neural networks. It can consist at least of one neuron, but sometimes it can be more than one neuron. But you can create a perceptron with a single neuron, and it can be used to perform certain functions. It can be used as a basic binary classifier. It can be trained to do some basic binary classification, and this is how a basic perceptron looks like. And this is nothing but a neuron. You have inputs x1, x2, to xn, and there is a summation function, and then there is what is known as an activation function. And based on this input, what is known as the weighted sum, the activation function either gives an output like a 0 or a 1. So we say the neuron is either activated or not. So that's the way it works. So you get the inputs. These inputs are, each of the inputs are multiplied by a weight, and there is a bias that gets added, and that whole thing is fed to an activation function, and then that results in an output. And if the output is correct, it is accepted. If it is wrong, if there is an error, then that error is fed back, and the neuron then adjusts the weights and biases to give a new output, and so on and so forth. So that's what is known as the training process of a neuron or a neural network. There's a concept called perceptron learning. So perceptron learning is again one of the very basic learning processes. The way it works is somewhat like this. So you have all these inputs like x1 to xn, and each of these inputs is multiplied by a weight, and then that sum, this is the formula or the equation. So that sum, wi xi sigma of that, which is the sum of all these product of x and w, is added up, and then a bias is added to that. The bias is not dependent on the input or the input values, but the bias is common for one neuron. However, the bias value keeps changing during the training process. Once the training is completed, the values of these weights, W1, W2, and so on, and the value of the bias gets fixed. So that is basically the whole training process, and that is what is known as the perceptron training. So the weights and biases keep changing till you get the accurate output. And the summation is of course passed through the activation function. As you see here, this WIXI summation plus B is passed through activation function, and then the neuron gets either fired or not. And based on that, there will be an output. That output is compared with the actual or expected value, which is also known as labeled information. So this is the process of supervised learning. So the output is already known, and that is compared, and thereby we know if there is an error or not. And if there is an error, the error is fed back, and the weights and biases are updated accordingly till the error is reduced to the minimum. So this iterative process is known as perceptron learning or perceptron learning rule, and this error needs to be minimized. So till the error is minimized, this iteratively the weights and biases keep changing, and that is what is the training process. So the whole idea is to update the weights and the bias of the perceptron till the error is minimized. The error need not be zero. The error may not ever reach zero, but the idea is to keep changing these weights and bias so that the error is minimum, the minimum possible that it can have. So this whole process is an iterative process, and the iteration continues till either the error is zero, which is unlikely situation, or it is the minimum possible within these given conditions. Now, in 1943, two scientists, Warren McCulloch and Walter Pitts, came up with an experiment where they were able to implement the logical functions like AND, OR, and NOR using neurons. And that was a significant breakthrough in a sense. So they were able to come up with the most common logical gates. They were able to implement some of the most common logical gates, which could take two inputs like A and B and then give a corresponding result. So for example, in case of an AND gate, A and B, and then the output is AB. In case of an OR gate, it is A plus B, and so on and so forth. And they were able to do this using a single layer perceptron. Now, most of these gates, it was possible to use single layer perceptron except for XOR, and we will see why that is in a little bit. So this is how an AND gate works. The inputs A and B, the output should be fired, or the neuron should be fired only when both the inputs are 1. So if you have 0, 0, the output should be 0. For 0, 1, it is again 0, 1, 0, again 0, and 1, 1, the output should be 1. So how do we implement this with a neuron? So it was found that by changing the values of weights, it is possible to achieve this logic. So for example, if we have equal weights like 0.7, 0.7, and then if we take the sum of the weighted product, so for example 0.7 into 0, and then 0.7 into 0 will give you 0, and so on and so forth. And in the last case, when both the inputs are 1, you get a value which is greater than 1, which is the threshold. So only in this case the neuron gets activated, and the output is, there is an output. In all the other cases, there is no output because the threshold value is 1. So this is implementation of an AND gate using a single perceptron or a single neuron. Similarly, an OR gate. In order to implement an OR gate, in case of an OR gate, the output will be 1 if either of these inputs is 1. So for example, 0, 1 will result in 1, or rather, in all the cases it is 1 except for 0, 0. So how do we implement this using a perceptron? Once again, if you have a perceptron with weights, for example 1.2, now if you see here, if in the first case when both are 0, the output is 0. In the second case, when it is 0 and 1, 1.2 into 0 is 0, and then 1.2 into 1 is 1. And in the second case, similarly, the output is 1.2. In the last case, when both the inputs are 1, the output is 2.4. So during the training process, these weights will keep changing, and then at one point where the weights are equal to W1 is equal to 1.2 and W2 is equal to 1.2, the system learns that it gives the correct output. So that is implementation of OR gate using a single neuron or a single layer perceptron. Now XOR gate. This was one of the challenging ones. They tried to implement an XOR gate with a single level perceptron, but it was not possible. And therefore, in order to implement an XOR, so this was like a roadblock in the progress of neural network. However, subsequently they realized that this can be implemented, an XOR gate can be implemented using a multi-level perceptron or MLP. So in this case, there are two layers instead of a single layer, and this is how you can implement an XOR gate. So you will see that X1 and X2 are the inputs, and there is a hidden layer, and that's why it is denoted as H3 and H4, and then you take the output of that and feed it to the output at O5 and provide a threshold here. So we will see here that this is the numerical calculation. So the weights are, in this case for X1 it is 20 and minus 20, and once again 20 and minus 20. So these inputs are fed into H3 and H4. So you will see here for H3 the input is 0 1 1 1, and for H4 it is 1 0 1 1. And if you now look at the output, final output, where the threshold is taken as 1, if we use a sigmoid with the threshold 1, you will see that in these two cases it is 0, and in the last two cases it is 1. So this is the implementation of XOR. In case of XOR, only when one of the inputs is 1, you will get an output. So that is what we are seeing here. If we have either both the inputs are 1 or both the inputs are 0, then the output should be 0. So that is what is an exclusive OR gate. So it is exclusive because only one of the inputs should be 1, and then only you will get an output of 1, which is satisfied by this condition. So this is a special implementation. XOR gate is a special implementation of perceptron. Now that we got a good idea about perceptron, let's take a look at what is a neural network. So we have seen what is a perceptron, we have seen what is a neuron, so we will see what exactly is a neural network. So neural network is nothing but a network of these neurons, and they are different types of neural networks. There are about 5 of them. These are artificial neural network, convolutional neural network, then recursive neural network or recurrent neural network, deep neural network, and deep belief network. So, and each of these types of neural networks have a special, they can solve a special kind of problems. For example, convolutional neural networks are very good at performing image processing and image recognition and so on, whereas RNN are very good for speech recognition and also text analysis and so on. So each type has some special characteristics, and they are good at performing certain special kind of tasks. What are some of the applications of deep learning? Deep learning is today used extensively in gaming. You must have heard about AlphaGo, which is a game created by a startup called DeepMind, which got acquired by Google. And AlphaGo is an AI which defeated the human world champion Lee Sedol in this game of Go. So gaming is an area where deep learning is being extensively used, and a lot of research happens in the area of gaming as well. In addition to that, nowadays there are neural networks or special type called generative adversarial networks, which can be used for synthesizing either images or music or text and so on, and they can be used to compose music. So the neural network can be trained to compose a certain kind of music. And autonomous cars, you must be familiar with Google's self-driving car, and today a lot of automotive companies are investing in this space, and deep learning is a core component of this autonomous cars. The cars are trained to recognize, for example, the road, the lane markings on the road, signals, any objects that are in front, any obstruction, and so on and so forth. So all this involves deep learning. So that's another major application. And robots, we have seen several robots, including Sophia. You may be familiar with Sophia, who was given a citizenship by Saudi Arabia. And there are several such robots which are very human-like, and the underlying technology in many of these robots is deep learning. Medical diagnostics and healthcare is another major area where deep learning is being used, and within healthcare diagnostics, again, there are multiple areas where deep learning and image recognition, image processing can be used. For example, for cancer detection, as you may be aware, if cancer is detected early on, it can be cured. And one of the challenges is in the availability of specialists who can diagnose cancer using these diagnostic images and various scans and so on and so forth. So the idea is to train neural network to perform some of these activities so that the load on the cancer specialist doctors or oncologists comes down. And there is a lot of research happening here, and there are already quite a few applications that are claimed to be performing better than human beings in this space. It can be lung cancer, it can be breast cancer, and so on and so forth. So healthcare is a major area where deep learning is being applied. Let's take a look at the inner working of a neural network. So how does an artificial neural network, let's say, can we train a neural network to identify the shapes like squares and circles and triangles when these images are fed? So this is how it works. Any image is nothing but it is a digital information of the pixels. So in this particular case, let's say this is an image of 28 by 28 pixel, and this is an image of a square. There is a certain way in which the pixels are lit up, and so these pixels have a certain value, maybe from 0 to 256, and 0 indicates that it is black or it is dark, and 256 indicates it is white or lit up. So that is like an indication or a measure of how the pixels are lit up. And so this is an image is, let's say, consisting of information of 784 pixels. So all the information, what is inside this image, can be kind of compressed into these 784 pixels. The way each of these pixels is lit up provides information about what exactly is the image. So we can train neural networks to use that information and identify the images. So let's take a look how this works. So each neuron, the value, if it is close to 1, that means it is white, whereas if it is close to 0, that means it is black. Now this is an animation of how this whole thing works. So these pixels, one of the ways of doing it is we can flatten this image and take this complete 784 pixels and feed that as input to our neural network. The neural network can consist of probably several layers. There can be a few hidden layers, and then there is an input layer and an output layer. Now the input layer takes these 784 pixels as input, the values of each of these pixels, and then you get an output which can be of 3 types or 3 classes. One can be a square, a circle, or a triangle. Now during the training process, there will be initially, obviously you feed this image and it will probably say it's a circle or it will say it's a triangle. So as a part of the training process, we then send that error back, and the weights and the biases of these neurons are adjusted till it correctly identifies that this is a square. That is the whole training mechanism that happens out here. Now let's take a look at a circle. Same way. So you feed these 784 pixels. There is a certain pattern in which the pixels are lit up, and the neural network is trained to identify that pattern. And during the training process, once again, it would probably initially identify it incorrectly, saying this is a square or a triangle, and then that error is fed back and the weights and biases are adjusted finally till it finally gets the image correct. So that is the training process. So now we will take a look at same way a triangle. So now if you feed another image which is consisting of triangle. So this is the training process. Now we have trained our neural network to classify these images into a triangle or a circle and a square. So now this neural network can identify these three types of objects. Now if you feed another image, and it will be able to identify whether it's a square or a triangle or a circle. Now what is important to be observed is that when you feed a new image, it is not necessary that the image or the triangle is exactly in this position. Now the neural network actually identifies the patterns. So even if the triangle is, let's say, positioned here, not exactly in the middle but maybe at the corner or in the side, it would still identify that it is a triangle, and that is the whole idea behind pattern recognition. So how does this training process work? This is a quick view of how the training process works. So we have seen that a neuron consists of inputs. It receives inputs, and then there is a weighted sum, which is nothing but this xi wi summation of that plus the bias, and this is then fed to the activation function, and that in turn gives us a output. Now during the training process, initially obviously when you feed these images, when you send maybe a square, it will identify it as a triangle, and when you maybe feed a triangle, it will identify as a square, and so on. So that error information is fed back, and initially these weights can be random. Maybe all of them have 0 values, and then it will slowly keep changing. So as a part of the training process, the values of these weights w1, w2 up to wn keep changing in such a way that towards the end of the training process, it should be able to identify these images correctly. So till then the weights are adjusted, and that is known as the training process. So, and these weights are numeric values. It could be 0.5, 0.25, 0.35 and so on. It could be positive or it could be negative, and the value that is coming here is the pixel value. As we have seen, it can be anything between 0 to 1. You can scale it between 0 to 1 or 0 to 256, whichever way, 0 being black and 256 being white, and then all the other colors in between. So that is the input. So these are numerical values. This multiplication or the product wixi is a numerical value, and the bias is also a numerical value. We need to keep in mind that the bias is fixed for a neuron. It doesn't change with the inputs, whereas the weights are 1 per input. So that is one important point to be noted. So but the bias also keeps changing. Initially it will again have a random value, but as a part of the training process, the weights, the values of the weights w1, w2, wn and the value of b will change, and ultimately once the training process is complete, these values are fixed for this particular neuron, w1, w2 up to wn, and plus the value of the b is also fixed for this particular neuron. And in this way there will be multiple neurons, and there may be multiple levels of neurons here, and that's the way the training process works. So this is another example of multi-layer. So there are 2 hidden layers in between, and then you have the input layer, values coming from the input layer, then it goes through multiple layers, hidden layers, and then there is an output layer. And as you can see, there are weights and biases for each of these neurons in each layer, and all of them keeps changing during the training process, and at the end of the training process all these weights have a certain value, and that is a trained model, and those values will be fixed once the training is completed. Alright, then there is something known as activation function. Neural networks consists of one of the components in neural networks is activation function, and every neuron has an activation function, and there are different types of activation functions that are used. It could be a ReLU, it could be sigmoid, and so on and so forth. And the activation function is what decides whether a neuron should be fired or not. So whether the output should be 0 or 1 is decided by the activation function. And the activation function in turn takes the input, which is the weighted sum. Remember we talked about wixi plus b. That weighted sum is fed as an input to the activation function, and then the output can be either a 0 or a 1. And there are different types of activation functions which are covered in an earlier video you might want to watch. Alright, so as a part of the training process, we feed the inputs, the labeled data or the training data, and then it gives an output, which is the predicted output by the network, which we indicate as y hat, and then there is a labeled data, because for supervised learning we already know what should be the output, so that is the actual output. And in the initial process before the training is complete, obviously there will be error, so that is measured by what is known as a cost function. So the difference between the predicted output and the actual output is the error, and the cost function can be defined in different ways. There are different types of cost functions. So in this case, it is like the average of the squares of the error. So, and then all the errors are added, which can sometimes be called as sum of squares, sum of square errors, or SSE, and that is then fed as a feedback in what is known as backward propagation or backpropagation, and that helps in the network adjusting the weights and biases. And so the weights and biases get updated till this value, the error value or the cost function, is minimum. Now there is a optimization technique which is used here called gradient descent optimization, and this algorithm works in a way that the error, which is the cost function, needs to be minimized. So there's a lot of mathematics that goes behind this. For example, they find the local minima, the global minima using the differentiation and so on and so forth. But the idea is this. So as a training process, as the part of training, the whole idea is to bring down the error, which is like, let's say this is the function, the cost function. At certain levels it is very high, the cost value of the cost function, the output of the cost function is very high. So the weights have to be adjusted in such a way, and also the bias of course, that the cost function is minimized. So there is this optimization technique called gradient descent that is used, and this is known as the learning rate. Now gradient descent, you need to specify what should be the learning rate, and the learning rate should be optimal, because if you have a very high learning rate, then the optimization will not converge, because at some point it will cross over to the side. On the other hand, if you have very low learning rate, then it might take forever to convert. So you need to come up with the optimum value of the learning rate, and once that is done using the gradient descent optimization, the error function is reduced, and that's like the end of the training process. Alright, so this is another view of gradient descent. So this is how it looks. This is your cost function, the output of the cost function, and that has to be minimized using gradient descent algorithm. And these are like the parameters, and weight could be one of them. So initially we start with certain random values, so cost will be high, and then the weights keep changing, and in such a way that the cost function needs to come down, and at some point it may reach the minimum value, and then it may increase. So that is where the gradient descent algorithm decides that, okay, it has reached a minimum value and it will kind of try to stay here. This is known as the global minima. Now sometimes these curves may not be, just for explanation purpose this has been drawn in a nice way, but sometimes these curves can be pretty erratic. There can be some local minima here, and then there is a peak, and so on. So the whole idea of gradient descent optimization is to identify the global minima and to find the weights and the bias at that particular point. So that's what is gradient descent. And then this is another example. So you can have these multiple local minima. So as you can see, at this point when it is coming down, it may appear like this is a minimum value, but then it is not. This is actually the global minimum value, and the gradient descent algorithm will make an effort to reach this level and not get stuck at this point. So the algorithm is already there, and it knows how to identify this global minimum, and that's what it does during the training process. Now, in order to implement deep learning, there are multiple platforms and languages that are available, but the most common platform nowadays is TensorFlow, and so that's the reason we have this tutorial. We have created this tutorial for TensorFlow. So we will take you through a quick demo of how to write a TensorFlow code using Python. And TensorFlow is an open source platform created by Google. So let's just take a look at the details of TensorFlow. And so this is a library, a Python library, so you can use Python or any other languages. It's also supported in other languages like Java and R and so on. But Python is the most common language that is used. So it is a library for developing deep learning applications, especially using neural networks. And it consists of primarily two parts, if you will. So one is the tensors, and then the other is the graphs or the flow. That's the way the name, that's the reason for this kind of a name called TensorFlow. So what are tensors? Tensors are like multi-dimensional arrays, if you will. That's one way of looking at it. So usually you have a one-dimensional array. So first of all, you can have what is known as a scalar, which means a number. And then you have a one-dimensional array, something like this, which means this is like a set of numbers. So that is a one-dimensional array. Then you can have a two-dimensional array, which is like a matrix. And beyond that, sometimes it gets difficult. So this is a three-dimensional array, but TensorFlow can handle many more dimensions. So it can have multi-dimensional arrays. That is the strength of TensorFlow, and which makes computation, deep learning computation, much faster. And that's the reason why TensorFlow is used for developing deep learning applications. So TensorFlow is a deep learning tool, and this is the way it works. So the data basically flows in the form of tensors, and the way the programming works as well is that you first create a graph of how to execute it, and then you actually execute that particular graph in the form of what is known as a session. We will see this in the TensorFlow code as we move forward. So all the data is managed or manipulated in tensors, and then the processing happens using these graphs. There are certain terms called, like for example, ranks of a tensor. The rank of a tensor is like a dimensionality in a way. So for example, if it is scalar, so there is just a number, just one number, the rank is supposed to be 0, and then it can be a one-dimensional vector, in which case the rank is supposed to be 1, and then you can have a two-dimensional vector, typically like a matrix. Then in that case we say the rank is 2, and then if it is a three-dimensional array, then rank is 3, and so on. So it can have more than 3 as well. So it is possible that you can store multi-dimensional arrays in the form of tensors. So what are some of the properties of TensorFlow? I think today it is one of the most popular platform. TensorFlow is the most popular deep learning platform or library. It is open source. It's developed by Google, developed and maintained by Google, but it is open source. One of the most important things about TensorFlow is that it can run on CPUs as well as GPUs. GPU is a graphical processing unit, just like CPU is central processing unit. Now, in earlier days, GPU was used primarily for graphics, and that's how the name has come. And one of the reasons is that it cannot perform generic activities very efficiently like CPU, but it can perform iterative actions or computations extremely fast and much faster than a CPU. So they are really good for computational activities, and in deep learning there is a lot of iterative computation that happens, so in the form of matrix multiplication and so on. So GPUs are very well suited for this kind of computation, and TensorFlow supports both GPU as well as CPU. And there's a certain way of writing code in TensorFlow. We will see as we go into the code. And of course, TensorFlow can be used for traditional machine learning as well, but then that would be an overkill. But just for understanding, it may be a good idea to start writing code for a normal machine learning use case, so that you get a hang of how TensorFlow code works, and then you can move into neural networks. So that is just a suggestion, but if you're already familiar with how TensorFlow works, then probably you can go straight into the neural networks part. So in this tutorial, we will take the use case of recognizing handwritten digits. This is like a hello world of deep learning, and this is a nice little, MNIST database is a nice little database that has images of handwritten digits, nicely formatted, because very often in deep learning and neural networks, we end up spending a lot of time in preparing the data for training. And with MNIST database, we can avoid that you already have the data in the right format which can be directly used for training. And MNIST also offers a bunch of built-in utility functions that we can straight away use and call those functions without worrying about writing our own functions. And that's one of the reasons why MNIST database is very popular for training purposes. Initially, when people want to learn about deep learning and TensorFlow, this is the database that is used. And it has a collection of 70,000 handwritten digits, and a large part of them are for training. Then you have test, just like in any machine learning process, and then you have validation. And all of them are labeled. So you have the images and their label. And these images, they look somewhat like this. So they are handwritten images collected from a lot of individuals. People have, these are samples written by human beings. They have handwritten these numbers going from 0 to 9. So people have written these numbers, and then the images of those have been taken and formatted in such a way that it is very easy to handle. So that is MNIST database. And the way we are going to implement this in our TensorFlow is we will feed this data, especially the training data, along with the label information. And the data is basically, these images are stored in the form of the pixel information, as we have seen in one of the previous slides. All the images are nothing but, these are pixels. So an image is nothing but an arrangement of pixels, and the value of the pixel, either it is lit up or it is not, or in somewhere in between. That's how the images are stored, and that is how they are fed into the neural network and for training. Once the network is trained, when you provide a new image, it will be able to identify within a certain error, of course. And for this, we will use one of the simpler neural network configurations called softmax. And for simplicity, what we will do is we will flatten these pixels. So instead of taking them in a two-dimensional arrangement, we just flatten them out. So for example, it starts from here. It is a 28 by 28, so there are 784 pixels. So pixel number 1 starts here, it goes all the way up to 28, then 29 starts here and goes up to 56 and so on. And the pixel number 784 is here. So we take all these pixels, flatten them out, and feed them like one single line into our neural network. And this is what is known as a softmax layer. What it does is, once it is trained, it will be able to identify what digit this is. So there are, in this output layer, there are 10 neurons, each signifying a digit. And at any given point of time, when you feed an image, only one of these 10 neurons gets activated. So for example, if this is trained properly, and if you feed a number 9 like this, then this particular neuron gets activated. So you get an output from this neuron. Let me just use a pen or a laser to show you here. Okay, so you're feeding a number 9. Let's say this has been trained, and now if you're feeding a number 9, this will get activated. Now let's say you feed 1 to the trained network, then this neuron will get activated. If you feed 2, this neuron will get activated, and so on. I hope you get the idea. So this is one type of a neural network or an activation function known as softmax layer. So that's what we will be using here. This is one of the simpler ones for quick and easy understanding. So this is how the code would look. We will go into our lab environment in the cloud, and we will show you there directly. But very quickly, this is how the code looks. And let me run you through briefly here, and then we will go into the Jupyter notebook where the actual code is, and we will run that as well. So as a first step, first of all, we are using Python here, and that's why the syntax of the language is Python. And the first step is to import the TensorFlow library. So, and we do this by using this line of code saying import TensorFlow as TF. TF is just for convenience, so you can give any name. And once you do this, TF is TensorFlow is available as an object in the name of TF, and then you can run its methods and accesses its attributes and so on and so forth. And MNIST database is actually an integral part of TensorFlow, and that's again another reason why we, as a first step, we always use this example, MNIST database example. So you just simply import MNIST database as well using this line of code, and you slightly modify this so that the labels are in this format, what is known as one hot true, which means that the label information is stored like an array. And let me just use the pen to show what exactly it is. So when you do this one hot true, what happens is each label is stored in the form of an array of 10 digits, and let's say the number is 8. Okay, so in this case, all the remaining values, there will be a bunch of zeros. So this is like array at position 0, this is at position 1, position 2, and so on and so forth. Let's say this is position 7, then this is position 8. That will be 1 because our input is 8, and again position 9 will be 0. Okay, so one hot encoding, this one hot encoding true will kind of load the data in such a way that the labels are in such a way that only one of the digits has a value of 1, and that indicates, so based on which digit is 1, we know what is the label. So in this case, the 8th position is 1, therefore we know this sample data, the value is 8. Similarly, if you have a 2 here, let's say, then the labeled information will be somewhat like this. So you have your labels. So you have this as 0, the 0th position. The first position is also 0. The second position is 1 because this indicates number 2. And then you have third as 0 and so on. Okay, so that is the significance of this one hot true. All right, and then we can check how the data is looking by displaying the data. And as I mentioned earlier, this is pretty much in the form of digital form, like numbers. So all these are like pixel values, so you will not really see an image in this format, but there is a way to visualize that image. I will show you in a bit. And this tells you how many images are there in each set. So the training, there are 55,000 images in training, and in the test set there are 10,000, and then validation there are 5,000. So altogether there are 70,000 images. All right, so let's move on, and we can view the actual image by using the matplotlib library, and this is how you can view. This is the code for viewing the images, and you can view them in color or you can view them in grayscale. So the CMap is what tells in what way we want to view it, and what are the maximum values and the minimum values of the pixel values. So these are the max and minimum values, so of the pixel values. So maximum is 1 because this is a scaled value. So 1 means it is white, and 0 means it is black, and in between is, it can be anywhere in between black and white. And the way to train the model, there is a certain way in which you write your TensorFlow code. And the first step is to create some placeholders, and then you create a model. In this case, we will use the softmax model, one of the simplest ones. And placeholders are primarily to get the data from outside into the neural network. So this is a very common mechanism that is used. And then, of course, you will have variables, which are your, remember, these are your weights and biases. So for, in our case, there are 10 neurons, and each neuron actually has 784 because each neuron takes all the inputs. If we go back to our slide here, actually every neuron takes all the 784 inputs. Right? This is the first neuron. It receives all the 784. This is the second neuron. This also receives all the 780. So each of these inputs needs to be multiplied with a weight, and that's what we are talking about here. So this is a matrix of 784 values for each of the neurons, and so it is like a 10 by 784 matrix because there are 10 neurons. And similarly, there are biases. Now remember, I mentioned bias is only 1 per neuron, so it is not 1 per input, unlike the weights. So therefore there are only 10 biases because there are only 10 neurons in this case. So that is what we are creating a variable for biases. So this is something little new in TensorFlow. You will see, unlike our regular programming languages where everything is a variable, here the variables can be of 3 different types. You have placeholders, which are primarily used for feeding data. You have variables, which can change during the course of computation. And then a third type, which is not shown here, are constants. So these are like fixed numbers. All right. So in a regular programming language, you may have everything as variables or at the most variables and constants, but in TensorFlow you have 3 different types: placeholders, variables, and constants. And then you create what is known as a graph. So TensorFlow programming consists of graphs and tensors, as I mentioned earlier. So this can be considered ultimately as a tensor, and then the graph tells how to execute the whole implementation, so that the execution is stored in the form of a graph. And in this case, what we are doing is we are doing a multiplication. TF, you remember this TF was created as a TensorFlow object here. One more level, one more. So TF is available here. Now TensorFlow has what is known as a matrix multiplication or matmul function. So that is what is being used here in this case. So we are using the matrix multiplication of TensorFlow so that you multiply your input values x with w, right? This is what we were doing, xw plus b. You're just adding b, and this is in very similar to one of the earlier slides where we saw sigma xi wi. So that's what we are doing here. Matrix multiplication is multiplying all the input values with the corresponding weights and then adding the bias. So that is the graph we created. And then we need to define what is our loss function and what is our optimizer. So in this case, we again use the TensorFlow's APIs. So tf.nn softmax cross entropy with logits is the API that we will use, and reduce mean is what is like the mechanism whereby which says that you reduce the error. And optimizer for doing reduction of the error, what optimizer are we using? So we are using gradient descent optimizer. We discussed about this in a couple of slides earlier. And for that, you need to specify the learning rate. You remember we saw that there was a slide somewhat like this, and then you define what should be the learning rate, how fast you need to come down. That is the learning rate. And this again needs to be tested and tried, and to find out the optimum level of this learning rate. It shouldn't be very high, in which case it will not converge, or shouldn't be very low, because it will, in that case, it will take very long. So you define the optimizer, and then you call the method minimize for that optimizer, and that will kickstart the training process. And so far we've been creating the graph, and in order to actually execute that graph, we create what is known as a session, and then we run that session. And once the training is completed, we specify how many times, how many iterations we want it to run. So for example, in this case, we are saying 1000 steps. So that is a exit strategy in a way. So you specify the exit condition. So a training will run for 1000 iterations. And once that is done, we can then evaluate the model using some of the techniques shown here. So let us get into the code quickly and see how it works. So this is our cloud environment. Now you can install TensorFlow on your local machine as well. I'm showing this demo on our existing cloud, but you can also install TensorFlow on your local machine, and there is a separate video on how to set up your TensorFlow environment. You can watch that if you want to install your local environment. Or you can go for any cloud service, like for example Google Cloud, Amazon, or Cloud Labs. Any of these you can use and run and try the code. Okay, so it has got started. We will log in. Alright, so this is our deep learning tutorial code, and this is our TensorFlow environment. And so let's get started. The first, we have seen a little bit of a code walkthrough in the slides as well. Now you will see the actual code in action. So the first thing we need to do is import TensorFlow, and then we will import the data, and we need to adjust the data in such a way that the one hot encoding is set to true, one hot encoding, right? As I explained earlier. So in this case, the label values will be shown appropriately. And if we just check what is the type of the data, so you can see that this is a data sets, Python data sets. And if we check the number of images, the way it looks, so this is how it looks. It is an array of type float 32. Similarly, the number, if you want to see what is the number of training images, there are 55,000, then there are test images 10,000, and then validation images 5,000. Now let's take a quick look at the data itself, visualization. So we will use Matplotlib for this. And if we take a look at the shape, now shape gives us like the dimension of the tensors or the arrays, if you will. So in this case, the training data set, if we see the size of the training data set using the method shape, it says there are 55,000 and 55,000 by 784. So remember, the 784 is nothing but the 28 by 28, 28 into 28. So that is equal to 784. So that's what it is showing. Now we can take just one image and just see what is the first image and see what is the shape. So again, size, obviously it is only 784. Similarly, you can look at the image itself, the data of the first image itself. So this is how it shows. So large part of it will probably be zeros, because as you can imagine, in the image only certain areas are written, rest is blank. So that's why you will mostly see zeros, either it is black or white. But then there are these values are, so the values are actually, they are scaled, so their values are between 0 and 1. Okay, so this is what you're seeing. So certain locations there are some values, and then other locations there are zeros. So that is how the data is stored and loaded. If we want to actually see what is the value of the handwritten image, if you want to view it, this is how you view it. So you create, like, do this reshape, and Matplotlib has this feature to show you these images. So we will actually use the function called IMShow, and then if you pass this parameters appropriately, you will be able to see the different images. Now I can change the values in this position, so which image we are looking at, right? So we can say, if I want to see what is there in maybe 5,000, right? So 5,000 has 3. Similarly, you can just say 5. What is in 5? 5 has 8. What is in 50? Again 8. So basically, by the way, if you're wondering how I'm executing this code, Shift Enter, in case you're not familiar with Jupyter Notebooks, Shift Enter is how you execute each cell, individual cell. And if you want to execute the entire program, you can go here and say run all. So that is how this code gets executed. And here again, we can check what is the maximum value and what is the minimum value of this pixel values. As I mentioned, it is scaled, so therefore it is between, the values lie between 1 and 0. Now this is where we create our model. The first thing is to create the required placeholders and variables, and that's what we are doing here, as we have seen in the slides. So we create one placeholder and we create 2 variables, which is for the weights and biases. These 2 variables are actually matrices, so each variable has 784 by 10 actual values. Okay, so one for this 10 is for each neuron, there are 10 neurons, and 784 is for the pixel values inputs that are given, which is 28 into 28. And the biases, as I mentioned, one for each neuron, so there will be 10 biases. They are stored in a variable by the name B. And this is the graph, which is basically the multiplication of these matrix multiplication of x into w, and then the bias is added for each of the neurons. And the whole idea is to minimize the error. So let me just execute. I think this code is executed. Then we define what is the y value is basically the label value. So this is another placeholder. We had x as one placeholder and y underscore true as a second placeholder, and this will have values in the form of 10 digit arrays. And since we said one hot encoded, the position which has a 1 value indicates what is the label for that particular number. All right. Then we have cross entropy, which is nothing but the loss function. And we have the optimizer. We have chosen gradient descent as our optimizer. Then the training process itself. So the training process is nothing but to minimize the cross entropy, which is again nothing but the loss function. So we define all of this in the form of a graph. So up to here, remember what we have done is we have not exactly executed any TensorFlow code till now. We are just preparing the graph, the execution plan. That's how the TensorFlow code works. So the whole structure and format of this code will be completely different from how we normally do programming. So even with people with programming experience may find this a little difficult to understand it, and it needs quite a bit of practice. So you may want to view this video also maybe a couple of times to understand this flow, because the way TensorFlow programming is done is slightly different from the normal programming. Some of you who, let's say, have done maybe Spark programming to some extent will be able to easily understand this. But even in Spark, the programming, the code itself is pretty straightforward. Behind the scenes, the execution happens slightly differently. But in TensorFlow, even the code has to be written in a completely different way. So the code doesn't get executed in the same way as you have written. So that's something you need to understand, and a little bit of practice is needed for this. So far what we have done up to here is creating the variables and feeding the variables, and or rather not feeding but setting up the variables and the graph. That's all. Defining maybe the what kind of a network you want to use. For example, we want to use softmax and so on. So you have created the variables, how to load the data, loaded the data, viewed the data, and prepared everything, but you have not yet executed anything in TensorFlow. Now the next step is the execution in TensorFlow. So the first step for doing any execution in TensorFlow is to initialize the variables. So anytime you have any variables defined in your code, you have to run this piece of code always. So you need to basically create what is known as a node for initializing. So this is a node. You still are not yet executing anything here. You just created a node for the initialization. So let us go ahead and create that. And here onwards is where you will actually execute your code in TensorFlow. And in order to execute the code, what you will need is a session, TensorFlow session. So tf.session will give you a session, and there are a couple of different ways in which you can do this, but one of the most common methods of doing this is with what is known as a with loop. So you have a with tf.session as ses and with a colon here, and this is like a block, starting of the block, and these indentations tell how far this block goes, and this session is valid till this block gets executed. So that is the purpose of creating this with block. This is known as a with block. So with tf.session as ses, you say ses.run init. Now ses.run will execute a node that is specified here. So for example, here we are saying ses.run. Ses is basically an instance of the session, right? So here we are saying tf.session. So an instance of the session gets created and we are calling that ses. And then we run a node within that, one of the nodes in the graph. So one of the nodes here is init. So we say run that particular node, and that is when the initialization of the variables happens. Now what this does is, if you have any variables in your code, in our case we have W is a variable and B is a variable. So any variables that we created, you have to run this code, you have to run the initialization of these variables, otherwise you will get an error. Okay, so that's what this is doing. Then we, within this with block, we specify a for loop, and we are saying we want the system to iterate for 1000 steps and perform the training. That's what this for loop does. Run training for 1000 iterations. And what it is doing basically is it is fetching the data or these images. Remember, there are about 50,000 images, but it cannot get all the images in one shot because it will take up a lot of memory and performance issues will be there. So this is a very common way of performing deep learning training. You always do in batches. So we have maybe 50,000 images, but you always do it in batches of 100 or maybe 500 depending on the size of your system and so on and so forth. So in this case we are saying, okay, get me 100 images at a time and get me only the training images. Remember, we use only the training data for training purpose, and then we use test data for test purpose. You must be familiar with machine learning, so you must be aware of this, but in case you are not, in machine learning also, this is not specific to deep learning, but in machine learning in general, you have what is known as training data set and test data set. Your available data, typically you will be splitting into two parts and using the training data set for training purpose, and then to see how well the model has been trained, you use the test data set to check or test the validity or the accuracy of the model. So that's what we are doing here. And you observe here that we are actually calling an mnist function here. So we are saying mnist train.next batch. Right? So this is the advantage of using MNIST database, because they have provided some very nice helper functions which are readily available. Otherwise, this activity itself, we would have had to write a piece of code to fetch this data in batches. That itself is a lengthy exercise. So we can avoid all that if we are using MNIST database, and that's why we use this for the initial learning phase. Okay, so when we say fetch, what it will do is it will fetch the images into X and the labels into Y, and then you use this batch of 100 images and you run the training. So ses.run, basically what we are doing here is we are running the training mechanism, which is nothing but it passes this through the neural network, passes the images through the neural network, finds out what is the output, and if the output, obviously initially it will be wrong, so all that feedback is given back to the neural network, and thereby all the W's and B's get updated till it reaches 1000 iterations. In this case, the exit criteria is 1000, but you can also specify probably accuracy rate or something like that for the as an exit criteria. So here it just says that, okay, this particular image was wrongly predicted, so you need to update your weights and biases. That's the feedback given to each neuron, and that is run for 1000 iterations. And typically by the end of this 1000 iterations, the model would have learned to recognize these handwritten images. Obviously it will not be 100% accurate. Okay, so once that is done, so this happens for 1000 iterations. Once that is done, you then test the accuracy of these models by using the test data set. Right? So this is what we are trying to do here. The code may appear a little complicated because if you're seeing this for the first time, you need to understand the various methods of TensorFlow and so on. But it is basically comparing the output with what is actually there. That's all it is doing. So you have your test data, and you're trying to find out what is the actual value and what is the predicted value, and seeing whether they are equal or not, tf.equal, right? And how many of them are correct, and so on and so forth. And based on that, the accuracy is calculated as well. So this is the accuracy, and that is what we are trying to see, how accurate the model is in predicting these numbers or these digits. Okay, so let us run this. This entire thing is in one cell, so we will have to just run it in one shot. It may take a little while. Let us see. And not bad. So it has finished the 1000 iterations, and what we see here as an output is the accuracy. So we see that the accuracy of this model is around 91%. Okay, now which is pretty good for such a short exercise. Within such a short time we got 90% accuracy. However, in real life this is probably not sufficient, so there are other ways to increase the accuracy. We will see probably in some of the later tutorials how to improve this accuracy, how to change maybe the hyperparameters like number of neurons or number of layers and so on and so forth, and so that this accuracy can be increased beyond 90%.
Hello and welcome to the TensorFlow Object Detection API tutorial. In this video, I will walk you through the TensorFlow code to perform object detection in a video. So let's get started. This part is basically you're importing all the libraries. We need a lot of these libraries, for example, NumPy, we need image IO, datetime, and pill, and so on and so forth, and of course matplotlib. So we import all these libraries, and then there are a bunch of variables which have some paths for the files and folders. So this is regular stuff. Let's keep moving. Then we import the matplotlib and make it inline, and a few more imports. Alright, and then these are some warnings. We can just ignore them. So if I run this code once again, it will go away. Alright, and then here onwards we do the model preparation. Now what we're going to do is we are going to use an existing neural network model. So we are not going to train a new one because that really will take a long time, and it needs a lot of computation resources and so on, and it is really not required. There are already models that have been trained, and in this case it is the SSD with MobileNet. That's the model that we are going to use, and this model is trained to detect objects, and it is readily available as open source, so we can actually use this. And if you want to use other models, there are a few more models available, so you can click on this link here, and let me just take you there. There are a few more models, but we have chosen this particular one because this is faster. It may not be very accurate, but that is one of the faster models. But on this link you will see a lot of other models that are readily available. These are trained models. Some of them would take a little longer, but they may be more accurate and so on, so you can probably play around with these other models. Okay, so we will be using that model. So this piece of code, this line, is basically importing that model, and this is also known as frozen model. The term we use is frozen model. So we import, download and import that, and then we will actually use that model in our code. Alright, so these two cells, we have downloaded and imported the model, and then once it is available locally, we will then load this into our program. Alright, so we are loading this into memory, and you need to perform a couple of additional steps, which is basically we need to map the numbers to text. As you may be aware, when we actually build the model and when we run predictions, the model will not give a text. The output of the model is usually a number. So we need to map that to a text. So for example, if the network predicts that the output is 5, we know that 5 means it is an aeroplane. Things like that. So this mapping is done in this next cell. Alright, so let's keep moving, and then we have a helper code which will basically load the data or load the images and transform into NumPy arrays. This is also used in doing object detection in images, so we are actually going to reuse, because video is nothing but it consists of frames which in turn are images. So we are going to pretty much reuse the same code which we used for doing object detection in images. So this is where the actual detection starts. So here, this is the path for where the images are stored. So this is here once again we are reusing the code which we wrote for detecting objects in an image. So this is the path where the images were stored, and this is the extension, and this was done for about 2 or 3 images. So we will continue to use this, and if we go down, I'll skip this section. So this is the cell where we are actually loading the video and converting it into frames, and then using frame by frame we are detecting the objects in the image. So in this code what we are doing basically is there are a few lines of code. What they do is basically once they find an object, a box will be drawn around those each of those objects, and the input file, the name of the input video file is traffic. It is the extension is MP4, and we have this video reader. It's an excellent object which is basically part of this class called image.io, so we can read and write videos using that. And the video that we are going to use is traffic.mp4. You can use any mp4 file, but in our case I picked up video which has like car. So let me just show you. So this is in this object detection folder. I have this mp4 file. I'll just quickly play this video. It's a little slow. Yeah, okay, so here we go. This is the video. It's a short one, relatively small video, so that for this particular demo. And what it will do is once we run our code, it will detect each of these cars and it will annotate them as cars. So in this particular video we only have cars. We can later on see with another video. I think I have cat here, so we can also try with that, but let's first check with this traffic video. So let me go back. So we will be reading this frame by frame, and no, actually we will be reading the video file, but then we will be analyzing it frame by frame, and we will be reading them at 10 frames per second. That is the rate we are mentioning here, and analyzing it and then annotating and then writing it back. So you will see that we will have a video file named something like this, traffic_annotated, and we will see the annotated video. So let's go back and run through this piece of code, and then we will come back and see the annotated video. This might take a little while, so I will pause the video after running this particular cell and then come back to show you the results. Alright, so let's go ahead and run it. So it is running now, and it is also important that at the end you close the video writer, so that it is similar to a file pointer. When you open a file, you should also make sure you close it so that it doesn't hog the resources. So it's very similar. So at the end of it, the last piece or last line of code should be video_writer.close. Alright, so I'll pause and then I'll come back. Okay, so I will see you in a little bit. Alright, so now as you can see here, the processing is done. The hourglass has disappeared. That means the video has been processed. So let's go back and check the annotated video. We'll go back to my file manager. So this was the original traffic.mp4, and now you have here traffic_annotated mp4. So let's go and run this and see how it looks. You see here, it has got each of these cars are getting detected. Let me pause and show you. So we pause here. It says car 70%. Let us allow it to go a little further. It detects something on top. What is that? Truck. Okay. So I think because of the board on top, it somehow thinks there is a truck. Let's play some more and see if it detects anything else. So this is again a car, looks like. So let us, yeah. So this is a car, and it has confidence level of 69%. Okay, this is again a car. Alright, so basically till the end it goes and detects each and every car that is passing by. Now we can quickly repeat this process for another video. Let me just show you the other video, which is a cat. Again, there is this cat is not really moving or anything, but it is just standing there staring and moving a little slowly, and our application will, our network will detect that this is a cat, and even when the cat moves a little bit in the other direction, it will continue to detect and show that it is a cat. Okay, so yeah, so this is how the original video is. Let's go ahead and change our code to analyze this one and see if it detects, our network detects this cat. Close this, here we go, and I'll go back to my code. All we need to do is change this traffic to cat, the extension. It will automatically up because it is given here, and then it will run through. So very quickly, once again, what it is doing is this video underscore reader has a neat little feature or interface whereby you can say for frame in video underscore reader. So it will basically provide frame by frame. So you're in a loop frame by frame, and then you take that each frame that is given to you, you take it and analyze it as if it is an image, individual image. So that's the way it works. So it is very easy to handle this. Alright, so now let's once again run just this cell. The rest of the stuff remains the same. So I will run this cell again. It will take a little while, so the hourglasses come back. I will pause and then come back in a little while. Alright, so the processing is done. Let's go and check the annotated video. Go here. So we have cat annotated.mp4. Let's play this. Alright, so you can see here it is detecting the cat, and in the beginning you also saw it detected something else here. There looks like it detected one more object. So let's just go back and see what it has detected here. Let's see. Yes. So what is it trying to show here? It's too small, not able to see, but it is trying to detect something. I think it is saying it is a car. I don't know. Alright, okay, so in this video there's pretty much only one object, which is the cat, and let's wait for some time and see if it continues to detect it when the cat turns around and moves as well. Just in a little bit that's going to happen, and we will see. There we go. And in spite of turning the other way, I think our network is able to detect that it is a cat. So let me freeze and then show here. It is actually still continues to detect it as a cat. Alright, so that's pretty much it. I think that's the only object that it detects in this particular video. Okay, so close this. So that's pretty much it. Thank you very much for watching this video. You have a great day, and in case you have any questions, please put them below the video here, and we will be more than happy to get back to you. And make sure you put your email ID so that we can contact you in case you have any questions. Thank you once again. Bye-bye.
Today we're going to be covering the convolutional neural network tutorial. Do you know how deep learning recognizes the objects in an image? And really, this particular neural network is how image recognition works. It's very central, one of the biggest building blocks for image recognition. It does it using convolution neural network. And over here we have the basic picture of a hummingbird. Pixels of an image fed as input. You have your input layer coming in, so it takes that graphic and puts it into the input layer. You have all your hidden layers. And then you have your output layer, and your output layer, one of those is going to light up and say, oh, it's a bird. We're going to go into depth. We're going to actually go back and forth on this a number of times today. So if you're not catching all the image, don't worry, we're going to get into the details. So we have our input layer accepts the pixels of the image as input in the form of arrays. And you can see up here where they've actually labeled each block of the bird in different arrays. So we'll dive into deep as to how that looks like and how those matrices are set up. Your hidden layer carry out feature extraction by performing certain calculations and manipulation. So this is the part that kind of reorganizes that picture multiple ways until we get some data that's easy to read for the neural network. This layer uses a matrix filter and performs convolution operation to detect patterns in the image. And if you remember that convolution means to coil or to twist. So we're going to twist the data around and alter it and use that operation to detect a new pattern. There are multiple hidden layers like convolution layer. ReLU is how that is pronounced. And that's the rectified linear unit. That has to do with the activation function that's used. Pooling layer also uses multiple filters to detect edges, corners, eyes, feathers, beak, etc. And just like the term says, pooling is pooling information together. And we'll look into that a lot closer here. So if it's a little confusing now, we'll dig in deep and try to get you squared away with that. And then finally there is a fully connected layer that identifies the object in the image. So we have these different layers coming through in the hidden layers, and they come into the final area, and that's where we have, say, one node or one neural network entity that lights up that says it's a bird. What's in it for you? We're going to cover an introduction to the CNN, what is convolution neural network, how CNN recognizes images. We're going to dig deeper into that and really look at the individual layers in the convolutional neural network. And finally, we do a use case implementation using the CNN. We'll begin our introduction to the CNN by introducing the pioneer of convolutional neural network, Yann LeCun. He was the director of Facebook AI Research Group. built the first convolutional neural network called LeNet in 1988. So these have been around for a while and have had a chance to mature over the years. It was used for character recognition tasks like reading zip code digits. Imagine processing mail and automating that process. CNN is a feed-forward neural network that is generally used to analyze visual images by producing data with a grid-like topology. A CNN is also known as a convnet. And very key to this is we are looking at images. That was what this was designed for, and you'll see the different layers as we dig in mirror some of them are actually now used since we're using TensorFlow and Keras in our code later on. You'll see that some of those layers appear in a lot of your other neural network frameworks. But in this case, this is very central to processing images and doing so in a variety that captures multiple images and really drills down into their different features. In this example here you see flowers of two varieties, orchid and a rose. I think the orchid is much more dainty and beautiful, and the rose smells quite beautiful. I have a couple rose bushes in my yard. They go into the input layer. That data is then sent to all the different nodes in the next layer, one of the hidden layers, based on its different weights and its setup. It then comes out and gives those a new value. Those values then are multiplied by their weights and go to the next hidden layer, and so on. And then you have the output layer, and one of those nodes comes out and says it's an orchid, and the other one comes out and says it's a rose, depending on how well it was trained. What separates the CNN, or the convolutional neural network, from other neural networks is a convolutional operation. Forms the basis of any convolutional neural network. In a CNN, every image is represented in the form of arrays of pixel values. So here we have a real image of the digit 8. That then gets put onto its pixel values, represented in the form of an array. In this case, you have a two-dimensional array. And then you can see in the final end form, we transform the digit 8 into its representational form of pixels of zeros and ones, where the ones represent, in this case, the black part of the 8, and the zeros represent the white background. To understand the convolution neural network, or how that convolutional operation works, we're going to take a sidestep and look at matrices. In this case, we're going to simplify it, and we're going to take two matrices, A and B, of one dimension. Now, kind of separate this from your thinking as we learn that you want to focus just on the matrix aspect of this. And then we'll bring that back together and see what that looks like when we put the pieces for the convolutional operation. Here we've set up two arrays. We have, in this case, they're a single dimension matrix. And we have A equals 5, 3, 7, 5, 9, 7. And we have B equals 1, 2, 3. So in the convolution, as it comes in there, it's going to look at these two, and we're going to start by multiplying them, A times B. And so we multiply the arrays element-wise, and we get 5, 6, 6, where 5 is the 5 times 1, 6 is 3 times 2, and then the other 6 is 2 times 3. And since the two arrays aren't the same size, they're not the same setup, we're going to just truncate the first one, and we're going to look at the second array multiplied just by the first three elements of the first array. Now that's going to be a little confusing. Remember, a computer gets to repeat these processes hundreds of times, so we're not going to just forget those other numbers later on. We'll bring those back in. And then we have the sum of the product. In this case, 5 plus 6 plus 6 equals 17. So in our A times B, our very first digit in that matrix of A times B is 17. And if you remember, I said we're not going to forget the other digits. So we now have 3, 2, 5. We move one set over, and we take 3, 2, 5, and we multiply that times B. And you'll see that 3 times 1 is 3, 2 times 2 is 4, and so on and so on. We sum it up, so now we have the second digit of our A times B product in the matrix. And we continue on with that same thing, so on and so on. So then we would go from 375 to 759 to 597. This short matrix that we have for A, we've now covered all the different entities in A that match 3 different levels of B. Now, in a little bit, we're going to cover where we use this math at, this multiplying of matrices and how that works. But it's important to understand that we're going through the matrix and multiplying the different parts to it to match the smaller matrix with the larger matrix. I know a lot of people get lost at is, what's going on here with these matrices? Ooh, scary math. Not really that scary when you break it down. We're looking at a section of A and we're comparing it to B. So when you break that down in your mind like that, you realize, okay, so I'm just taking these two matrices and comparing them, and I'm bringing the value down into one matrix, A times B. We're reducing that information in a way that will help the computer see different aspects. Let's go ahead and flip over again back to our images. Here we are back to our images. Talking about going to the most basic two-dimensional image you can get to. Consider the following two images. The image for the symbol backslash. When you press the backslash, the above image is processed. And you can see there for the image for the forward slash is the opposite. So when we click the forward slash button, that flips. Very basic. We have 4 pixels going in. Can't get any more basic than that. Here we have a little bit more complicated picture. We take a real image of a smiley face. Then we represent that in the form of black and white pixels. So if this was an image in the computer, it's black and white. And like we saw before, we convert this into the zeros and ones. So where the other one would have just been a matrix of just 4 dots, now we have a significantly larger image coming in. So don't worry, we're going to bring this all together here in just a little bit. Layers in convolutional neural network. When we're looking at this, we have our convolution layer. And that really is the central aspect of processing images in the convolutional neural network. That's why we have it. And then that's going to be feeding in. And you have your ReLU layer, which is, as we talked about, the rectified linear unit. We'll talk about that a little bit later. The ReLU is how that layer is activated, is the math behind it, what makes the neurons fire. You'll see that in a lot of other neural networks. When you're using it just by itself, it's for processing smaller amounts of data, where you use the atom activation feature for large data coming in. Now, because we're processing small amounts of data in each image, the ReLU layer works great. You have your pooling layer. That's where you're pooling the data together. Pooling is a neural network term. It's very commonly used. I like to use the term reduce. So if you're coming from the map and reduce side, you'll see that we're mapping all this data through all these networks, and then we're going to reduce it. We're going to pool it together. And then finally we have the fully connected layer. That's where our output's going to come out. So we have started to look at matrices. We've started to look at the convolutional layer and where it fits in and everything. We've taken a look at images. So we're going to focus more on the convolution layer, since this is a convolutional neural network. A convolution layer has a number of filters and perform convolution operation. Every image is considered as a matrix of pixel values. Consider the following 5x5 image whose pixel values are only 0 and 1. Now, obviously, when we're dealing with color, there's all kinds of things that come in on color processing, but we want to keep it simple and just keep it black and white. And so we have our image pixels, so we're sliding the filter matrix over the image and computing the dot product to detect the patterns. And right here, you're going to ask, where does this filter come from? This is a bit confusing because the filter is going to be derived later on. We build the filters when we program or train our model. So you don't need to worry what the filter actually is, but you do need to understand how a convolution layer works, is what is the filter doing. Filter, and you'll have many filters. You don't have just one filter. You'll have lots of filters that are going to look for different aspects. And so the filter might be looking for just edges, it might be looking for different parts. We'll cover that in a little bit more detail in a minute. Right now we're just focusing on how the filter works as a matrix. Remember earlier we talked about multiplying matrices together? And here we have our two-dimensional matrix. And you can see we take the filter and we multiply it in the upper left image, and you can see right here 1 times 1, 1 times 0, 1 times 1. We multiply those all together, then sum them, and we end up with a convolved feature of 4. We're going to take that and sliding the filter matrix over the image and computing the dot product to detect patterns. So we're just going to slide this over. We're going to predict the first one and slide it over 1 notch, predict the second one, and so on all the way through until we have a new matrix. And this matrix, which is the same size as the filter, has reduced the image, and whatever filter, whatever that's filtering out, is going to be looking at just those features reduced down to a smaller matrix. So once the feature maps are extracted, the next step is to move them to the ReLU layer. So the ReLU layer, the next step, first is going to perform an element-wise operation. So each of those maps coming in, if there's negative pixels, so it sets all the negative pixels to 0. And you can see this nice graph where it just zeroes out the negatives, and then you have a value that goes from 0 up to whatever value is coming out of the matrix. This introduces nonlinearity to the network. So up until now, we say linearity, we're talking about the fact that the feature has a value. So it's a linear feature. This feature came up and it has, let's say the feature is the edge of the beak. it's like, or that backslash that we saw. It'll look at that and say, okay, this feature has a value from -10 to 10 in this case. If it was 1, it'd say, yeah, this might be a beak. It might not. It might be an edge right there. A -5 means, no, we're not even going to look at it. It's a 0. And so we end up with an output, and the output takes all these filtered features. Remember, we're not just running one filter on this, we're running a number of filters on this image. And so we end up with a rectified feature map that is looking at just the features coming through and how they weigh in from our filters. So here we have an input of it looks like a toucan bird. Very exotic looking. Real image is scanned in multiple convolution and the ReLU layers for locating features. And you can see up here is turn it into a black and white image. And in this case, we're looking in the upper right-hand corner for a feature, and that box scans over. A lot of times it doesn't scan 1 pixel at a time. A lot of times it will skip by 2 or 3 or 4 pixels to speed up the process. That's one of the ways you can compensate if you don't have enough resources on your computation for large images. And it's not just one filter that slowly goes across the image. You have multiple filters that have been programmed in there. So you're looking at a lot of different filters going over the different aspects of the image and just sliding across there and forming a new matrix. One more aspect to note about the ReLU layer is we're not just having one ReLU coming in. So not only do we have multiple features going through, but we're generating multiple ReLU layers for locating the features. That's very important to note. So we have quite a bundle. We have multiple filters, multiple ReLU, which brings us to the next step, forward propagation. Now we're going to look at the pooling layer. The rectified feature map now goes through a pooling layer. Pooling is a downsampling operation that reduces the dimensionality of the feature map. That's all we're trying to do. We're trying to take a huge amount of information and reduce it down to a single answer. This is a specific kind of bird. This is an iris. This is a rose. So you have a rectified feature map. And you see here we have a rectified feature map coming in. We set the max pooling with a 2x2 filters and a stride of 2. And if you remember correctly, I talked about not going 1 pixel at a time. Well, that's where the stride comes in. We end up with a 2x2 pooled feature map, but instead of moving 1 over each time and looking at every possible combination, we skip a few there. We go by 2. We skip every other pixel. And we just do every other one. And this reduces our rectified feature map, which as you can see over here, 16 by 16 to a 4 by 4. So we're continually trying to filter and reduce our data so that we can get to something we can manage. And over here you see that we have the max 3, 4, 1, and 2. And in the max pooling, we're looking for the max value. A little bit different than what we were looking at before. So coming from the rectified feature, we're now finding the max value and then we're pooling those features together. So instead of think of this as image of the map, think of this as how valuable is a feature in that area? How much of a feature value do we have? And we just want to find the best or the maximum feature for that area. They might have that one piece of the filter of the beak said, oh, I see a 1 in this beak in this image, and then it skips over and says, I see a 3 in this image, and it says, oh, this one is rated as a 4. We don't want to sum it together because then you might have like 5 1s and it'll say 5, but you might have 4 zeros and 1 10, and that 10 says, well, this is definitely a beak, where the 1s will say probably not a beak. A little strange analogy since we're looking at a bird, but you can see how that pooled feature map comes down, and we're just looking for the max value in each one of those matrices. Pooling layer uses different filters to identify different parts of the image, like edges, corners, body, feathers, eyes, beak, etc. I know I focus mainly on the beak, but obviously each feature could be a different part of the bird coming in. So let's take a look at what that looks like. Structure of a convolution neural network so far. This is where we're at right now. We have our input image coming in, and then we use our filters, and there's multiple filters on there that are being developed to kind of twist and change that data, and so we multiply the matrices. We take that little filter, maybe it's a 2x2, we multiply it by each piece of the image, and if we step 2, then it's every other piece of the image. That generates multiple convolution layers. So we have a number of convolution layers we have set up in there just looking at that data. We then take those convolution layers, we run them through the ReLU setup, And then once we've done through the ReLU setup, and we have multiple ReLUs going on, multiple layers that are ReLU, then we're going to take those multiple layers and we're going to be pooling them. So now we have the pooling layers, or multiple poolings going on. Up until this point, we're dealing with, sometimes it's multiple dimensions. You can have 3 dimensions. Some strange data setups that aren't doing images but looking at other things, they can have 4, 5, 6, 7 dimensions. So right now we're looking at 2D image dimensions coming into the pooling layer. So the next step is we want to reduce those dimensions, or flatten them. So flattening is a process of converting all of the resultant 2-dimensional arrays from pooled feature map into a single long continuous linear vector. So over here you see where we have a pooled feature map. Maybe that's the bird wing, and it has values 6, 8, 4, 7, and we want to just flatten this out and turn it into 6, 8, 4, 7, or a single linear vector. And we find out that not only do we do each of the pooled feature maps, we do all of them into one long linear vector. So now we've gone through our convolutional neural network part, and we have the input layer into the next setup. All we've done is taken all those different pooling layers and we've flattened them out and combined them into a single linear vector going in. So after we've done the flattening, we have just a quick recap because we've covered so much, so it's important to go back and take a look at each of the steps we've gone through. The structure of the network so far is we have our convolution where we twist it and we filter it and multiply the matrices. We end up with our convolutional layer, which uses the ReLU to figure out the values going out into the pooling. As you have numerous convolution layers that then create numerous pooling layers, pooling that data together, which is the max value, which one we want to send forward. We want to send the best value. And then we're going to take all of that from each of the pooling layers and we're going to flatten it. And we're going to combine them into a single input going into the final layer. Once you get to that step, you might be looking at that going, boy, that looks like the normal input to most neural network. And you're correct, it is. So once we have the flattened matrix from the pooling layer, that becomes our input. So the pooling layer is fed as an input to the fully connected layer to classify the image. And so you can see as our flattened matrix comes in this case we have the pixels from the flattened matrix fed as an input back to our toucan, or whatever that kind of bird that is. I need one of these to identify what kind of bird that is. It comes into our forward propagation network. And that will then have the different weights coming down across. And then finally it selects that that's a bird and that it's not a dog or a cat in this case. Even though it's not labeled, the final layer there in red is our output layer, our final output layer that says bird, cat, or dog. So quick recap of everything we've covered so far. We have our input image, which is twisted and multiplied. The filters are multiplied times the two matrices multiplied all the filters to create our convolution layer. Our convolution layers, there's multiple layers in there because it's all building multiple layers off the different filters. Then goes through the ReLU as this activation, and that creates our pooling. And so once we get into the pooling layer, we then in the pooling look for who's the best, what's the max value coming in from our convolution. And then we take that layer and we flatten it, and then it goes into a fully connected layer, our fully connected neural network, and then to the output. And here we can see the entire process, how the CNN recognizes a bird. This is kind of nice because it's showing the little pixels and where they're going. You can see the filter is generating this convolution network, and that filter shows up in the bottom part of the convolution network. And then based on that, it uses the ReLU for the pooling. The pooling then find out which one's the best, and so on, all the way to the fully connected layer at the end, or the classification in the output layer. So that'd be a classification neural network at the end. So we covered a lot of theory up till now, and you can imagine each one of these steps has to be broken down in code. So putting that together can be a little complicated. Not that each step of the process is overly complicated, but because we have so many steps. We have 1, 2, 3, 4, 5 different steps going on here with sub-steps in there. We're going to break that down and walk through that in code. So in our use case implementation using the CNN, we'll be using the CFAR10 dataset from Canadian Institute for Advanced Research for classifying images across 10 categories. Unfortunately, they don't let me know whether it's going to be a toucan or some other kind of bird, but we do get to find out whether it can categorize between a ship, a frog, deer, bird, airplane, automobile, cat, dog, horse, truck. So that's a lot of fun. And if you're looking anything in the news at all of our automated cars and everything else, you can see where this kind of processing is so important in today's world and very cutting edge as far as what's coming out in the commercial deployment. I mean, this is really cool stuff. We're starting to see this just about everywhere in industry. So a great time to be playing with this and figuring it all out. Let's go ahead and dive into the code and see what that looks like when we're actually writing our script. Before we go on, let's do one more quick look at what we have here. Let's just take a look at data batch 1 keys. And remember, in Jupyter Notebook, I can get by with not doing the print statement. If I put a variable down there, it'll just display the variable. And you can see under data batch 1 for the keys, since this is a dictionary, we have the batch 1 label, data, and file names. So you can actually see how it's broken up in our data set. So for the next step, or step 4 as we're calling it, we want to display the image using Matplotlib. There's many ways to display the images. You could even, well, there's other ways to drill into it, but Matplotlib is really good for this. And we'll also look at our first reshape setup, or shaping the data, so you can have a little glimpse into what that means. So we're going to start by importing our matplot, and of course, since I am doing Jupyter Notebook, I need to do the matplot inline command, so it shows up on my page. So here we go. We're going to import matplotlib.pyplot as PLT. And if you remember Matplotlib, the pyplot is like a canvas that we paint stuff onto. And there's my %sign matplotlib inline, so it's going to show up in my notebook. And then of course we're going to import numpy as np for our numbers Python array setup. And let's go ahead and set x equals to data batch 1. So this will pull in all the data going into the x value. And then, because this is just a long stream of binary data, we need to go a little bit of reshaping. So in here we have to go ahead and reshape the data. We have 10,000 images. Okay, that looks correct. And this is kind of an interesting thing. It took me a little bit I had to go research this myself to figure out what was going on with this data. And what it is it's a 32 by 32 picture. And let me do this. Let me go ahead and do a drawing pad on here. So we have 32 bits by 32 bits, and it's in color. So there's 3 bits of color. Now, I don't know why the data is particularly like this. It probably has to do with how they originally encoded it. But most pictures put the 3 afterward. So what we're doing here is we're going to take the shape, we're going to take the data, which is just a long stream of information, and we're going to break it up into 10,000 pieces, and those 10,000 pieces then are broken into 3 pieces each, and those 3 pieces then are 32 by 32. You could look at this like an old-fashioned projector where they have the red screen, or the red projector, the blue projector, and the green projector, and they add them all together, and each one of those is a 32 by 32 bit. So that's probably how this was originally formatted, was in that kind of ideal. Things have changed, so we're going to transpose it, and we're going to take the 3, which was here, and we're going to put it at the end. So the first part is reshaping the data from a single line of bit data, or whatever format it is, into 10,000 by 3 by 32 by 32, and then we're going to transpose the color factor to the last place. So it's the image, then the 32 by 32 in the middle, that's this part right here, and then finally we're going to take this, which is 3 bits of data, and put it at the end. So it's more like we process images now. And then as type, this is really important that we're going to use an integer 8. You can come in here and you'll see a lot of these, they'll try to do this with a float or a float 64. What you got to remember though is a float uses a lot of memory. So once you switch this into something that's not integer 8, which goes up to 128, you are just going to, the amount of RAM, let's just put that in here, is going to go way up. The amount of RAM that it loads. So you want to go ahead and use this. You can try the other ones and see what happens if you have a lot of RAM on your computer. But for this exercise, this will work just fine. And let's go ahead and take that and run this. So now our X variable is all loaded and it has all the images in it from the batch 1, data batch 1. And just to show what we were talking about with the as type on there, if we go ahead and take X0 and just look for its max value, let me go ahead and run that. You'll see it doesn't, oops, I said 128, it's 255. You'll see it doesn't go over 255 because it's basically an ASCII character is what we're keeping that down to. We're keeping those values down. So they're only 255, 0 to 255 versus a float value, which would bring this up exponentially in size. And since we're using the Matplot library, we can do, oops, that's not what I wanted. Since we're using the Matplot library, we can take our canvas and just do a plt.im for image show, and let's just take a look at what x0 looks like. And it comes in, I'm not sure what that is, but you can see it's a very low grade image broken down to the minimal pixels on there. And if we did the same thing, let's see what 1 looks like. Hopefully it's a little easier to see. Run on there, not enter. Let's hit the run on that. And we can see this is probably a semi-truck. That's a good guess on there. And I can just go back up here instead of typing the same line in over and over. And we'll look at 3. That looks like a dump truck unloading, and so on. You can do any of the 10,000 images. We can just jump to 55. Looks like some kind of animal looking at us there, probably a dog. And just for fun, let's do just one more run on there, and we can see a nice car for our image number 4. So you can see we paste through all the different images. It's very easy to look at them, and they've been reshaped to fit our view and what the Matplot library uses for its format. So the next step is we're going to start creating some helper functions. We'll start by a one-hot encoder to help us when we're processing the data. Remember that your labels, they can't just be words. They have to switch it, and we use the one-hot encoder to do that. And then we'll also create a class CFAR helper, so it's going to have an init and a setup for the images. And then finally we'll go ahead and run that code so you can see what that looks like. And then we get into the fun part where we're actually going to start creating our model, our actual neural network model. So let's start by creating our one-hot encoder. We're going to create our own here, and it's going to return an out. And we'll have our vector coming in and our values equal 10. What this means is that we have the 10 values, the 10 possible labels. And remember, we don't look at the labels as a number, because a car isn't one more than a horse. That'd be just kind of bizarre to have horse equals 0, car equals 1, plane equals 2, cat equals 3. So a cat plus a car equals what? So instead, we create a NumPy array of zeros. And there's going to be 10 values, so we have 10 different values in there. So you have 0 or 1. 1 means it's a cat, 0 means it's not a cat. In the next line it might be that 1 means it's a car, 0 means it's not a car. So instead of having one output with a value of 0 to 10, you have 10 outputs with the values of 0 to 1. That's what the one-hot encoder is doing here. And we're going to utilize this in code in just a minute. So let's go ahead and take a look at the next helpers. We have a few of these helper functions we're going to build. And when you're working with a very complicated Python project, dividing it up into separate definitions and classes is very important. Otherwise, it just becomes really ungainly to work with. So let's go ahead and put in our next helper, which is a class. And there's a lot in this class, so we'll break it down here. Let's just start, oops, we can put a space right in there. There we go. Now this is a little bit more readable. Add a second space. So we're going to create our class, the Cipher Helper. And we'll start by initializing it. Now, there's a lot going on in here. So let's start with the init part. Self.I equals 0. That'll come in a little bit. We'll come back to that in the lower part. We want to initialize our training batches. So when we went through this, there was like a meta batch. We don't need the meta batch, but we do need the data batch 1, 2, 3, 4, 5, and we do not want the testing batch in here. This is just the self all train batches. So we're going to make an array of all those different images. And then of course we left the test batch out, so we have our self.test batch. We're going to initialize the training images and the training labels, and also the test images and the test labels. So this is just to initialize these variables in here. Then we create another definition down here, and this is going to set up the images. And let's just take a look and see what's going on in there. Now we could have all just put this as part of the init part, since this is all just helper stuff, but breaking it up again makes it easier to read. It also makes it easier when we start executing the different pieces to see what's going on. So that way we have a nice print statement to say, hey, we're now running this and this is what's going on in here. We're going to set up these self-training images at this point, and that's going to go to a NumPy array VStack. And in there we're going to load up, in this case, the data for D and self all train batches. Again, that points right up to here. So we're going to go through each one of these files, or each one of these data sets, because they're not a file anymore. We've brought them in. Data batch 1 points to the actual data. And so our self-training images is going to stack them all into a NumPy array. And then it's always nice to get the training length, and that's just a total number of self-training images in there. And then we're going to take the self-training images, And let me switch marker colors because I am getting a little too much on the markers up here. Oops, there we go. Bring down our marker change so we can see it a little better. And at this point, this should look familiar. Where did we see this? Well, when we wanted to look at this above and we wanted to look at the images in the Matplot library, we had to reshape it. So we're doing the same thing here. We're taking our self-training images and based on the training length, total number of images, because we stacked them all together, so now it's just one large file of images, we're going to take and look at it as our 3 video cameras that are each displaying 32 by 32, and we're going to switch that around so that now we have each of our images that stays the same place, and then we have our 32 by 32, and then by our 3. Our 3 different values for the color. And of course we want to go ahead and they run this where we say divide by 255. That was from earlier. It just brings all the data into 0 to 1. That's what this is doing. So we're turning this into a 0 to 1 array, which is all the pictures 32 by 32 by 3. And then we're going to take the self-training labels and we're going to pump those through our one-hot encoder we just made, and we're going to stack them together. And again, we're converting this into an array that goes from, instead of having horse equals 1, dog equals 2, and then horse plus dog would equal 3, which would be cat. Now, it's going to be an array of 10, where each one is 0 to 1. Then we want to go ahead and set up our test images and labels. And when we're doing this, you're going to see it's the same thing we just did with the rest of them. We just changed colors right here. This is no different than what we were doing up here with our training set. We're going to stack the different images. We're going to get the length of them so we know how many images are in there. You certainly could add them by hand, but it's nice to let the computer do it, especially if it ever changes on the other end and you're using other data. And again, we reshape them and transpose them, and we also do the one-hot encoder. Same thing we just did on our training images. So now our test images are in the same format. So now we have a definition which sets up all our images in there. And then the next step is to go ahead and batch them, or next batch. And let's do another breakout here for batches, because this is really important to understand. It tends to throw me for a little loop when I'm working with TensorFlow or Keras or a lot of these. We have our data coming in. If you remember, we had like 10,000 photos. Let me just put 10,000 down here. We don't want to run all 10,000 at once, so we want to break this up into batch sizes. And you also remember that we had the number of photos, in this case length of test or whatever number is in there. We also have 32 by 32 by 3. So when we're looking at the batch size, we want to change this from 10,000 to a batch of, in this case, I think we're going to do batches of 100. So we want to look at just 100, the first 100 of the photos. And if you remember, we set self-I equal to 0. So what we're looking at here is we're going to create X. We're going to get the next batch from the very initialized. We've already initialized it for 0. So we're going to look at X from 0 to batch size, which we set to 100. So just the first 100 images. And then we're going to reshape that into, and this is important to let the data know, that we're looking at 100 by 32 by 32 by 3. Now, we've already formatted it to the 32 by 32 by 3. This just sets everything up correctly so that X has the data in there in the correct order and the correct shape. And then the Y, just like the X, is our labels. So our training labels, again, they go from 0 to batch size. In this case, they do self-I plus batch size because the self-I is going to keep changing. And then finally, we increment the self-I because we have 0. So the next time we call it, we're going to get the next batch size. And so basically, we have X and Y. X being the photograph data coming in and Y being the label. And that, of course, is labeled through one hot encoder. So if you remember correctly, if it was, say, horse is equal to 0, it would be 1 for the 0 position, since this is the horse, and then everything else would be 0 in here. Let me just put lines through there. There we go. There's our array. Hard to see that array. So let's go ahead and take that, and we're going to finish loading it, since this is our class. And now we're armed with all this, our setup over here. Let's go ahead and load that up. And so we're going to create a variable ch with the CFAR helper in it. And then we're going to do ch.setupImages. Now we could have just put all of the setup images under the init, but by breaking this up into 2 parts, it makes it much more readable. And also, if you're doing other work, there's reasons to do that as far as the setup. Let's go ahead and run that. And you can see where it says setting up training images and labels, setting up test images. And that's one of the reasons we broke it up, is so that if you're testing this out, you can actually have print statements in there telling you what's going on, which is really nice. They did a good job with this setup. I like the way that it was broken up in the back. And then one quick note, you want to remember that batch, to set up the next batch, since we have to run batch equals ch next batch of 100, because we're going to use the 100 size. But we'll come back to that. We're going to use that. Just remember that that's part of our code we're going to be using in a minute from the definition we just made. So now we're ready to create our model. First thing we want to do is we want to import our TensorFlow as TF. I'll just go ahead and run that so it's loaded up. And you can see we got a warning here. That's because they're making some changes. It's always growing, and they're going to be depreciating one of the values from float64 to float type, or is treated as an NP float64. Nothing to really worry about, because this doesn't even affect what we're working on, because we've set all of our stuff to a 255 value, or 0 to 1. And do keep in mind that 0 to 1 value that we converted to 255 is still a float value, but it'll easily work with either the NumPy float 64 or the NumPy D-type float. It doesn't matter which one it goes through, so the depreciation would not affect our code as we have it. And in our TensorFlow, we'll go ahead, let me just increase the size in there just a moment so you can get a better view of the what we're typing in. We're going to set a couple placeholders here. And so we're going to set x equals TF placeholder TF float 32. We just talked about the float 64 versus the NumPy float. We're actually just going to keep this at float 32. More than significant number of decimals for what we're working with. And since it's a placeholder, we're going to set the shape equal to, and we've set it equal to none, because at this point we're just holding the place on there. We'll be setting up as we run the batches. That's what that first value is. And then 32 by 32 by 3, that's what we reshaped our data to fit in. And then we have our y true equals placeholder TF float 32, and the shape equals none, comma 10. 10 is the 10 different labels we have, so it's an array of 10. And then let's create one more placeholder. We'll call this hold prob, or hold probability. And we're going to use this. We don't have to have a shape or anything for this. This placeholder is for what we call dropout. If you remember from our theory before, we drop out so many nodes is looking at, or the different values going through, which helps decrease bias. So we need to go ahead and put a placeholder for that also. And we'll run this, so it's all loaded up in there. So we have our 3 different placeholders. And since we're in TensorFlow, when you use Keras, it does some of this automatically, but we're in TensorFlow direct. Keras sits on TensorFlow. We're going to go ahead and create some more helper functions. We're going to create something to help us initialize the weights, initialize our bias. If you remember that each layer has to have a bias going in. We're going to go ahead and work on our conversional 2D, our max pool. So we have our pooling layer, our convolutional layer, and then our normal full layer. So we're going to go ahead and put those all into definitions. And let's see what that looks like in code. And you can also grab some of these helper functions from the MNIST, the NIST setup. We just put that in there if you're under the TensorFlow. So a lot of these are already in there, but we're going to go ahead and do our own. And we're going to create our init weights. And one of the reasons we're doing this is so that you can actually start thinking about what's going on in the back end. So even though there's ways to do this with an automation, sometimes these have to be tweaked and you have to put in your own setup in here. Now we're not going to be doing that. We're just going to recreate them for our code. And let's take a look at this. We have our weights, and so what comes in is going to be the shape, and what comes out is going to be random numbers. So we're going to go ahead and just init some random numbers based on the shape with a standard deviation of 0.1. Kind of a fun way to do that. And then the TF variable, init random distribution. So we're just creating a random distribution on there. That's all that is for the weights. Now, you might change that. You might have a higher standard deviation. In some cases, you actually load preset weights. That's pretty rare. Usually you're testing that against another model or something like that, and you want to see how those weights configure with each other. Now remember, we have our bias, so we need to go ahead and initialize the bias with a constant. In this case, we're using 0.1. A lot of times the bias is just put in as 1, and then you have your weights to add on to that. But we're going to set this as 0.1. So we want to return a convolutional 2D, in this case a neural network. This is would be a layer on here. What's going on with the conv2D is we're taking our data coming in, we're going to filter it. Strides, if you remember correctly, strides came from, here's our image, and then we only look at this picture here, and then maybe we have a stride of 1, so we look at this picture here. And we continue to look at the different filters going on there. The other thing this does is that we have our data coming in as 32 by 32 by 3. And we want to change this so that it's just, this is 3 dimensions, and it's going to reformat this as just 2 dimensions. So it's going to take this number here and combine it with the 32 by 32. So this is a very important layer here because it's reducing our data down using different means. And it connects down, I'm just going to jump down one here. It goes with the convolutional layer. So you have your kind of your pre-formatting and the setup, and then you have your actual convolution layer that goes through on there. And you can see here we have init weights by the shape, init bias, shape of 3, because we have the 3 different, here's our 3 again. And then we return the TFNN ReLU with the convention 2D, so this convolutional has this feeding into it. Right there, it's using that as part of it, and of course the input is the XY plus B, the bias. So that's quite a mouthful, but these two are the keys here to creating the convolutional layers there. The convolutional 2D coming in, and then the convolutional layer, which then steps through and creates all those filters we saw. Then of course we have our pooling. So after each time we run it through the conventional layer, we want to pool the data. If you remember correctly on the pool side, and let me just get rid of all my marks, it's getting a little crazy there. And in fact, let's go ahead and jump back to that slide. Let's just take a look at that slide over here. So we have our image coming in. We create our convolutional layer with all the filters. Remember, the filters go, the filters coming in here, and it looks at these 4 boxes, and then if it's a step, let's say step 2, it then goes to these 4 boxes, and then the next step, and so on. So we have our convolutional layer that we generate, or convolutional layers. They use the ReLU function. There's other functions out there. For this, though, the ReLU is the the one that works the best, at least so far. I'm sure that will change. And then we have our pooling. Now, if you remember correctly, the pooling was max. So if we had the filter coming in, and they did the multiplication on there, and we have a 1, and maybe a 2 here, and another 1 here, and a 3 here, 3 is the max. And so out of all of these, you then create an array that would be 3, and if the max is over here 2 or whatever it is, that's what goes into the pooling, or what's going on in our pooling. So again, we're reducing that data down. We're reducing it down as small as we can, and then finally we're going to flatten it out into a single array, and that goes into our fully connected layer. And you can see that here in the code. Right here we're going to create our normal full layer. So at some point we're going to take from our pooling layer, this will go into some kind of flattening process, and then that will be fed into the different layers going in down here. And so we have our input size. You'll see our input layer get shape, which is just going to get the shape for whatever's coming in. And then input size, initial weights is also based on the input layer coming in. And the input size down here is based on the input layer shape. So we're just going to already use the shape and already have our size coming in. And of course, you have to make sure you init the bias. Always put your bias on there. And we'll do that based on the size. So this will return tf.matmul input layer W plus B. This is just a normal full layer. That's what this means right down here. That's what we're going to return. So that was a lot of steps we went through. Let's go ahead and run that. So those are all loaded in there. And let's go ahead and create the layers. Let's see what that looks like. Now that we've done all the heavy lifting and everything, we get to do all the easy part. Let's go ahead and create our layers. We'll create a convolution layer 1 and 2 different convolutional layers, and then we'll take that and we'll flatten that out, create a reshape pooling in there for our reshape, and then we'll have our full layer at the end. So let's start by creating our first convolutional layer. Then we come in here, and let me just run that real quick. And I want you to notice on here the 3 and the 32. This is important because coming into this convolutional layer, we have 3 different channels and 32 pixels each. So that has to be in there. The 4 and 4 you can play with. This is your filter size. So if you remember, you have a filter and you have your image, and the filter slowly steps over and filters out this image depending on what your step is. For this particular setup, 4, 4 is just fine. That should work pretty good for what we're doing and for the size of the image. And then of course at the end, once you have your convolutional layer set up, you also need to pool it, and you'll see that the pooling is automatically set up so that it would see the different shape based on what's coming in. So here we have max 2x2, and we put in the convolutional one that we just created, the convolutional layer we just created goes right back into it. And that right up here, as you can see, is the X. It's coming in from here, so it knows to look at the first model and set the data accordingly, set that up so it matches. And we went ahead and ran this already. I think I ran it. Let me go and run it again. And if we're going to do one layer, let's go ahead and do a second layer down here. And it's we'll call it Convo 2. It's also a convolutional layer on this. And you'll see that we're feeding convolutional 1 in, the pooling. So it goes from convolutional 1 into convolutional 1 pooling, from convolutional 1 pooling into convolutional 2, and then from convolutional 2 into convolutional 2 pooling. And we'll go ahead and take this and run this. So these variables are all loaded into memory. And for our flattened layer, let's go ahead and we'll do, since we have 64 coming out of here and we have 4x4 going in, let's do 8x8 by 64. So let's do 4096. This is going to be the flat layer. So that's how many bits are coming through on the flat layer. And we'll reshape this. So we'll reshape our Convo 2 pooling, and that will feed into here, the Convo 2 pooling, and then we're going to set it up as a single layer that's 4096 in size. That's what that means there. We'll go ahead and run this. So we've now created this variable, the Convo 2 flat, and then we have our first full layer. This is the final neural network where we have the flat layer going in. And we're going to again use the ReLU for our setup on there in a neural network for evaluation. And you'll notice that we're going to create our first full layer. Our normal full layer, that's our definition. So we created that. That's creating the normal full layer. And our input for the data comes right here from this goes right into it. The Convo 2 flat. So this tells it how big the data is. And we're going to have it come out. It's going to have 1024. That's how big the layer is coming out. We'll go ahead and run this. So now we have our full layer 1. And with the full layer 1, we want to also define the full 1 dropout to go with that. So our full layer 1 comes in, keep probability equals hold probability. Remember we created that earlier. And the full layer 1 is what's coming into it. And this is going backwards and training the data. We're not training every weight. We're only training a percentage of them each time, which helps get rid of the bias. So let me go ahead and run that. And finally, we'll go ahead and create a Y-predict, which is going to equal the normal full 1 dropout and 10, because we have 10 labels in there. Now, in this neural network, we could have added additional layers. That would be another option to play with. You can also play with, instead of 1024, you can use other numbers for the way that sets up on what's coming out and going into the next one. We're only going to do just the 1 layer and the 1 layer dropout. And you can see if we did another layer, it'd be real easy just to feed in the full 1 dropout into full layer 2. And then full layer 2 dropout would have full layer 2 feed into it. And then you'd switch that here for the Y prediction. For right now, this is great. This particular data set is tried and true, and we know that this will work on it. And if we just type in Y predict and we run that, we'll see that this is a tensor object, shape $10, D-type 32. Quick way to double check what we're working on. So now we've got all of our, we've done a setup all the way to the Y predict, which we just did. We want to go ahead and apply the loss function and make sure that's set up in there. Create the optimizer. And then train our optimizer and create a variable to initialize all the global TF variables. So before we dive into the loss function, let me point out one quick thing, or just kind of a rehab over a couple things. And that is, when we're playing with these setups, we pointed out up here we can change the 4-4 and use different numbers there. They change your outcome. So depending on what numbers you use here will have a huge impact on how well your model fits. And that's the same here with the 1024 also. This is also another number that if you continue to raise that number, you'll get possibly a better fit. You might overfit. And if you lower that number, you'll use less resources. And generally, you want to use this in the exponential growth. An exponential being 2, 4, 8, 16. And in this case, the next one down would be 5, 12. You can use any number there, but those would be the ideal numbers when you look at this data. So the next step in all this is we need to also create a way of tracking how good our model is. And we're going to call this a loss function. And so we're going to create a cross-entropy loss function. And so before we discuss exactly what that is, let's take a look and see what we're feeding it. We're going to feed it our labels, and we have our true labels and our prediction labels. So coming in here is the two different variables we're sending in, or the two different probability distributions, is one that we know is true and what we think it's going to be. Now this function right here, when they talk about cross entropy, in information theory, the cross entropy between two probability distributions over the same underlying set of events measures the average number of bits needed to identify an event drawn from the set. That's a mouthful. Really, we're just looking at the amount of error in here. How many of these are correct and how many of these are incorrect? So how much of it matches? And we're going to look at that. We're just going to look at the average. That's what the mean, the reduced to the mean means here. So we're looking at the average error on this. And so the next step is we're going to take the error. We want to know our cross entropy, or our loss function, how much loss we have. That's going to be part of how we train the model. So when you know what the loss is and we're training it, you feed that back into the back propagation setup. And so we want to go ahead and optimize that. Here's our optimizer. We're going to create the optimizer using an atom optimizer. Remember, there's a lot of different ways of optimizing the data. Atom's the most popular used. So our optimizer is going to equal the TF train atom optimizer. If you don't remember what the learning rate is, let me just pop this back into here. Here's our learning rate. When you have your weights, you have all your weights and your different nodes that are coming out. Here's our node coming out, and it has all its weights. And then the error is being sent back through in reverse on our neural network. So we take this error and we adjust these weights based on the different formulas. In this case, the atom formula is what we're using. We don't want to just adjust them completely. We don't want to change this weight so it exactly fits the data coming through. Because if we made that kind of adjustment, it's going to be biased to whatever the last data we sent through is. Instead, we're going to multiply that by 0.001 and make a very small shift in this weight. So our delta W is only 0.001 of the actual delta W of the full change we're going to compute from the atom. And then we want to go ahead and train it. So our training, or set up a training variable or function. And this is going to equal our optimizer minimize cross entropy. And we make sure we go ahead and run this. So it's loaded in there. And then we're almost ready to train our model. But before we do that, we need to create one more variable in here. And we're going to create a variable to initialize all the global TF variables. And when we look at this, the TF global variable initializer, this is a TensorFlow object. It goes through there and it looks at all our different setup that we have going under our TensorFlow, and then initializes those variables. So it's kind of like a magic wand because it's all hidden in the back end of TensorFlow. All you need to know about this is that you have to have the initialization on there, which is an operation, and you have to run that once you have your setup going. So we'll go ahead and run this piece of code, and then we're going to go ahead and train our data. So let me run this so it's loaded up there. And so now we're going to go ahead and run the model by creating a graph session. Graph session is a TensorFlow term. So you'll see that coming up. It's one of the things that throws me because I always think of GraphX and Spark and Graph as just general graphing. But they talk about a graph session. So we're going to go ahead and run the model. And let's go ahead and walk through this, what's going on here. And let's paste this data in here. And here we go. So we're going to start off with a TF session as ses. So that's our actual TF session that we've created. So we're right here with the TF session. Our session we're creating, we're going to run TF global variable initializer. So right off the bat, we're initializing our variables here. And then we have for I in range 500. So what's going on here, remember 500, we're going to break the data up and we're going to batch it in at 500 points each. We've created our session run, so we're going to do with TF session as session right here. We've created our variable session. And then we're going to run and we're going to go ahead and initialize it. So we have our TF global variables initializer that we created. That initializes our session in here. The next thing we're going to do is we're going to go for I in range of 500, batch equals ch.next batch. So if you remember correctly, this is loading up 100 pictures at a time. And this is going to loop through that 500 times. So we are literally doing, 500 times 100 is 50,000. So that's 50,000 pictures we're going to process right there. In the first process is we're going to do a session run. We're going to take our train. We created our train variable or optimizer in there. We're going to feed it the dictionary. We had our feed dictionary that we created, and we have x equals batch 0 coming in, y true, batch 1, hold the probability, 0.5. And then just so that we can keep track of what's going on, we're going to, every 100 steps, we're going to run a print. So currently on step, format, accuracy is, and we're going to look at matches equals tf dot equal tf argument y prediction 1 tf dot arg max y true comma 1. So we're going to look at this as how many matches it has. And here our ACC, all we're doing here is we're going to take the matches, how many matches they have, it generates a chart. We're going to convert that to float. That's what the TF cast does. And then we just want to know the average. We just want to know the average of the accuracy. And then we'll go ahead and print that out, print session run accuracy feed dictionary. So it takes all this and it prints out our accuracy on there. So let's go ahead and take this, oops, flip screens there. Let's go ahead and take this and let's run it. And this is going to take a little bit to run. So let's see what happens on my old laptop. And we'll see here that we have our current, we're currently on step 0. It takes a little bit to get through the accuracy. And this will take just a moment to run. We can see that on our step 0 it has an accuracy of 0.1 or 0.1028. And as it's running, we'll go ahead, you don't need to watch it run all the way, but this accuracy is going to change a little bit up and down. So we've actually lost some accuracy during our step 2. But we'll see how that comes out. Let's come back after we run it all the way through and see how the different steps come out. I was actually reading that backwards. The way this works is the closer we get to 1, the more accuracy we have. So you can see here we've gone from a 0.1 to a 0.39, and we'll go ahead and pause this and come back and see what happens when we're done with the full run. Alright, now that we've prepared the meal, got it in the oven, and pulled out my finished dish here, if you've ever watched any of the old cooking shows, let's discuss a little bit about this accuracy going on here, and how do you interpret that? We've done a couple things. First, we've defined accuracy. The reason I got it backwards before is you have loss or accuracy. And with loss, you'll get a graph that looks like this. It goes, oops, that's an S, by the way. There we go. You get a graph that curves down like this. And with accuracy, you get a graph that curves up. This is how good it's doing. Now, in this case, 1 is supposed to be really good accuracy. That means it gets close to 1, but it never crosses 1. So if you have an accuracy of 1, that is phenomenal. In fact, that's pretty much unheard of. And the same thing with loss. If you have a loss of 0, that's also unheard of. And the 0 is actually on this axis right here as we go in there. So how do we interpret that? Because, if I was looking at this and I go, oh, 0.51, that's 51%. You're doing 50-50. No, this is not percentage. Let me just put that in there. It is not percentage. This is logarithmic. What that means is that 0.2 is twice as good as 0.1. And when we see 0.4, that's twice as good as 0.2. Real way to convert this into a percentage. You really can't say this is a direct percentage conversion. What you can do, though, is in your head, if we were to give this a percentage, we might look at this as 50%, we're just guessing, equals 0.1. And if 50% roughly equals 0.1, that's where we started up here at the top. Remember at the top here, here's our 0.1028. The accuracy of 50%, then 75% is about 0.2, and so on and so on. Don't quote those numbers because that doesn't work that way. They say that if you have 0.95, that's pretty much saying 100%. And if you have anywhere between, you'd have to go look this up. Let me go ahead and remove all my drawings there. So the magic number is 0.5. We really want to be over a 0.5 in this whole thing. And we have both 0.5004. Remember, this is accuracy. If we were looking at loss, then we'd be looking the other way. But 0.0, instead of how high it is, we want how low it is. But with accuracy, being over a 0.5 is pretty valid. That means this is pretty solid. And if you get to a 0.95, then it's a direct correlation. That's what we're looking for here in these numbers. You can see we finished with this model at 0.5135, so still good. And if we look at when they ran this on the other end, remember there's a lot of randomness that goes into it when we seed the weights. They got 0.5251, so a little better than ours. But that's fine. You'll find your own comes up a little bit better or worse depending on just that randomness. And so we've gone through the whole model. We've trained the model, and we've also gone through on every 100th run to test the model to see how accurate it is.
So what is deep learning? Deep learning is a subset of machine learning, which itself is a branch of artificial intelligence. Unlike traditional machine learning models, which require manual feature extraction, deep learning models automatically discovers representation from raw data. So this is made possible through neural networks, particularly deep neural networks, which consist of multiple layers of interconnected nodes. So these neural networks are inspired by the structure and the function of human brain. Each layer in the network transforms the input data into more abstract and composite representation. For instance, in image recognition, the initial layer might detect simple features like edges and textures, while the deeper layer recognizes more complex structure like shapes and objects. So one of the key advantages of deep learning is its ability to handle large amount of unstructured data, such as images, audios, and text, making it extremely powerful for various applications. So stay tuned as we delve deeper into how these neural networks are trained, the types of deep learning models, and some exciting applications that are shaping our future. Types of deep learning. Deep learning AI can be applied supervised, unsupervised, and reinforcement machine learning, using various methods for each. The first one, supervised machine learning. In supervised learning, the neural network learns to make prediction or classify that data using labeled datasets. Both input features and target variables are provided, and the network learns by minimizing the error between its prediction and the actual targets. A process called backpropagation. CNN and RNN are the common deep learning algorithms used for tasks like image classification, sentiment analysis, and language translation. The second one, unsupervised machine learning. In unsupervised machine learning, the neural network discovers patterns or clusters in unlabeled datasets without target variables. It identifies hidden pattern or relationship within the data. Algorithms like autoencoders and generative models are used for tasks such as clustering, dimensionality reduction, and anomaly detection. The third one, reinforcement machine learning. In this, an agent learns to make decisions in an environment to maximize a reward signal. The agent takes action, observes the records, and learns policies to maximize cumulative rewards over time. Deep reinforcement learning algorithms like deep Q networks and deep deterministic polygradient are used for tasks such as robotics and gameplay. Moving forward, let's see what are the artificial neural networks. Artificial neural networks, ANNs inspired by the structure and the function of human neurons, consist of interconnected layers of artificial neurals or units. The input layer receives data from the external resources and it passes to one or more hidden layers. Each neuron in these layers computes a weighted sum of inputs and transfers the result to the next layer. During training, the weight of these connections are adjusted to optimize the network's performance. A fully connected artificial neural network includes an input layer or more hidden layers and an output layer. Each neuron in a hidden layer receives input from the previous layer and sends its output to the next layer. So this process continues until the final output layer produces the network response. So moving forward, let's see types of neural networks. So deep learning models can automatically learn features from data, making them ideal to tasks like image recognition, speech recognition, and natural language processing. So the most common architecture in deep learnings are the first one, feed-forward neural network, FNNs. So these are the simplest type of neural network where information flows linearly from the input to the output. They are widely used for tasks such as image classification, speech recognition, and natural language processing, NLP. The second one, convolutional neural network, designed specifically for image and video recognition. CNNs automatically learn features from images, making them ideal for image classification, object detection, and image segmentation. The third one, recurrent neural networks, RNNs, are specialized for processing sequential data time series and natural language. They maintain an internal state to capture information from previous input, making them suitable for tasks such as speech recognition, NLP, and language translation. So now let's move forward and see some deep learning application. The first one is autonomous vehicle. Deep learning is changing the development of self-driving car. Algorithms like CNNs process data from sensors and cameras to detect objects, recognize traffic signs, and make driving decisions in real time, enhancing safety and efficiency on the road. The second one is healthcare diagnostic. Deep learning models are being used to analyze medical images such as X-rays, MRIs, and CT scans with high accuracy. They help in early detection and diagnosis of diseases like cancer, improving treatment outcomes and saving lives. The third one is NLP. Recent advancement in NLP powered by deep learning models like Transformer, ChatGPT have led to more sophisticated and human-like text generation, translation, and sentiment analysis. So applications include virtual assistant, chatbots, and automated customer service. The fourth one, deepfake technology. So deep learning techniques are used to create highly realistic synthetic media known as deepfakes. While this technology has entertainment and creative application, it also raises ethical concern regarding misinformation and digital manipulation. The fifth one, predictive maintenance. In industries like manufacturing and aviation, deep learning models predict equipment failures before they occur by analyzing sensor data. Their proactive approach reduces downtime, lowers maintenance cost, and improves operational efficiency. So now let's move forward and see some advantages and disadvantages of deep learning. So first one is high computational requirements. So deep learning requires significant data and computational resources for training. Whereas advantage is high accuracy, achieves state-of-the-art performance in tasks like image recognition and natural language processing. Whereas deep learning needs large labeled datasets, often require extensive labeled dataset for training, which can be costly and time consuming together. So second advantage of deep learning is automated feature engineering. Automatically discovers and learn relevant features from data without manual intervention. The third disadvantage is overfitting. So deep learning can overfit to training data, leading to poor performance on new unseen data. Whereas the third deep learning advantage is scalability. So deep learning can handle large complex dataset and learn from massive amount of data. So in conclusion, deep learning is a transformative leap in AI, mimicking human neural networks. It has changed healthcare, finance, autonomous vehicles, and NLP.
Did you know that you can easily build a website for free using AI? And that's not a trick. It's completely true. Thanks to the amazing new AI tools, anyone can create a website even without writing a single line of code. Even if you have no technical experience, you can set up a professional website quickly and easily. In this video, I'm going to show you how you can build a website without even writing a single line of code, using the power of AI and no-code tools. In today's video, we have split this video into two parts to make it more simple and easy to follow. So whether you are a complete beginner or a business owner or even a student, this is something anyone can do. In the first part, I'll guide you through how to build a website using Pantheon and WordPress. You don't need any coding skills for this. Plus, we will use Gravity Write, an AI tool that helps you generate content for your website, like About Us page or blog post. AI will take care of everything from writing to saving your time and also giving the maximum effort. In the second part, we look at some of the best AI website builders like Durable, Cleap AI, and Pineapple AI. These tools are actually free of cost and can build your website for you just in few seconds. You don't even have to worry about the design or content. AI will handle everything. It's fast, easy, and perfect for anyone who needs a website but doesn't want to struggle with coding. So if you're looking to create a website quickly and for free, you're in the right place. Stick around and I'll show you step by step how to get your website live using these top-notch code and AI-powered platforms. So let's get started and see how AI is making web design easier than ever.
So let's move on to the demo part. Alright, so now that we know what we're going to cover, let's jump into the first part, which is building a website using Pantheon. And this is the Pantheon website we have logged in. And for this, you have to just click on Get Started. And then we will move on to the WordPress part. So here, as you can see, you have to just simply fill up your details. So I've filled up my details here and just click on Continue. Wait for a few seconds till the dashboard is being loaded. And then you have to just simply click on Create a Site. And then we will be selecting WordPress. So now, as you can see, we have successfully logged into our Pantheon account and we have also created our account. Now the next step will be installing this WordPress account and then deploying our website in Pantheon in WordPress. So we will just simply click on WordPress here. Okay, You have to enter your Pantheon site name. Suppose I want to keep my name as Urban Threads India, and then just click on continue here. So as you can see, the site name already exists, so we have to just change our name. We'll just put new over here. Let's see what it shows. New Urban Threads, and just click on continue. So if this website name is not registered, it will successfully create my website using this particular name. So now the dashboard is being loaded. We just have to wait for a few seconds till it deploys our WordPress. Okay, so now that our WordPress is successfully deployed, we just have to click on visit your Pantheon site dashboard, and then it will load the dashboard. So now you have to click on visit development site, and here you have to select the preferred language which you'll be using. So I've already selected my language, which is English here, and just click on continue. And now as you can see that our WordPress installation is successfully done. So now I'll be just writing my title name, which is New Urban Threads, and write the username here, provide your name, and yeah, this password you can copy it or you can change your password accordingly. Just provide your email address here and click on discourage search engines from indexing the site, and just select on install WordPress. So now that our installation is completely done, we can log into our WordPress account, and here you have to provide your username and the email address which you have used in order to create this account. Copy paste the password here and just click on login. So this is the WordPress interface here. Now so this is the WordPress installation we have done, and now the next step will be building our website. So as you can see, we have successfully installed our WordPress, and this is the dashboard being shown. Now you have to click on plugins and just select add new plugin, and from here you have to select plugin which is a starter template, and just select enter. So this is the template which we will be using to create our website. So you have to install this template here, wait for a few seconds, and then click on activate. So there are two ways of building our website here. The first one is using the AI website builder, which will be using features like zip WP to help to build a website faster. And the second step, which is quite old and traditional, which is using the classic starter template. So using this method, you have to create a website, professionally designed templates to meet the requirements. I mean, you have to just select a template, already made website template, and from there you can customize and edit accordingly. But for the first step, I'll be showing you how to make using the AI website builder. So just simply click on build with AI. Okay, and here you have to select let's get started. So as you can see, we are building our website using zip WP, which is an AI tool that can automatically create our website content and layout, and it makes our work super easy. So now, as you can see, we are connecting our zip WP account with this website, Pantheon website, and then we will click on continue here. Okay, so as now you can see, we have logged into our zip WP account, and from here you can select as per as your use. So for now, we will be going with the free version and just click on get started here. So this is the verification code it has sent to my email. We'll just wait for a few minutes. So now you have to give the name of your website which you're building, which was New Urban Threads, and you just have to provide the detail. What is this website used for? Is it for clothing, spa, gym, local business, non-profit, entrepreneur, agency? So here we will just click on entrepreneur and just click on next. So it's written describe your new urban threads in few words. So here you have to describe what your website, what your business is about in a few words. Or also here's an option like you can also write using the AI. So you can just simply click here, write using AI. And now you can see it has created a description for your Urban Threads website account. So it has already written what your website will be about. See, it's written it's an innovative fashion brand in San Francisco. Since we are in India, you can all modify here as per as your needs. So just provide Bengaluru and I'll just give here India. Okay, and whatever customization you have to do, you can do it. So it was founded 2001. I'll just put it 2024 and just click on next. So as you can see, it has already given a description for your website here, and now you have to provide your email address. You can also add your social media account if you want to, and just click on next here. Okay, so these are the images you want to pick. So just select on the images. Since it's my clothing online store, you can just select few images from here. You can select this. You can also just simply search here fashion or street style fashion. Okay, so as you can see, these are few images it has shown for us. I'll just select this also. You can also upload your images if you want to, and then we will click on next. So now since we have described our website and given our contact details and address and also uploaded the image here, the next step is choosing the design. So here from this templates given, you can choose your design, whatever you want your website to be displayed as. So these designs are actually premium. You can select, since we are using the free trial here, you can select the free version here. So whatever style it's looking good, you can just select that accordingly. Since I like this more, I'll just select this. And this is just a sneak peek of how our actual website will be. So just take a look, how will it look like. Alright, and from here you can actually upload your logo. So just click on select files. So this is our logo here, new urban threads. And you can also decrease the logo width accordingly. You can also change the font pair, whatever you want your website font to be in. So since I like this more, I'll just keep it this. You can change the color palette also. So I'll be selecting this as my color palette and I'll select continue. So also you can add features in your website, what features you want. Blog, contact form, automation integrations, video player, page builder, e-commerce, that cart, donations, free live chat. So I will just simply click on free live chat as I want this to be displayed as a feature in my website, and I'll just select start building. So we are preparing your website. You just have to wait for a few seconds till it prepares our website. So as you can see, our website is now ready and you can just click on this option. Okay, and now the next step will be editing our layout and the content in our website according to. Just simply click on edit page here. So from here you can just edit the homepage sustainable or okay. So this is the description here. You can add it accordingly, or you can also ask the AI to write it or make it more shorter here. You can also change the layout of this button, and from here click on content and the image icon you want it to be. So if you want this icon to be enabled, you have to just click on select here, and what style you want in your title plus your description. You can just change it accordingly. Since I want to keep it in white color, I'll just go with it. And okay, Alex turns journey to some sustainable fashion. These are the demo post 1 reviews. You can just simply click here and change if you want to. These are the testimonials of what our customers say here. And now if you want to stay in touch, you have to just enter your email address. To continue reading, you can just select here. So see, you can just customize it accordingly and edit your layout if you want to. And the best way I do it is using an AI tool known as Gravity Write. So you can just search your Gravity Write. This AI tool will help you to generate content for your website. I'll just show you how. So you have to just enter your email address here. Okay, so as you can see, it has got bundles and plenty of option here to provide you content for any of the thing, for booking management, course creator, music, website content. So since I want content for my website, see, you can even get some domain name ideas and create homepage, service page content using this AI tool, which is really amazing. So let's go back to our web page and we will just simply save this. So now we have finally viewed our page here. So this is how our actual page will look like. Our actual website, how it looks like. Isn't it really amazing? Just within few seconds, following few steps, you are now able to create an amazing website. So now that we have created a website, the next step is purchasing a domain name. For this, you can use one website which is called Web Space Kit or Hostinger. So I'll be showing you here. Just simply type Web Space Kit. And if you think you can buy a free domain, I don't think so. It is possible to buy a free domain. It's obviously paid, but then you can use this website to actually buy a domain in lesser price, which is only 139 rupees per month. And you can just view the plans and simply buy. And the next website is Hostinger. So these services will let you buy a domain and host your website in a very small fee. So all the links will be added in the description box if you want to check out these websites and create and buy your domain for publishing it online in the internet. You can use either hosting it or WebSpace Kit. Also, one more thing. Now that we have decided to move our website for WebSpace Kit for hosting, you need to install a plugin on your Pantheon website, which is known as Migrate Guru. And using this plugin, you can actually, wait, I'll show you the plugin here. So you have to just simply click on add new plugin, and the plugin name is Migrate Guru. So we'll just search for Migrate Guru here. And using this, you have to just simply click on this. Now, why do we have to do it? I've already explained you. This will help you just have to install it on both your Pantheon site as well as your WebSpace, and it will help you to move everything over just within a few clicks. So we have now created a fully functional website using our AI. The second step was using the template version. You can also use the template version if you want to. So now that we have covered how to build a website using Pantheon, WordPress, so now we will discuss quickly the free AI tools which you can use to make your website even more faster. The first one on the list is Hookos AI. So you just have to simply click on Hookos AI Builder and it will create your website within just 5 minutes. So you have to just simply enter your email address and just click on Get Your AI Website here. As you can see, within just few steps, you have to just provide the details and the description of your website purpose. So suppose it's for travel, just simply write travel here and select categories like travel agent, equipment store. So it's a travel blog, so I'll just simply click on travel blog here. So you just can provide it accordingly what features you want to be included in your website here. So if I want to create a blog website for travel, just simply click on write a blog and just create a website. So as you can see, these are the steps here involved. So it's for my online business only. You can just simply provide business name here. Wander with me is my website name. So now you can see we're almost finished. So select the 3 unique aspects of your business, which is affordable prices, friendly, easy navigation, and just select on continue here. Just one more step and we will be done building our website. The second step is you can either what website visitors, how you want your website visitors to connect with you. So if you want your website visitors to connect via phone or contact form, I want them to connect via contact form and I'll just simply click on continue. So this is the layout they have generated for us for my travel blog website. Select the template you wanted I like this one, so I'll just quickly click on this and select continue. So see, this is the website it has created for me here, and it's really good. So I really like the layout it has generated for me here, and also the font. You can just change, customize, and edit your blog accordingly. If you want to keep it in pink color, you can also choose that, and also edit the images if you want to. See, you can add your touch here, and I like it in this font. If you like it in this font, you can just simply click here and create my website. So as you can see, our site is now created here, and this is really amazing. I mean, within just a few steps, you can create a fully functional website using this AI tool. Now let's discuss the second AI tool on the list, which is Leia AI. Just search your LEIA AI website builder. And this is also one of the amazing website builder you can create within just few seconds. You have to just click on get started here and just type, suppose I want a yoga studio website, and just click on next here. Just build my site and click on continue. So it will not take even a minute to build this website. Just click on view it. And now you can see that a yoga studio website is functionally built here. Like just within, and this is way more, I guess, faster than the previous AI website we have discussed before. I mean, you do not have to even provide description and it will just generate website for you. So from here, you can just simply replace the image, delete the element you want to, and add the content accordingly. So this was way more faster than the previous website, AI website we have generated. Now let's quickly dive into the third website tool, which is Pineapple AI. Just simply type Pineapple AI website builder and see. This is the website's interface. And here also you can just simply write your website you want. For example, you want a website for kindergarten school. You want to create a website for kindergarten school offering best education in town with all the modern technologies used to educate students. And just simply click on generate here. So see, you have to train your AI and just provide the business details you want to, and just simply click on next option to generate your website. So you can just simply click on the website template you want to. So if I like this one, I'll just simply click here and just click on AI customize and see, it will generate a website for you. And from here, you can add details to start generation. And like this, you can create a website. I mean, it is good, but I like the previous two AI tools more, which could create really amazing website within just a few seconds. This was the template we had selected, and from here you have to just simply click on each of the content you want to edit and just pick your design here. All right. So let's move on to the next website, which is Cleep AI. Just simply search Cleep AI website builder and let's see how this website is. So you can just simply click on try for free option here and search for business. If your business is related to health and beauty, just select that. If you're an entrepreneur, select entrepreneur. What name it should be? Fit India. What's your goal to make money online? Location you can set accordingly. With AI, add some information. For information, you can use either ChatGPT or your Gravity to generate content. So just copy paste the content here from either ChatGPT or this. You can also provide your logo and the picture of your choice and just simply click on next here. You can choose any of the style you want. And now you can see that your AI is building your content. So as you can see, this website is being created using the Clean AI tool. So this is a website. You can just click on the site settings and just change the template or the style you want, however you want to be. So let's talk about the final AI website builder, which is my personal favorite, which is Durable AI. So we just click on Durable AI and let's check how this AI will create content for us. We'll just select generate your website here. So what type of website are you building? It's we will use the same fashion online clothing store. Name of your business is Trendy Collections. Just click on generate websites. So you just have to wait for a few seconds and a website will be generated. So since I had provided my location, Bengaluru, so it has created my website called Bengaluru's latest collection website. You can check it now. So as you can see, our website is now ready and you can also edit your website accordingly. This tool creates websites in a matter of seconds. Just give some basic details and Durable AI generates a complete website including content, images and layout. If you're in a hurry, this is the perfect solution for you. I would highly recommend using this tool. And now you can see the pricing label and everything mentioned here. It's superb. I mean, the quality and the layout it has provided is really good. So now you can just click on edit section and edit accordingly. So guys, we have come to the end of our video. You know now how to build a no-code website using platforms like Pantheon and WordPress, as well as how quickly it generates website using AI-powered builders like ZipWP, Hookoo's AI, Clip AI, and my personal favorite, Durable AI. So whether you want full control over your website or fast AI-generated solutions, these tools are really game changers. So check out the link mentioned in the description box and you are good to go.
RNN tutorial. That's the recurrent neural network. So we talk about a feed-forward neural network. In a feed-forward neural network, information flows only in the forward direction, from the input nodes through the hidden layers, if any, and to the output nodes. There are no cycles or loops in the network. And so you can see here we have our input layer. I was talking about how it just goes straight forward into the hidden layers. So each one of those connects and then connects to the next hidden layer, connects to the output layer. And of course we have a nice simplified version where it has a predicted output and they refer to the input as X a lot of times and the output as Y. Decisions are based on current input, no memory about the past, no future scope. Why recurrent neural network? Issues in feed-forward neural network. So one of the biggest issues is because it doesn't have a scope of memory or time, a feed-forward neural network doesn't know how to handle sequential data. It only considers only the current input. So if you have a series of things and because 3 points back affects what's happening now and what your output affects what's happening, that's very important. So whatever I put as an output is going to affect the next one. A feed forward doesn't look at any of that. It just looks at this is what's coming in. And it cannot memorize previous inputs. So it doesn't have that list of inputs coming in. Solution to feed forward neural network. You'll see here where it says recurrent neural network, and we have our X on the bottom going to H, going to Y. That's your feed forward. But right in the middle, it has a value C, so there's a whole other process. So it's memorizing what's going on in the hidden layers, and the hidden layers, as they produce data, feed into the next one. So your hidden layer might have an output that goes off to Y, but that output goes back into the next prediction coming in. What this does is this allows it to handle sequential data. It considers the current input and also the previously received inputs. And if we're going to look at general drawings and solutions, we should also look at applications of the RNN. Image captioning. RNN is used to caption an image by analyzing the activities present in it. A dog catching a ball in midair. That's very tough. I mean, we have a lot of stuff that analyzes images of a dog and the image of a ball, but it's able to add one more feature in there that's actually catching the ball in midair. Time series prediction. Any time series problem like predicting the prices of stocks in a particular month can be solved using RNN. And we'll dive into that in our use case and actually take a look at some stock. One of the things you should know about analyzing stock today is that it is very difficult. And if you're analyzing the whole stock, the stock market at the New York Stock Exchange in the US produces somewhere in the neighborhood, if you count all the individual trades and fluctuations by the second, it's like 3 terabytes a day of data. So we're only going to look at one stock. Just analyzing one stock is really tricky. In here, we'll give you a little jump on that, so that's exciting, but don't expect to get rich off of it immediately. Another application of the RNN is natural language processing. Text mining and sentiment analysis can be carried out using RNN for natural language processing. And you can see right here the term natural language processing, when you stream those 3 words together, is very different than if I said processing language naturally. So the time series is very important when we're analyzing sentiments. It can change the whole value of a sentence just by switching the words around. Or if you're just counting the words, you might get one sentiment where if you actually look at the order they're in, you get a completely different sentiment. When it rains, look for rainbows. When it's dark, look for stars. Both of these are positive sentiments, and they're based upon the order of which the sentence is going in. Machine translation. Given an input in one language, RNN can be used to translate the input into a different languages as output. I myself am very linguistically challenged. But if you study languages and you're good with languages, you know right away that if you're speaking English, you would say big cat. And if you're speaking Spanish, you would say cat big. So that translation is really important to get the right order, to get, there's all kinds of parts of speech that are important to know by the order of the words. Here this person is speaking in English and getting translated. And you can see here a person is speaking in English in this little diagram. I guess that's denoted by the flags. I have a flag. I own it. No. But they're speaking in English and it's getting translated into Chinese, Italian, French, German, and Spanish languages. Some of the tools coming out are just so cool. So somebody like myself who's very linguistically challenged, I can now travel into worlds I would never think of, because I can have something translate my English back and forth readily, and I'm not stuck with a communication gap. So let's dive into what is a recurrent neural network. Recurrent neural network works on the principle of saving the output of a layer and feeding this back to the input in order to predict the output of the layer. Sounds a little confusing. When we start breaking it down, it'll make more sense. And usually we have a propagation forward neural network with the input layers, the hidden layers, the output layer. With the recurrent neural network, we turn that on its side. So here it is, and now our X comes up from the bottom into the hidden layers into Y, and they usually draw it very simplified, X to H, with C as a loop, A to Y, where A, B, and C are the perimeters. A lot of times you'll see this kind of drawing in here, digging closer and closer into the H and how it works. Going from left to right, you'll see that the C goes in, and then the X goes in. So the X is going upward bound, and C is going to the right. A is going out. And C is also going out. That's where it gets a little confusing. So here we have X in, C in, and then we have Y out and C out. And C is based on HT minus 1. So our value is based on the Y and the H value are connected to each other. They're not necessarily the same value because H can be its own thing. And usually we draw this, or we represent it as a function. H of T equals a function of C, where H of T minus 1, that's the last H output, and X of T going in. So it's the last output of H combined with the new input of X, where HT is the new state, FC is a function with the parameters C, that's a common way of denoting it, HT minus 1 is the old state coming out, and then X of T is an input vector at time of step T. Well, we need to cover types of recurrent neural networks. And so the first one is the most common one, which is a one-to-one single output. One-to-one neural network is usually known as a vanilla neural network, used for regular machine learning problems. Why? Because vanilla is usually considered kind of just a real basic flavor. But because it's very basic, a lot of times they'll call it the vanilla neural network, which is not the common term, but it is, like kind of a slang term. People will know what you're talking about usually if you say that. Then we run one to many, so you have a single input, and you might have multiple outputs. In this case, image captioning, as we looked at earlier, where we have not just looking at it as a dog, but a dog catching a ball in the air. And then you have many-to-one network, takes in a sequence of inputs. Examples, sentiment analysis, where a given sentence can be classified as expressing positive or negative sentiments. And we looked at that as we were discussing, if it rains, look for a rainbow. So positive sentiment where rain might be a negative sentiment if you were just adding up the words in there. And then, of course, if you're going to do a one-to-one, many-to-one, one-to-many, there's many-to-many networks, takes in a sequence of inputs and generates a sequence of outputs. Example, machine translation. So we have a lengthy sentence coming in English and then going out in all the different languages. Just a wonderful tool. Very complicated set of computations. If you're a translator, you realize just how difficult it is to translate into different languages. One of the biggest things you need to understand when we're working with this neural network is what's called the vanishing gradient problem. While training an RNN, your slope can be either too small or very large, and this makes training difficult. When the slope is too small, the problem is known as vanishing gradient. And you'll see here they have a nice image, loss of information through time. So if you're pushing not enough information forward, that information is lost, and then when you go to train it, you start losing the third word in the sentence or something like that, or it doesn't quite follow the full logic of what you're working on. Exploding gradient problem. Oh, this is one that runs into everybody. When you're working with this particular neural network, when the slope tends to grow exponentially instead of decaying, this problem is called exploding gradient. Issues in gradient problem: long training time, poor performance, bad accuracy. And I'll add one more in there. Your computer, if you're on a lower end computer testing out a model, will lock up and give you the memory error. Explaining gradient problem. Consider the following two examples to understand what should be the next word in the sequence. The person who took my bike and blank, a thief. The students who got into engineering with blank from Asia. And you can see in here we have our x value going in, we have the previous value going forward, and then you back propagate the error like you do with any neural network. And as we're looking for that missing word, maybe we'll have the person took my bike and blank was a thief. And the student who got into engineering with a blank were from Asia. Consider the following example, the person who took the bike. So we'll go back to the person who took the bike was blank a thief. In order to understand what would be the next word in the sequence, the RNN must memorize the previous context, whether the subject was singular noun or a plural noun. So was a thief is singular. The student who got into engineering, well, in order to understand what would be the next word in the sequence, the RNN must memorize the previous context, whether the subject was singular noun or a plural noun. And so you can see here the students who got into engineering with blank were from Asia. It might be sometimes difficult for the error to back propagate to the beginning of the sequence to predict what should be the output. So when you run into the gradient problem, we need a solution, the solution to the gradient problem. First, we're going to look at exploding gradient, where we have three different solutions depending on what's going on. One is identity initialization. So the first thing we want to do is see if we can find a way to minimize the identities coming in instead of having it identify everything, just the important information we're looking at. Next is to truncate the back propagation. So instead of having whatever information it's sending to the next series, we can truncate what it's sending. We can lower that particular set of layers, make those smaller. And finally is a gradient clipping. So when we're training it, we can clip what that gradient looks like and narrow the training model that we're using. When you have a vanishing gradient, the option problem, we can take a look at weight initialization, very similar to the identity, but we're going to add more weights in there so it can identify different aspects of what's coming in better. Choosing the right activation function. That's huge. So we might be activating based on one thing and we need to limit that. We haven't talked too much about activation functions, so we'll look at that just minimally. There's a lot of choices out there. And then finally there's long short-term memory networks, the LSTMS. And we can make adjustments to that. So just like we can clip the gradient as it comes out, we can also expand on that. We can increase the memory network, the size of it, so it handles more information. And one of the most common problems in today's setup is what they call long-term dependencies. Suppose we try to predict the last word in the text. The clouds are in the, and you probably said sky. Here we do not need any further context. It's pretty clear that the last word is going to be sky. Suppose we try to predict the last word in the text. I have been staying in Spain for the last 10 years. I can speak fluent Maybe you said Portuguese or French. No, you probably said Spanish. The word we predict will depend on the previous few words in context. Here we need the context of Spain to predict the last word in the text. It's possible that the gap between the relevant information and the point where it is needed to become very large. LSTMs help us solve this problem. So the LSTMs are a special kind of recurrent neural network capable of learning long-term dependencies. Remembering information for long periods of time is their default behavior. All recurrent neural networks have the form of a chain of repeating modules of neural network connections. In standard RNNs, this repeating module will have a very simple structure such as a single tangent H layer. LSTMs also have a chain-like structure, but the repeating module has a different structure. Instead of having a single neural network layer, there are 4 interacting layers communicating in a very special way. LSTMs are a special kind of recurrent neural network, capable of learning long-term dependencies. Remembering information for long periods of time is their default behavior. LSTMs also have a chain-like structure, but the repeating module has a different structure. Instead of having a single neural network layer, there are 4 interacting layers communicating in a very special way. As you can see, the deeper we dig into this, the more complicated the graphs get. In here, I want you to note that you have x at t minus 1 coming in, you have x at t coming in, and you have x at t plus 1. And you have h at t minus 1, and h at t coming in, and h at t plus 1 going out. And of course, on the other side is the output A. In the middle, we have our tangent H, but it occurs in 2 different places. So not only when we're computing the x at t plus 1 are we getting the tangent H from x at t, but we're also getting that value coming in from the x at t minus 1. So the short of it is that as you look at these layers, not only does the propagate through the first layer, goes into the second layer back into itself, but it's also going into the third layer. So now we're kind of stacking those up. And this can get very complicated as you grow that in size. It also grows in memory too, and in the amount of resources it takes. But it's a very powerful tool to help us address the problem of complicated, long sequential information coming in, like we were just looking at in the sentence. And when we're looking at our long, short-term memory network, there's 3 steps of processing in the LSTMs that we look at. The first one is we want to forget irrelevant parts of the previous state. A lot of times, like, is, as, in, a, unless we're trying to look at whether it's a plural noun or not, they don't really play a huge part in the language, so we want to get rid of them. Then selectively update cell state values. So we only want to update the cell state values that reflect what we're working on. And finally, we want to only output certain parts of the cell state. So whatever's coming out, we want to limit what's going out too. And let's dig a little deeper into this. Let's just see what this really looks like. So step 1 decides how much of the past it should remember. First step in the LSTM is to decide which information to be omitted from the cell in that particular time step. It is decided by the sigmoid function. It looks at the previous state, h at t minus 1, and the current input, x at t, and computes the function. So you can see over here we have a function of t equals the sigmoid function of the weight of f, the h at t minus 1, and then x at t, plus, of course you have a bias in there with any of your neural networks, so we have a bias function. So f at t equals forget gate, decides which information to delete that is not important from the previous time step. Considering an LSTM is fed with the following inputs from the previous and present time step. Alice is good in physics. John, on the other hand, is good in chemistry. So, previous output. John plays football well. He told me yesterday over the phone that he had served as a captain of his college football team. That's our current input. So as we look at this, the first step is the forget gate realizes there might be a change in context after encountering the first full stop. Compares with the current input sentence of x at t. So we're looking at that full stop and then compares it with the input of the new sentence. The next sentence talks about John, so the information on Alice is deleted. Okay, that's important to know. So we have this input coming in, and if we're going to continue on with John, then that's going to be the primary information we're looking at. The position of the subject is vacated and is assigned to John. And so in this one, we've seen that we've weeded out a whole bunch of information, and we're only passing information on John, since that's now the new topic. So step 2 is then to decide how much should this unit add to the current state. In the second layer, there are two parts. One is the sigmoid function, and the other is the tangent h. In the sigmoid function, it decides which values to let through, 0 or 1. Tangent h function gives the weightage to the values which are passed, deciding their level of importance, -1 to 1. And you can see the two formulas that come up. The I of t equals the sigmoid of the weight of I, h of t minus 1, x of t plus the bias of I. And the c of t equals the tangent of h of the weight of c of h of t minus 1 x of t plus the bias of c. So our I of t equals the input gate, determines which information to let through based on its significance in the current time step. If this seems a little complicated, don't worry, because a lot of the programming is already done when we get to the case study. Understanding, though, that this is part of the program is important when you're trying to figure out what to set your settings at. You should also note when you're looking at this, it should have some semblance to your forward propagation neural networks, where we have a value assigned to a weight plus a bias. Very important steps in any of the neural network layers, whether we're propagating into the information from one to the next, or we're just doing a straightforward neural network propagation. Let's take a quick look at this, what it looks like from the human standpoint, as I step out of my suit again. Consider the current input at x of t. John plays football well. He told me yesterday over the phone that he had served as a captain of his college football team. That's our input. Input gate analyzes the important information. John plays football and he was a captain of his college team is important. He told me over the phone yesterday is less important, hence it is forgotten. This process of adding some new information can be done via the input gate. Now this example is as a human form, and we'll look at training this stuff in just a minute. But as a human being, if I wanted to get this information from a conversation, maybe it's a Google Voice listening in on you or something like that, how do we weed out the information that he was talking to me on the phone yesterday? Well, I don't want to memorize that he talked to me on the phone yesterday, or maybe that is important. But in this case, it's not. I want to know that he was the captain of the football team. I want to know that he served. I want to know that John plays football and he was the captain of the college football team. Those are the two things that I want to take away as a human being. Again, we measure a lot of this from the human viewpoint, and that's also how we try to train them so we can understand these neural networks. Finally, we get to step 3, decides what part of the current cell state makes it to the output. The third step is to decide what will be our output. First we run a sigmoid layer, which decides what parts of the cell state make it to the output. Then we put the cell state through the tangent h to push the values to be between -1 and 1, and multiply it by the output of the sigmoid gate. So when we talk about the output of t, we set that equal to the sigmoid of the weight of 0 of the h of t minus 1, back one step in time, by the x of t, plus of course the bias. The h of t equals the out of t times the tangent h of c of t. So our O of t equals the output gate, allows the passed in information to impact the output in the current time step. Let's consider the example to predicting the next word in the sentence. John played tremendously well against the opponent and won for his team. For his contributions, Brave blank was awarded player of the match. There could be a lot of choices for the empty space. Current input, Brave, is an adjective. Adjectives describe a noun. John could be the best output after Brave. Thumbs up for John, awarded player of the match. And if you were to pull just the nouns out of the sentence, team doesn't look right because that's not really the subject we're talking about. Contributions, brave contributions, or brave team, brave player, brave match. So you look at this and you can start to train this neural network, so it starts looking at it and goes, oh no, John is what we're talking about. So brave is an adjective, John's going to be the best output. And we give John a big thumbs up. And then of course we jump into my favorite part, the case study. Use case implementation of LSTM. Let's predict the prices of stocks using the LSTM network based on the stock price data between 2012 and 2016. We're going to try to predict the stock prices of 2017. And this will be a narrow set of data. We're not going to do the whole stock market. It turns out that the New York Stock Exchange generates roughly 3 terabytes of data per day. That's all the different trades up and down of all the different stocks going on. And each individual one second to second or nanosecond to nanosecond. But we're going to limit that to just some very basic fundamental information. So don't think you're going to get rich off this today. But at least you can give a step forward in how to start processing something like stock prices, a very valid use for machine learning in today's markets. use case implementation of LSTM. Let's dive in. We're going to import our libraries, we're going to import the training set, and get the scaling going. Now, if you watch any of our other tutorials, a lot of these pieces just start to look very familiar because it's a very similar setup. But let's take a look at that, and just a reminder, we're going to be using Anaconda, the Jupyter Notebook. So here I have my Anaconda Navigator. When we go under environments, I've actually set up a Keras Python 3.6. I'm in Python 3.6. And nice thing about Anaconda, especially the newer version, I remember a year ago messing with Anaconda in different versions of Python in different environments. Anaconda now has a nice interface. And I have this installed both on a Ubuntu Linux machine and on Windows, so it works fine on there. You can go in here and open a terminal window, and then in here, once you're in the terminal window, this is where you're going to start installing using pip to install your different modules and everything. Now, we've already pre-installed them, so we don't need to do that in here. But if you don't have them installed in your particular environment, you'll need to do that. And of course, you don't need to use the Anaconda or the Jupyter. You can use whatever favorite Python IDE you like. I'm just a big fan of this because it keeps all my stuff separate. You can see on this machine I have specifically installed one for Keras, since we're going to be working with Keras under TensorFlow. When we go back to home, I've gone up here to application, and that's the environment I've loaded on here, and then we'll click on the Launch Jupyter Notebook. Now, I've already, in my Jupyter Notebook, have set up a lot of stuff so that we're ready to go. Kind of like Martha Stewart's in the old cooking shows. We want to make sure we have all our tools for you so you're not waiting for them to load. And if we go up here to where it says New, you can see where you can create a new Python 3. That's what we did here underneath the setup, so it already has all the modules installed on it. And I'm actually renamed this. If you go under File, you can rename it. I'm calling it RNN Stock. And let's just take a look and start diving into the code. Let's get into the exciting part. Now we've looked at the tool, and of course you might be using a different tool, which is fine. Let's start putting that code in there and seeing what those imports and uploading everything looks like. Now, the first half is kind of boring when we hit the Run button, because we're going to be importing NumPy as NP. That's the number Python, which is your NumPy array, and the matplot library, because we're going to do some plotting at the end, and our pandas for our data set. Our pandas is PD. And when I hit Run, it really doesn't do anything except for load those modules. Just a quick note, let me just do a quick draw here. Oops, Shift-Alt, there we go. You'll notice when we're doing this setup, if I was to divide this up, oops, I'm going to actually, let's overlap these, here we go. This first part that we're going to do is our data prep. A lot of prepping involved. In fact, depending on what your system is, since we're using Keras, I put an overlap here, but you'll find that almost maybe even half of the code we do is all about the data prep. And the reason I overlap this with Keras, let me just put that down because that's what we're working in, is because Keras has like their own preset stuff, so it's already pre-built in, which is really nice. So there's a couple steps a lot of times that are in the Keras setup. We'll take a look at that to see what comes up in our code as we go through and look at stock. And then the last part is to evaluate. And if you're working with shareholders or classroom, whatever it is you're working with, the evaluate is the next biggest piece. So the actual code here, Keras is a little bit more, but when you're working with some of the other packages, you might have like 3 lines. That might be it. All your stuff is in your pre-processing and your data. Since Keras is cutting edge and you load the individual layers, you'll see that there's a few more lines here and Keras is a little bit more robust. And then you spend a lot of times, like I said, with the evaluate, you want to have something you present to everybody else and say, hey, this is what I did, this is what it looks like. So let's go through those steps. This is like a kind of just general overview. And let's just take a look and see what the next set of code looks like. And in here we have a dataset train, and it's going to be read using the PD, or pandas.readCSV, and it's the Google stock price train.csv. And so under this we have training set equals dataset train.ilocation, and we've kind of sorted out part of that. So what's going on here? Let's just take a look at it. Let's look at the actual file and see what's going on there. Now if we look at this, ignore all the extra files on this, I already have a train and a test set where it's sorted out. This is important to notice because a lot of times we do that as part of the pre-processing of the data. We take 20% of the data out so we can test it, and then we train the rest of it. That's what we use to create our neural network. That way we can find out how good it is. But let's go ahead and just take a look and see what that looks like as far as the file itself. And I went ahead and just opened this up in a basic WordPad and text editor just so we can take a look at it. Certainly you can open up an Excel or any other kind of spreadsheet. And we note that this is a comma separated variables. We have a date, open, high, low, close, volume. This is the standard stuff that we import into our stock, or the most basic set of information you can look at in stock. It's all free to download. In this case, we downloaded it from Google. That's why we call it the Google stock price. And it specifically is Google. This is the Google stock values from, as you can see here, we started off at 1/3/2012. So when we look at this first setup up here, we have a data set train equals PD_CSV. And if you noticed on the original frame, let me just go back there, they had it set to home Ubuntu downloads Google stock price train. I went ahead and changed that because we're in the same file where I'm running the code. So I've saved this particular Python code, and I don't need to go through any special paths or have the full path on there. And then of course we want to take out certain values in here. And you're going to notice that we're using our data set, and we're now in pandas. So pandas, basically it looks like a spreadsheet. And in this case, we're going to do iLocation, which is going to get specific locations. The first value is going to show us that we're pulling all the rows in the data. And the second one is we're only going to look at columns 1 and 2. And if you remember here from our data, as we switch back on over, columns, we always start with 0, which is the date. And we're going to be looking at open and high, which would be 1 and 2. We'll just label that right there so you can see. Now, when you go back and do this, you certainly can extrapolate and do this on all the columns. But for the example, let's just limit a little bit here so that we can focus on just some key aspects of stock. And then we'll go up here and run the code. And again, I said the first half is very boring. Whenever you hit the run button, it doesn't do anything because we're still just loading the data and setting it up. Now that we've loaded our data, we want to go ahead and scale it. We want to do what they call feature scaling. And in here, we're going to pull it up from the sklearn or the skKit pre-processing import min-max scaler. And when you look at this, you got to remember that biases in our data, we want to get rid of that. So if you have something that's like a really high value, let's just draw a quick graph. And I have something here like maybe the stock has a value, one stock has a value of 100, and another stock has a value of 5. You start to get a bias between different stocks. And so when we do this, we go ahead and say, okay, 100 is going to be the max, and 5 is going to be the min, and then everything else goes, and then we change this, so we just squish it down. I like the word squish. So it's between 1 and 0. So 100 equals 1, or 1 equals 100, and 0 equals 5. And you can just multiply. It's usually just a simple multiplication we're using. Multiplication. So it's going to be minus 5 and then 100 divided, or 95 divided by 1. So, or whatever value is divided by 95. And once we've actually created our scale, we're telling us it's going to be from 0 to 1. We want to take our training set, and we're going to create a training set scaled. And we're going to use our scaler, SC, and we're going to fit. We're going to fit and transform the training set. So we can now use the SC, this particular object, we'll use it later on our testing set. Because remember, we have to also scale that when we go to test our model and see how it works. And we'll go ahead and click on the run. Again, it's not going to have any output yet because we're just setting up all the variables. Okay, so we paste the data in here, and we're going to create the data structure with the 60 time steps and output. First note, we're running 60 time steps, and that is where this value here also comes in. So the first thing we do is we create our xtrain and ytrain variables, and we set them to an empty Python array. Very important to remember what kind of array we're in and what we're working with. And then we're going to come in here, we're going to go for I in range 60 to 1258. There's our 60 time steps. And the reason we want to do this is as we're adding the data in, there's nothing below the 60. So if we're going to use 60 time steps, we have to start at point 60 because it includes everything underneath of it. Otherwise, you'll get a pointer error. And then we're going to take our X train and we're going to append training set scaled. This is a scaled value between 0 and 1. And then as I is equal to 60, this value is going to be 60 minus 60 is 0. So this actually is 0 to I. So it's going to be 0 to 60, 1 to 61. Let me just circle this part right here. 1 to 61, 2 to 62, and so on and so on. And if you remember, I said 0 to 60. That's incorrect because it does not count. Remember, it starts at 0, so this is a count of 60. So it's actually 59. Important to remember that as we're looking at this. And then the second part of this that we're looking at, so if you remember correctly, here we go. We go from 0 to 59 of I, and then we have a comma, a 0 right here. And so finally, we're just going to look at the open value. Now, I know we did put it in there for 1 to 2. If you remember correctly, it doesn't count the second one, so it's just the open value we're looking at, just open. And then finally, we have ytrain.append training set I to 0. And if you remember correctly, I comma 0. If you remember correctly, this is 0 to 59, so there's 60 values in it. So when we do I down here, this is number 60. So we're going to do this is we're creating an array, and we have 0 to 59. And over here we have number 60, which is going into the Y train. It's being appended on there. And then this just goes all the way up. So this is down here is 0 to 59, and we'll call it 60, since that's the value over here. And it goes all the way up to 1258. That's where this value here comes in. That's the length of the data we're loading. So we've loaded 2 arrays. We've loaded one array that has, which is filled with arrays from 0 to 59, and we loaded one array which is just the value. And what we're looking at, you want to think about this as a time sequence. Here's my open. What's the next one in the series? So we're looking at the Google stock, and each time it opens, we want to know what the next one, 0 through 59, what's 60? 1 through 60, what's 61? 2 through 62, what's 62? And so on going up. And then once we've loaded those in our for loop, we go ahead and take xtrain and ytrain equals np.array xtrain.nparray ytrain. We're just converting this back into a numpy array. That way we can use all the cool tools that we get with numpy array, including reshaping. So if we take a look and see what's going on here, we're going to take our xtrain, we're going to reshape it. Wow, what the heck does reshape mean? That means we have an array, if you remember correctly, so many numbers by 60. That's how wide it is. And so when you do xtrain.shape, that gets one of the shapes. And you get xtrain.shape of 1 gets the other shape. And we're just making sure the data is formatted correctly. And so you use this to pull the fact that it's 60 by, in this case, where's that value? 60 by 1199, 1258 minus 60, 1199, and we're making sure that that is shaped correctly. So the data is grouped into 1199 by 60 different arrays. And then the 1 on the end just means at the end, because when you're dealing with shapes and NumPy, they look at this as layers. And so the end layer needs to be 1 value. That's like the leaf of a tree, where this is the branch, and then it branches out some more, and then you get the leaf. np.reshape comes from and using the existing shapes to form it. We'll go ahead and run this piece of code. Again, there's no real output. And then we'll import our different Keras modules that we need. So from Keras models, we're going to import the sequential model. We're dealing with sequential data. We have our dense layers. We have actually 3 layers we're going to bring in. Our dense, our LSTM, which is what we're focusing on, and our dropout. And we'll discuss these 3 layers more in just a moment. But you do need with the LSTM, you do need the dropout, and then the final layer will be the dense. But let's go ahead and run this, and that'll import our modules. And you'll see we get an error on here. And if you read it closer, it's not actually an error, it's a warning. What does this warning mean? These things come up all the time when you're working with such cutting edge modules that are completely being updated all the time. We're not going to worry too much about the warning. All it's saying is that the H5 PY module, which is part of Keras, is going to be updated at some point. And if you're running new stuff on Keras and you start updating your Keras system, you better make sure that your H5Pi is updated too, otherwise you're going to have an error later on. And you can actually just run an update on the H5Pi now if you wanted to. Not a big deal. We're not going to worry about that today. And I said we were going to jump in and start looking at what those layers mean. I meant that. And we're going to start off with initializing the RNN, and then we'll start adding those layers in. And you'll see that we have the LSTM and then the dropout. LSTM, then dropout. LSTM, then dropout. What the heck is that doing? So let's explore that. We'll start by initializing the RNN, regressor equals sequential, because we're using the sequential model, and we'll run that and load that up. And then we're going to start adding our LSTM layer and some dropout regularization. And right there should be the Q, dropout regularization. And if we go back here and remember our exploding gradient, well, that's what we're talking about. The dropout drops out unnecessary data, so we're not just shifting huge amounts of data through the network. So we go in here. Let's just go ahead and add this in. I'll go ahead and run this. And we had 3 of them. So let me go ahead and put all 3 of them in, and then we can go back over them. Here's the second one, and let's put 1 more in. So let's put that in, and we'll go ahead and put 2 more in. I said 1 more in, but it's actually 2 more in. And then let's add 1 more after that. And as you can see, each time I run these, they don't actually have an output. So let's take a closer look and see what's going on here. So we're going to add our first LSTM layer in here. We're going to have units 50. The units is the positive integer, and it's the dimensionality of the output space. This is what's going out into the next layer. So we might have 60 coming in, but we have 50 going out. We have a return sequence, because it is a sequence data, so we want to keep that true. And then you have to tell it what shape it's in. Well, we already know the shape by just going in here and looking at xtrain shape. So input shape equals the xtrain shape of 1, 1. It makes it real easy. You don't have to remember all the numbers that put in 60 or whatever else is in there. You just let it tell the regressor what model to use. And so we follow our STM with a dropout layer. Now, understanding the dropout layer is kind of exciting because one of the things that happens is we can overtrain our network. That means that our neural network will memorize such specific data that it has trouble predicting anything that's not in that specific realm. To fix for that, each time we run through the training mode, we're going to take 0.2 or 20% of our neurons and just turn them off. So we're only going to train on the other ones. And it's going to be random. That way, each time we pass through this, we don't overtrain. These nodes come back in the next training cycle. We randomly pick a different 20. And finally, I see a big difference as we go from the first to the second and third and fourth. The first thing is we don't have to input the shape. Because the shape's already, the output units is 50 here, the next step automatically knows this layer is putting out 50, and because it's the next layer, it automatically sets that and says, oh, 50 is coming out from our last layer. It's coming out, goes into the regressor, and of course we have our dropout. And that's what's coming into this one, and so on, and so on. And so the next 3 layers, we don't have to let it know what the shape is. It automatically understands that. And we're going to keep the units the same. We're still going to do 50 units. It's still a sequence coming through, 50 units and a sequence. Now, the next piece of code is what brings it all together. Let's go ahead and take a look at that. And we come in here, we put the output layer, the dense layer. And if you remember up here, we had the 3 layers. We had LSTM, dropout, and dense. Dense just says we're going to bring this all down into one output. Instead of putting out a sequence, we just want to know the answer at this point. And let's go ahead and run that. And so in here, you notice all we're doing is setting things up, one step at a time. So far, we've brought in our, way up here, we brought in our data, we brought in our different modules, we formatted the data for training it, we set it up, we have our X train and our Y train. We have our source of data and the answers we know so far that we're going to put in there. We've reshaped that. We've come in and built our Keras. We've imported our different layers. And we have in here, if you look, we have 5 total layers. Now, Keras is a little different than a lot of other systems because a lot of other systems put this all in one line and do it automatic, but they don't give you the options of how those layers interface, and they don't give you the options of how the data comes in. Keras is cutting edge for this reason. So even though there's a lot of extra steps in building the model, this has a huge impact on the output and what we can do with these new models from Keras. So we brought in our dense, we have our full model put together, our regressor. So we need to go ahead and compile compile it, and then we're going to go ahead and fit the data. We're going to compile the pieces so they all come together, and then we're going to run our training data on there and actually recreate our regressor so it's ready to be used. So let's go ahead and compile that, and I can go ahead and run that. And if you've been looking at any of our other tutorials on neural networks, you'll see we're going to use the optimizer Atom. Atom is optimized for big data. There's a couple other optimizers out there beyond the scope of this tutorial, but certainly Atom will work pretty good for this. And loss equals mean squared value. So when we're training it, this is what we want to base the loss on. How bad is our error? Well, we're going to use the mean squared value for our error and the Atom optimizer for its differential equations. You don't have to know the math behind them, but certainly it helps to know what they're doing and where they fit into the bigger models. And then finally we're going to do our fit, fitting the RN into the training set. We have the regressor.fit, xtrain, ytrain, epochs, and batch size. So we know where this is. This is our data coming in. For the xtrain, our ytrain is the answer we're looking for of our data, our sequential input. Epochs is how many times we're going to go over the whole data set. We created a whole data set of xtrain. So this is each of those rows, which includes a time sequence of 60. And batch size, another one of those things where Keras really shines, is if you were pulling this, say, from a large file, instead of trying to load it all into RAM, it can now pick smaller batches up and load those indirectly. We're not worried about pulling them off a file today because this isn't big enough to cause the computer too much of a problem to run, not too straining on the resources. But as we run this, you can imagine what would happen if I was doing a lot more than just one column in one set of stock, in this case Google stock. Imagine if I was doing this across all the stocks and I had, instead of just the open, I had open, close, high, low, and you can actually find yourself with about 13 different variables times 60 because it's a time sequence. Suddenly you find yourself with a gig of memory you're loading into your RAM, which will just completely, if you're not on multiple computers or cluster, you're going to start running into resource problems. But for this, we don't have to worry about that. So let's go ahead and run this, and this will actually take a little bit on my computer because it's an older laptop. And give it a second to kick in there. There we go. All right, so we have epoch. So this is going to tell me it's running the first run through all the data. And as it's going through, it's batching them in 32 pieces. So 32 lines each time. And there's 1198. I think I said 1199 earlier, but it's 1198. I was off by one. And each one of these is 13 seconds. So you can imagine this is roughly 20 to 30 minutes runtime on this computer. Like I said, it's an older laptop running at 0.9 gigahertz on a dual processor. And that's fine. What we'll do is I'll go ahead and stop, go get a drink of coffee, and come back, and let's see what happens at the end and where this takes us. And like any good cooking show, I've gotten my latte. I also had some other stuff running in the background, so you'll see these numbers jumped up to like 19 seconds, 15 seconds. But you can scroll through, and you can see we've run it through 100 steps, or 100 epochs. So the question is, what does all this mean? One of the first things you'll notice is that our loss is over here. It kind of stopped at 0.0014, but you can see it kind of goes down until we hit about 0.014 3 times in a row. So we guessed our epoch pretty close since our loss has remained the same on there. So to find out what we're looking at, we're going to go ahead and load up our test data, the test data that we didn't process yet. And a real stock price, dataset test allocation. This is the same thing we did when we prepped the data in the first place. So let's go ahead and go through this code. And we can see we've labeled it Part 3, Making the Predictions and Visualizing the Results. So the first thing we need to do is go ahead and read the data in from our test CSV. And you see I've changed the path on it for my computer. And then we'll call it the real stock price. And again, we're doing just the one column here and the values from iLocation. So it's all the rows and just the values from that one location. That's the open. Stock open. Let's go ahead and run that. So that's loaded in there. And then let's go ahead and we have our inputs. We're going to create inputs here. And this should all look familiar because this is the same thing we did before. We're going to take our data set total. We're going to do a little pandas concat from the data set train. Now remember, the end of the data set train is part of the data going in. And let's just visualize that just a little bit. Here's our train data. Let me just put TR for train. And it went up to this value here. But each one of these values generated a bunch of columns. So it was 60 across, and this value here equals this one, and this value here equals this one, and this value here equals this one. And so we need these top 60 to go into our new data. So to find out what we're looking at, we're going to go ahead and load up our test data, the test data that we didn't process yet. And real stock price, data set, test allocation. This is the same thing we did when we prepped the data in the first place. So let's go ahead and go through this code. And we can see we've labeled it Part 3, Making the Predictions and Visualizing the Results. So the first thing we need to do is go ahead and read the data in from our test CSV. And you see I've changed the path on it for my computer. And then we'll call it the real stock price. And again, we're doing just the one column here and the values from iLocation. So it's all the rows and just the values from that one location. That's the open. Stock open. Let's go ahead and run that. So that's loaded in there. And then let's go ahead and we have our inputs. We're going to create inputs here. And this should all look familiar because this is the same thing we did before. We're going to take our data set total. We're going to do a little pandas concat from the data set train. Now remember, the end of the data set train is part of the data going in. And let's just visualize that just a little bit. Here's our train data. Let me just put TR for train. And it went up to this value here. But each one of these values generated a bunch of columns. So it was 60 across, and this value here equals this one, and this value here equals this one, and this value here equals this one. And so we need these top 60 to go into our new data, because that's part of the next data, or it's actually the top 59. So that's what this first setup is over here, is where we're going in, we're doing the real stock price, and we're going to just take the data set test, and we're going to load that in, and then the real stock price is our data test location. So we're just looking at that first column, the open price. And then our data set total, we're going to take pandas and we're going to concat, and we're going to take our data set train for the open and our data set test open. And this is one way you can reference these columns. We've referenced them a couple different ways. We've referenced them up here with the 1, 2, but we know it's labeled as a panda set as open. So pandas is great that way. Lots of versatility there. And we'll go ahead and go back up here and run this. There we go. And you'll notice this is the same as what we did before. We have our open data set. We appended our concatenated our two data sets together. We have our inputs equals data set total length, data set total minus length of data set minus test minus 60 values. So we're going to run this over all of them. And you'll see why this works, because normally when you're running your test set versus your training set, you run them completely separate. But when we graph this, you'll see that we'll be looking at the part that we didn't train it with to see how well it graphs. And we have our inputs equals inputs dot reshapes, or reshaping like we did before. We're transforming our inputs. So if you remember from the transform between 0 and 1. And finally, we want to go ahead and take our X test, and we're going to create that X test, and for I in range 60 to 80. So here's our X test, and we're appending our inputs I to 60, which remember is 0 to 59, and I comma 0 on the other side. So it's just the first column, which is our open column. And once again, we take our X test, we convert it to a NumPy array. We do the same reshape we did before, and then we get down to the final two lines, and here we have something new. Right here on these last two lines, let me just highlight those or mark them. Predicted stock price equals regressor.predicts X test. So we're predicting all the stock, including both the training and the testing model here. And then we want to take this prediction and we want to inverse the transform. So remember, we put them between 0 and 1. Well, that's not going to mean very much to me to look at a float number between 0 and 1. I want the dollar amounts. I want to know what the cash value is. And we'll go ahead and run this, and you'll see it runs much quicker than the training. That's what's so wonderful about these neural networks. Once you put them together, it takes just a second to run the same neural network that took us, what, a half hour to train? Head and plot the data. We're going to plot what we think it's going to be, and we're going to plot it against the real data, what the Google stock actually did. So let's go ahead and take a look at that in code. And let's pull this code up. So we have our PLT. That's our, if you remember from the very beginning, let me just go back up to the top. We have our matplotlibary.pyplot as PLT. That's where that comes in. And we come down here, we're going to plot, and let me get my drawing thing out again. We're going to go ahead, and PLT is basically kind of like an object. It's one of the things that always threw me when I'm doing graphs in Python, because I always think you have to create an object, and then it loads that class in there. Well, in this case, PLT is like a canvas you're putting stuff on. So if you've done HTML5, you'll have the canvas object. This is the canvas. So we're going to plot the real stock price. That's what it actually is. And we're going to give that color red. So it's going to be in bright red, and we're going to label it real Google stock price. And then we're going to do our predicted stock, and we're going to do it in blue, and it's going to be labeled predicted. And we'll give it a title, because it's always nice to give a title to your graph, especially if you're going to present this to somebody, to your shareholders in the office. And the X label is going to be time, because it's a time series. And we didn't actually put the actual date and times on here, but that's fine. We just know they're incremented by time. And then, of course, the Y label is the actual stock price. PLT.legend tells us to build the legend on here so that the color red and real Google stock price show up on there. And then the plot shows us that actual graph. So let's go ahead and run this and see what that looks like. And you can see here we have a nice graph, and let's talk just a little bit about this graph before we wrap it up. Here's our legend I was telling you about. That's why we have the legend to show the prices. We have our title and everything. And you'll notice on the bottom we have a time sequence. We didn't put the actual time in here. Now we could have. We could have gone ahead and plotted the X, since we know what the dates are, and plotted this to dates. But we also know that it's only the last piece of data that we're looking at. So last piece of data, which ends somewhere probably around here on the graph, I think it's like about 20% of the data, probably less than that. We have the Google price, and the Google price has this little up jump and then down, and you'll see that the actual Google, instead of a turn down here, just didn't go up as high and didn't go down. So our prediction has the same pattern, but the overall value is pretty far off as far as stock. But then again, we're only looking at one column. We're only looking at the open price. We're not looking at how many volumes were traded. And like I was pointing out earlier, we talk about stock. Just right off the bat, there's 6 columns. There's open, high, low, close, volume. Then there's volume shares. Then there's the adjusted open, adjusted high, adjusted low, adjusted close. They have a special formula to predict exactly what it would really be worth based on the value of the stock. And then from there's all kinds of other stuff you can put in here. So we're only looking at one small aspect, the opening price of the stock. And as you can see here, we did a pretty good job. This curve follows the curve pretty well. It has like little jumps on it, bends. They don't quite match up. So this bend here does not quite match up with that bend there, but it's pretty darn close. We have the basic shape of it, and the prediction isn't too far off. And you can imagine that as we add more data in and look at different aspects in the specific domain of stock, we should be able to get a better representation each time we drill in deeper. Of course, this took a half hour for my computer to train, so you can imagine that if I was running it across all those different variables, it might take a little bit longer to train the data. Not so good for doing a quick tutorial like this. So we're going to dive right into what is Keras. We'll also go all the way through this into a couple of tutorials, because that's where you really learn a lot, is when you roll up your sleeves. So when we talk about what is Keras, Keras is a high-level deep learning API written in Python for easy implementation of neural networks. It uses deep learning frameworks such as TensorFlow, PyTorch, etc. as backend to make computation faster. And this is really nice because as a programmer, there is so much stuff out there and it's evolving so fast, it can get confusing. And having some kind of high-level order in there where you can actually view it and easily program these different neural networks is really powerful. It's really powerful to have something out really quick and also be able to start testing your models and seeing where you're going. So Keras works by using complex deep learning frameworks such as TensorFlow, PyTorch, MLPlaid, etc. as a backend for fast computation, while providing a user-friendly and easy-to-learn front-end. And you can see here we have the Keras API specifications, and under that you'd have like TF Keras for TensorFlow, Thano Keras, and so on. And then you have your TensorFlow workflow that this is all sitting on top of. And this is, like I said, it organizes everything. The heavy lifting is still done by TensorFlow or whatever underlying package you put in there. And this is really nice because you don't have to dig as deeply into the heavy end stuff while still having a very robust package you can get up and running rather quickly. And it doesn't distract from the processing time because all the heavy lifting is done by packages like TensorFlow. This is the organization on top of it. So the working principle of Keras. The working principle of Keras is Keras uses computational graphs to express and evaluate mathematical expressions. And you can see here we put them in blue. They have the expression expressing complex problems as a combination of simple mathematical operators. where we have like the percentage, or in this case in Python, that's usually your remainder or multiplication. You might have the operator of x to the power of 0.3. And it is useful for calculating derivatives by using back propagation. So if we're doing with neural networks, when we send the error back up to figure out how to change it, this makes it really easy to do that without really not banging your head and having to hand write everything. It's easier to implement distributed computation, and for solving complex problems, specify input and outputs and make sure all nodes are connected. And so this is really nice as you come in through, is that as your layers are going in there, you can get some very complicated different setups nowadays, which we'll look at in just a second. And this just makes it really easy to start spinning this stuff up and trying out the different models. So when we look at cross models, cross model, we have a sequential model. Sequential model is a linear stack of layers where the previous layer leads into the next layer. And this, if you've done anything else, even like the sklearn with their neural networks and propagation and any of these setups, this should look familiar. You should have your input layer, it goes into your layer 1, layer 2, and then to the output layer. And it's useful for simple classifier or decoder models. And you can see down here we have the model equals a cross sequential, and this is the actual code. You can see how easy it is. We have a layer that's dense, your layer 1. As an activation, they're using the ReLU in this particular example. And then you have your name layer 1, layer dense ReLU, name layer 2, and so forth. And they just feed right into each other, so it's really easy just to stack them, as you can see here, and it automatically takes care of everything else for you. And then there's a functional model. And this is really where things are at. This is new. Make sure you update your Keras, or you'll find yourself running this doing the functional model. You'll run into an error code because this is a fairly new release. And it uses multi-input and multi-output model. The complex model, which forks into 2 or more branches. And you can see here we have our image inputs equals your Keras input shape equals 32 by 32 by 3. You have your dense layers, dense 64 activation ReLU. This should look similar to what you already saw before, but if you look at the graph on the right, it's going to be a lot easier to see what's going on. You have 2 different inputs. And one way you could think of this is maybe one of those is a small image and one of those is a full-sized image. And that feedback goes into, you might feed both of them into one node because it's looking for one thing, and then only into one node for the other one. And so you can start to get kind of an idea that there's a lot of use for this kind of split and this kind of setup. We have multiple information coming in, but the information's very different even though it overlaps. And you don't want it to send it through the same neural network. And they're finding that this trains faster and also has a better result depending on how you split the data up and how you fork the models coming down. And so in here we do have the 2 complex models coming in. We have our image inputs, which is a 32 by 32 by 3, or 3 channels, or 4 if you're having an alpha channel. You have your dense, your layers, dense is 64 activation using the ReLU, very common. X equals dense inputs, X layers dense X64 activation equals ReLU, X outputs equals layers dense 10X, model equals Keras, model inputs equals inputs, outputs equals outputs, name equals minced model. So we add a little name on there. And again, this is this kind of split here. This is setting us up to have the input go into different areas. So if you're already looking at Keras, you probably already have this answer. What are neural networks? But it's always good to get on the same page, and for those people who don't fully understand neural networks, to dive into them a little bit or do a quick overview. Neural networks are deep learning algorithms modeled after the human brain. They use multiple neurons, which are mathematical operations, to break down and solve complex mathematical problems. And so just like the neuron, one neuron fires in and it fires out to all these other neurons, or nodes as we call them, and eventually they all come down to your output layer. And you can see here we have the really standard graph: input layer, a hidden layer, and an output layer. One of the biggest parts of any data processing is your data pre-processing. So we always have to touch base on that. With a neural network, like many of these models, they're kind of, when you first start using them, they're like a black box. You put your data in, You train it and you test it and see how good it was. And you have to pre-process that data because bad data in is bad outputs. So in data pre-processing, we will create our own data examples set with Keras. The data consists of a clinical trial conducted on 2,100 patients, ranging from ages 13 to 100, with the patients under 65 and the other half over 65 years of age. We want to find the possibility of a patient experiencing side effects due to their age. And you can think of this in today's world with COVID, what's going to happen on there. And we're going to go ahead and do an example of that in our live hands-on. Like I said, most of this you really need to have hands-on to understand. So let's go ahead and bring up our Anaconda and open that up and open up a Jupyter Notebook for doing the Python code in. Now, if you're not familiar with those, you can use pretty much any of your setups. I just like those for doing demos and showing people, especially shareholders. It really helps because it's a nice visual. So let me go ahead and flip over to our Anaconda. And the Anaconda has a lot of cool tools. They just added Datalore and IBM Watson Studio Cloud into the Anaconda framework. But we'll be in the Jupyter Lab or Jupyter Notebook. I'm going to do Jupyter Notebook for this because I use the lab for like large projects with multiple pieces because it has multiple tabs. Where the notebook will work fine for what we're doing. And this opens up in our browser window because that's how Jupyter Notebook is set to run. And we'll go under New, create a new Python 3, and it creates an untitled Python. We'll go ahead and give this a title, and we'll just call this Keras tutorial. And let's change that to capital. There we go. We'll go ahead and just rename that. And the first thing we want to go ahead and do is get some pre-processing tools involved. And so we need to go ahead and import some stuff for that, like our NumPy, do some random number generation. I mentioned sklearn or your scikit. If you're installing sklearn, the sklearn stuff, it's scikit you want to look up. That should be a tool of anybody who is doing data science. If you're not familiar with the sklearn toolkit, it's huge, but there's so many things in there that we always go back to. And we want to go ahead and create some train labels and train samples for training our data. And then just a note of what we're actually doing in here. Let me go ahead and change this. This is kind of a fun thing you can do. We can change the code to Markdown. And then Markdown code is nice for doing examples once you've already built this. Our example data, we're going to do experimental. There we go. Experimental drug was tested on 2,100 individuals between 13 to 100 years of age. Half the participants are under 65, and 95% of participants are under 65. Experienced no side effects, while 95% of participants over 65 experienced side effects. So that's kind of where we're starting at. And this is just a real quick example, because we're going to do another one with a little bit more complicated information. And so we want to go ahead and generate our setup. So we want to do for I and range, and we want to go ahead and create, if you look here, we have random integers, train the labels, append. So we're just creating some random data. And let me go ahead and just run that. And so once we've created our random data, and you can certainly ask for a copy of the code from Simplilearn. They'll send you a copy of this, or you can zoom in on the video and see how we went ahead and did our train samples append. And we're just using this. I do this kind of stuff all the time. I was running a thing on that had to do with errors following a bell-shaped curve on a standard distribution error. And so what do? I generate the data on a standard distribution error to see what it looks like and how my code processes it, since that was the baseline I was looking for. In this, we're just doing generating random data for our setup on here. And we could actually go in, print some of the data up. Let's just do this, print. We'll do train samples, and we'll just do the first 5 pieces of data in there to see what that looks like. And you can see the first 5 pieces of data in our trained samples is 49, 85, 41, 68, 19. Just random numbers generated in there. That's all that is. And we generated significantly more than that. Let's see, 50 up here, 1,000. Yeah, so there's 1,000 here. 1,000 numbers we generated. And we could also, if we wanted to find that out, we could do a quick print the length of it. And so, or you could do a shape kind of thing, and if you're using NumPy, although the link for this is just fine. And there we go, it's actually 2100, like we said in the demo setup in there. And then we want to go ahead and take our labels. Oh, that was our train labels. We also did samples, didn't we? So we could also print, do the same thing. Oh, labels. And let's change this to labels. And labels. And run that just to double check, and sure enough we have 2100 and they're labeled 10, 10, 10. I guess that's if they have symptoms or not. 1 symptoms, 0 none. And so we want to go ahead and take our train labels and we'll convert it into a NumPy array, and the same thing with our samples. And let's go ahead and run that. And we also shuffle. This is just a neat feature you can do in NumPy right here. Put my drawing thing on, which I didn't have on earlier. I can take the data and I can shuffle it. So we have our, so it just randomizes it. That's all that's doing. We've already randomized it, so it's kind of an overkill. It's not really necessary. But if you're doing a larger package where the data is coming in, and a lot of times it's organized somehow, and you want to randomize it just to make sure that you know, the input doesn't follow a certain pattern that might create a bias in your model. And we go ahead and create a scalar. The scalar range, minimum max scalar, feature range 0 to 1. And then we go ahead and scale the scaled trained samples. So we're going to go ahead and fit and transform the data so it's nice and scaled. And that is the age. So you can see up here we have 49, 85, 41. We're just moving that so it's going to be between 0 and 1. And so this is true with any of your neural networks. You really want to convert the data to 0 and 1, otherwise you create a bias. So if you have like 100 creates a bias versus the math behind it gets really complicated. If you actually start multiplying stuff, because there's a lot of multiplication and addition going on in there, that higher end value will eventually multiply down, and it will have a huge bias as to how the model fits it, and then it will not fit as well. And then one of the fun things we can do in Jupyter Notebook is that if you have a variable and you're not doing anything with it, and it's the last one on the line, it will automatically print. And we're just going to look at the first 5 samples on here. And so it's going to print the first 5 samples. And you can see, here we go, 0.9195, 0.791. So everything's between 0 and 1. And that just shows us that we scaled it properly and it looks good. It really helps a lot to do these kind of print-ups halfway through. You never know what's going to go on there. I don't know how many times I've gotten down and found out that the data sent to me that I thought was scaled was not. And then I have to go back and track it down and figure it out on there. So let's go ahead and create our artificial neural network. And for doing that, this is where we start diving into TensorFlow and Keras. TensorFlow, if you don't know the history of TensorFlow, it helps to jump into, we'll just use Wikipedia. Be careful, don't quote Wikipedia on these things because you get in trouble. But it's a good place to start. Back in 2011, Google Brain built Disbelief as a proprietary machine learning setup. TensorFlow became the open source for it. So TensorFlow was a Google product, and then it became open sourced, and now it's just become probably one of the de factos when it comes for neural networks as far as where we're at. So when you see the TensorFlow setup, it's got like a huge following. There are some other setups like the scikit under the sklearn has their own little neural network, but the TensorFlow is the most robust one out there right now. And Keras sitting on top of it makes it a very powerful tool, so we can leverage both the Keras easiness in which we can build a sequential setup on top of TensorFlow. And so in here we're going to go ahead and do our input of TensorFlow, and then we have the rest of this is all Keras here from number 2 down. We're going to import from TensorFlow the Keras connection, and then you have your TensorFlow Keras models, import sequential. It's a specific kind of model. We'll look at that in just a second. If you remember from the files, that means it goes from one layer to the next layer to the next layer. There's no funky splits or anything like that. And then we have from TensorFlow Keras layers, we're going to import our activation and our dense layer. And we have our optimizer Atom. This is a big thing to be aware of, how you optimize your data. When you first do it, Atom's as good as any. Atom is usually, there's a number of optimizer out there. There's a couple of main ones, but Atom is usually assigned to bigger data. It works fine. Usually the lower data does it just fine, but Atom is probably the mostly used. But there are some more out there, and depending on what you're doing with your layers, your different layers might have different activations on them. And then finally down here you'll see our setup where we want to go ahead and use the metrics. And we're going to use the TensorFlow Keras metrics for categorical cross entropy. So we can see how everything performs when we're done. That's all that is. A lot of times you'll see us go back and forth between TensorFlow, and then scikit has a lot of really good metrics also for measuring these things. Again, it's the end of the at the end of the story, how good does your model do? And we'll go ahead and load all that. And then comes the fun part. I actually like to spend hours messing with these things. And 4 lines of code. You're like, you're going to spend hours on 4 lines of code? No, we don't spend hours on 4 lines of code. That's not what we're talking about when I say spend hours on 4 lines of code. What we have here, and I'm going to explain that in just a second, we have a model. And it's a sequential model. If you remember correctly, we mentioned the sequential up here where it goes from one layer to the next. And our first layer is going to be our input. It's going to be what they call dense, which is usually it's just dense, and then you have your input and your activation. How many units are coming in? We have 16. What's the shape? What's the activation? And this is where it gets interesting, because we have in here ReLU on 2 of these and softmax activation on 1 of these. There are so many different options for what these mean and how they function. How does the ReLU, how does the softmax function? And they do a lot of different things. We're not going to go into the activations in here. That is what really you spend hours doing, is looking at these different activations. And just some of it is just almost like you're playing with it like an artist. You start getting a feel for like a inverse tangent activation, or the tan-H activation takes up a huge processing amount. So you don't see it a lot. Yet it comes up with a better solution, especially when you're doing when you're analyzing Word documents and you're tokenizing the words. And so you'll see this shift from one to the other because you're both trying to build a better model. And if you're working on a huge data set, it'll crash the system. It'll just take too long to process. And then you see things like softmax. Softmax generates an interesting setup where a lot of these, when you talk about ReLU, oops, let me do this. ReLU, there we go. ReLU has a setup where if it's less than 0, it's 0, and then it goes up. And then you might have what they call lazy setup, where it has a slight negative to it so that the errors can translate better. Same thing with softmax. It has a slight laziness to it so that errors translate better. All these little details make a huge difference on your model. So one of the really cool things about data science that I like is you build your what they call you build to fail. And it's an interesting design setup. Oops, I forgot the end of my code here. The concept of build to fail is you want the model as a whole to work, so you can test your model out. So that you can do, you can get to the end and you can do your, let's see, where was it? Overshot down here. You can test out the quality of your setup on there. And see, where did I do my TensorFlow? Oh, here we go. It was right above me. There we go. We start doing your cross entropy and stuff like that. Is you need a full functional set of code so that when you run it, you can then test your model out and say, hey, it's either this model works better than this model and this is why. And then you can start swapping in these models. And so when I say I spend a huge amount of time on pre-processing data, it's probably 80% of your programming time. Well, between those two, it's like 80-20. You'll spend a lot of time on the models. Once you get the model down, once you get the whole code and the flow down set, depending on your data, your models get more and more robust as you start experimenting with different inputs, different data streams, and all kinds of things. And we can do a simple model summary here. Here's our sequential, here's our layer, our output, our parameter. This is one of the nice things about Keras is you can see right here, here's our sequential one model. Boom, 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 boom. Everything's set and clear and easy to read. So once we have our model built, the next thing we're going to want to do is we're going to go ahead and train that model. And so the next step is, of course, model training. And when we come in here, this a lot of times is just paired with the model because it's so straightforward. It's nice to print out the model setup so you can have a tracking. But here's our model. The keyword in Keras is compile, optimizer atom, learning rate, another term right there that we're just skipping right over that really becomes the meat of the setup is your learning rate. So whoops, I forgot that I had an arrow, but I'll just underline it. A lot of times the learning rate set to 0.01. Depending on what you're doing, this learning rate can overfit and underfit. So you'd want to look up, I know we have a number of tutorials out on overfitting and underfitting that are really worth reading once you get to that point and understanding. And we have our loss, sparse categorical cross entropy. So this is going to tell Keras how far to go until it stops. And then we're looking for metrics of accuracy. So we'll go ahead and run that. And now that we've compiled our model, we want to go ahead and run it, fit it. So here's our model fit. We have our scale to train samples, our train labels, our validation split. In this case, we're going to use 10% of the data for validation. Batch size, another number you kind of play with. Not a huge difference as far as how it works, but it does affect how long it takes to run, and it can also affect the bias a little bit. Most of the time, though, a batch size is between 10 to 100, depending on just how much data you're processing in there. We want to go ahead and shuffle it. We're going to go through 30 epochs and put a verbose of 2. Let me just go ahead and run this. And you can see right here, here's our epoch, here's our training, here's our loss. Now, if you remember correctly up here, we set the loss. Let's see, where was it? Compiled our data. There we go, loss. So it's looking at the sparse categorical cross entropy. This tells us that as it goes, how much does the error go down? Is the best way to look at that. And you can see here, the lower the number, the better. It just keeps going down. And vice versa, accuracy we want. Let's see, where's my accuracy? Value accuracy at the end. And you can see 0.619, 0.69, 0.74, it's going up. We want the accuracy, would be ideal if it made it all the way to 1. But we also, the loss is more important because it's a balance. You can have 100% accuracy and your model doesn't work because it's overfitted. Again, you want to look up overfitting and underfitting models. And we went ahead and went through 30 epochs. It's always fun to kind of watch your code going. To be honest, I usually the first time I run it, I'm like, oh, that's cool, I get to see what it does. And after the second time of running it, I'm like, I like to just not see that. And you can repress those, of course, in your code. Repress the warnings in the printing. And so the next step is going to be building a test set and predicting it now. So here we go. We want to go ahead and build our test set. And we have, just like we did our training set, a lot of times you just split your initial set up. But we'll go ahead and do a separate set on here. And this is just what we did above. There's no difference as far as the randomness that we're using to build this set on here. The only difference is that we already did our scalar up here. Well, that doesn't matter because the data is going to be across the same thing. But this should just be transform down here instead of fit transform. Because you don't want to refit your data on your testing data. There we go. And now we're just transforming it because you never want to transform the test data. Easy mistake to make, especially on an example like this where we're not doing, we're randomizing the data anyway, so it doesn't matter too much because we're not expecting something weird. And then we want to go ahead and do our predictions. The whole reason we built the model is we take our model, we predict, and we're going to do, here's our X-scale data, batch size 10, verbose, and now we have our predictions in here, and we could go ahead and do a, we'll print predictions, and then I guess I could just put down predictions in 5 so we can look at the first 5 of the predictions. And what we have here is we have our age and the prediction on this age versus what we think it's going to be, what we think is going to they're going to have symptoms or not. And the first thing we notice is that's hard to read because we really want a yes/no answer. So we'll go ahead and just round off the predictions using the argmax, the NumPy argmax for predictions. So it just goes to a 0, 1, and if you remember, this is a Jupyter Notebook, so I don't have to put the print. I can just put in rounded predictions, and we'll just do the first 5. And you can see here 0, 1, 0, 0, 0. So that's what the predictions are that we have coming out of this. Is no symptoms, symptoms, no symptoms, symptoms, no symptoms. And just as we were talking about at the beginning, we want to go ahead and take a look at this. There we go. Confusion matrices for accuracy check. Most important part when you get down to the end of the story, how accurate is your model before you go and play with the model and see if you can get a better accuracy out of it. And for this, we'll go ahead and use the scikit, the sklearn metrics, scikit being where that comes from. Import confusion matrix, some iteration tools, and of course a nice matplot library. That makes a big difference, so it's always nice to have a nice graph to look at. Picture's worth 1,000 words. And then we'll go ahead and call it CM for confusion matrix, y true equals test labels, y predict rounded predictions. And we'll go ahead and load in our CM. And I'm not going to spend too much time on the plotting, going over the different plotting code. You can spend we have whole tutorials on how to do your different plotting on there. But we do have here is we're going to do a plot confusion matrix. There's our CM, our classes, normalized false, title, confusion matrix. CMAP is going to be in blues. And you can see here we have to the nearest CMAP, titles, all the different pieces, whether you put tick marks or not, the marks, the classes, the color bar. So a lot of different information on here as far as how we're doing the printing of the confusion matrix. You can also just dump the confusion matrix into a Seaborn and real quick get an output. It's worth knowing how to do all this when you're doing a presentation to the shareholders. You don't want to do this on the fly. You want to take the time to make it look really nice, like our guys in the back did. And let's go ahead and do this. Forgot to put together our CM plot labels. We'll go ahead and run that. And then we'll go ahead and call the definition for our mapping. And you can see here, plot confusion matrix. That's the little script we just wrote. And we're going to dump our data into it. So our confusion matrix, our classes, title confusion matrix. And let's just go ahead and run that. And you can see here we have our basic setup. No side effects, 195. Had side effects, 200. No side effects that had side effects. So we predicted the 10 of them who actually had side effects. And that's pretty good. I mean, I don't know about you, but you know, that's 5% error on this. And this is because there's 200 here. That's where I get 5% is. Divide these both by 2 and you get 5 out of 100. You can do the same kind of math up here. Not as quick on the fly because it's 15 and 195. Not an easily rounded number. But you can see here where they have 15 people who predicted to have with the no side effects but had side effects kind of set up on there. And these confusion matrix are so important at the end of the day. This is really where you show whatever you're working on comes up, and you can actually show them, hey, this is how good we are or not, how messed up it is. So this was I spent a lot of time on some of the parts, but you can see here is really simple. We did the random generation of data, but when we actually built the model coming up here, here's our model summary, and we just have the layers on here that we built with our model on this, and then we went ahead and trained it and ran the prediction. Now we can get a lot more complicated. Let me flip back on over here because we're going to do another demo. So that was our basic introduction to it. We talked about the oops, here we go. Okay, so implementing a neural network with Keras. After creating our samples and labels, we need to create our Keras neural network model. We will be working with a sequential model which has 3 layers. And this is what we did. We had our input layer, our hidden layers, and our output layers. And you can see the input layer coming in was the age factor. We had our hidden layer, and then we had the output. Are you going to have symptoms or not? So we're going to go ahead and go with something a little bit more complicated. Training our model is a 2-step process. We first compile our model and then we train it in our training data set. So we have compiling. Compiling converts the code into a form of understandable by machine. We used the Atom in the last example, a gradient descent algorithm, to optimize the model, and then we trained our model, which means it let it learn on training data. And I actually had it a little backwards there, but this is what we just did. Is if you remember from our code we just had, oops, let me go back here. Here's our model that we created, summarized. We come down here and we compile it. So it tells it, hey, we're ready to build this model and use it. And then we train it. And this is the part where we go ahead and fit our model and put that information in here, and it goes through the training on there. And of course we scaled the data, which was really important to do. And then you saw we did the creating a confusion matrix with Keras. As we are performing classifications on our data, we need a confusion matrix to check the results. A confusion matrix breaks down the various misclassifications as well as correct classifications to get the accuracy. And so you can see here, this is what we did with the true positive, true negative, false negative. And that is what we went over. Let me just scroll down here. On the end, we printed it out, and you can see we have a nice printout of our confusion matrix with the true positive, false negative, true negative. And so the blue ones, we want those to be the biggest numbers because those are the better side. And then we have our false predictions on here as far as this one. So it had no side effects, but we predicted, let's see, no side effects predicting side effects and vice versa.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now, saving and loading models with Keras. We're going to dive into a more complicated demo. And you're going to say, oh, well, that was a lot of complication before. Well, if you broke it down, we randomized some data, we created the Keras setup, we compiled it, we trained it, we predicted, and we ran our matrix. So we're going to dive into something a little bit more fun. Is we're going to do a face mask detection with Keras. So we're going to build a Keras model to check if a person is wearing a mask or not in real time. And this might be important if you're at the front of a store. This is something today which is might be very useful as far as some of our, making sure people are safe. And so we're going to look at mask and no mask. And let's start with a little bit on the data. And so in my data I have with a mask. You can see they just have a number of images showing the people in masks. And again, if you want some of this information, contact Simplilearn, and they can send you some of the information as far as people with and without masks, so you can try it on your own. And this is just such a wonderful example of this setup on here. So before I dive into the mask detection, talking about being in the current with COVID and seeing if people are wearing masks, this particular example I had to go ahead and update to a Python 3.8 version. It might run in a 3.7, I'm not sure. I kind of skipped 3.7 and installed 3.8. So I'll be running in a Python 3.8, and then you also want to make sure your TensorFlow is up to date, because the they call functional layers, that's where they split, if you remember correctly from back. Let's take a look at this. Remember from here, the functional model and a functional layer allows us to feed in the different layers into different nodes into different layers and split them. Very powerful tool, very popular right now in the edge of where things are with neural networks and creating a better model. So I've upgraded to Python 3.8, and let's go ahead and open that up and go through our next example, which includes multiple layers, programming it to recognize whether someone wears a mask or not, and then saving that model so we can use it in real time. So we're actually almost a full end-to-end development of a product here. Of course, this is a very simplified version, and there'd be a lot more to it. You'd also have to do like recognizing whether it's someone's face or not. All kinds of other things go into this. So let's go ahead and jump into that code, and we'll open up a new Python 3. Oops, Python 3. It's working on it. There we go. And then we want to go ahead and train our mask. We'll just call this train mask. And we want to go ahead and train mask and save it. So it's save mask, train mask detection, not to be confused with masking data. A little bit different. We're actually talking about a physical mask on your face. And then from the Keras standpoint, we got a lot of imports to do here. And I'm not going to dig too deep on the imports. We're just going to go ahead and notice a few of them. So we have in here, oops, let me go Alt-D, there we go. Have something to draw with a little bit here. We have our image processing, and the image processing right here, let me underline that, deals with how do we bring images in, because most images are like a square grid, and then each value in there has 3 values for the 3 different colors. Keras and TensorFlow do a really good job of working with that, so you don't have to do all the heavy listening and figuring out what's going to go on. We have the mobile net average pooling 2D. This again is how do we deal with the images and pooling them. Dropout's a cool thing worth looking up. If you haven't, as you get more and more into Keras and TensorFlow, it'll auto drop out certain nodes. That way you'll get a better, the nodes just kind of die. They find that they actually create more of a bias than a help, and they also add processing time, so they remove them. And then we have our flatten. That's where you take that huge array with the 3 different colors and you find a way to flatten it so it's just a 1-dimensional array instead of a 2 by 2 by 3. Dense input, we did that in the other one, so that should look a little familiar. Oops, there we go. Our input, our model, again these are things we had on the last one. Here's our optimizer with our atom. We have some pre-processing on the input that goes along with bringing in the data in. More pre-processing with image to array, loading the image, This stuff is so nice. It looks like a lot of work. So you have to import all these different modules in here. But the truth is it does everything for you. You're not doing a lot of pre-processing. You're letting the software do the pre-processing. And we're going to be working with setting something to categorical. Again, that's just a conversion from a number to a category. 0, 1 doesn't really mean anything. It's like true, false. Label binarizer, the same thing. We're changing our labels around. And then there's our train, test, split, classification report. Our IM utilities, let me just go ahead and scroll down here a notch for these. This is something a little different going on down here. This is not part of the TensorFlow or the sklearn. This is the scikit setup and TensorFlow above. The path, this is part of OpenCV. And we'll actually have another tutorial going out with the OpenCV. So if you want to know more about OpenCV, you'll get a glance on it in this software, especially the second piece when we reload up the data and hook it up to a video camera. We're going to do that on this round. But this is part of the OpenCV thing, and you'll see CV2 is usually how that's referenced. But the IM utilities has to do with how do you rotate pictures around and stuff like that, and resize them. And then the matplot library for plotting, because it's nice to have a graph, tells us how good we're doing, and then of course our numpy numbers array and just a straight OS access. Wow, so that was a lot of imports. Like I said, I'm not going to I spent a little time going through them, but we didn't want to go too much into them. And then I'm going to create some variables that we need to go ahead and initialize. We have the learning rate, number of epochs to train for, and the batch size. And if you remember correctly, we talked about the learning rate to the -4.00001. A lot of times it's 0.001 or 0.001. Usually it's in that variation depending on what you're doing and how many epochs, and they kind of play with the epochs. The epochs is how many times we're going to go through all the data. And now I have it as 2. The actual setup is for 20, and 20 works great. The reason I have it for 2 is it takes a long time to process. One of the downsides of Jupyter is that Jupyter isolates it to a single kernel. So even though I'm on an 8-core processor with 16 dedicated threads, only one thread is running on this, no matter what. So it doesn't matter. So it takes a lot longer to run, even though TensorFlow really scales up nicely. And the batch size is how many pictures do we load at once and process. Again, those are numbers you have to learn to play with depending on your data and what's coming in. And the last thing we want to go ahead and do is there's a directory with a data set we're going to run. And this just has images of masks and not masks. And if we go in here, you'll see data set. And then you have pictures with masks. They're just images of people with masks on their face. And then we have the opposite. Let me go back up here. Without masks. So it's pretty straightforward. They look kind of askew because they tried to format them into very similar setup on there. So they're mostly squares. You'll see some that are slightly different on here. And that's kind of an important thing to do on a lot of these data sets. Get them as close as you can to each other. And we actually will run in this processing of images up here, and the cross layers and importing and dealing with images. It does such a wonderful job of converting these that a lot of it we don't have to do a whole lot with. So you have a couple things going on there. And so we're now going to be, this is now loading the images, and let me see. And we'll go ahead and create data and labels. Here's our here's the features going in, which is going to be our pictures, and our labels going out. And then for categories in our list directory, and if you remember, I just flashed that at you. It had face mask or no face mask. Those are the two options. And we're just going to load into that. We're going to append the image itself and the labels. So we're just going to create a huge array. And you can see right now this could be an issue if you had more data. At some point, thankfully I have a 32 gig hard drive or RAM. Even that, you could do with a lot less of that. Probably under 16 or even 8 gigs would easily load all this stuff. And there's a conversion going on in here. I told you about how we are going to convert the size of the image so it resizes all the images. And that way our data is all identical the way it comes in. And you can see here with our labels, we have without mask, without mask, without mask. The other one would be with mask. Those are the two that we have going in there. And then we need to change it to the one-hot encoding. And this is going to take our, up here we had, was it labels and data. We want the labels to be categorical. So we're going to take labels and change it to categorical, and our labels then equal a categorical list. We'll run that. And again, if we do labels and we just do the last or the first 10, let's do the last 10 just because minus 10 to the end. There we go. Just so we can see what the other side looks like. We now have 1. That means they have a mask. 1, 0, 1, 0, so on. 1 being they have a mask, and 0 no mask. And if we did this in reverse, I just realized that this might not make sense if you've never done this before. Let me run this. 0, 1. So 0 is, do they have a mask on? 0. Do they not have a mask on? 1. So this is the same as what we saw up here without mask. 1 equals, the second value is without mask. So with mask, without mask. And that's just with any of your data processing, we can't really, if you have a 0, 1 output, it causes issues as far as training and setting it up. So we always want to use a one-hot encoder if the values are not actual linear value or regression values, are not actual numbers, if they represent a thing. And so now we need to go ahead and do our train X, test X, train Y, test Y, train, split, test data. And we'll go ahead and make sure it's going to be random, and we'll take 20% of it for testing and the rest for setting it up as far as training their model. This is something that's become so cool. When they're training these sets, they realize we can augment the data. What does augment mean? Well, if I rotate the data around and I zoom in, I zoom out, I rotate it, share it a little bit, flip it horizontally, fill mode, as I do all these different things to the data, it is able to, it's kind of like increasing the number of samples I have. So if I have all these perfect samples, what happens when we only have part of the face, or the face is tilted sideways, or all those little shifts cause a problem if you're doing just a standard set of data. So we're going to create an augment in our image data generator, which is going to rotate, zoom, and do all kinds of cool things. And this is worth looking up, this image data generator and all the different features it has. A lot of times, the first time through my models, I'll leave that out because I want to make sure there's a thing what we call build to fail, which is just cool to know. You build the whole process, and then you start adding these different things in so that you can better train your model. And so we go and run this, and then we're going to load. And then we need to go ahead, and you probably would have gotten an error if you hadn't put this piece in right here. I haven't run it myself because the guys in the back did this. We take our base model, and one of the things we want to do is we want to do a mobile net v2. And this is a big thing right here. Include the top equals false. A lot of data comes in with a label on the top row. So we want to make sure that that is not the case. And then the construction of the head of the model that will be placed on the top of the base model. We want to go ahead and set that up. And you'll see a warning here. I'm kind of ignoring the warning because it has to do with the size of the pictures and the weights for input shape. So it'll switch things to defaults, just saying, hey, we're going to auto shape some of this stuff for you. You should be aware that with this kind of imagery, we're already augmenting it by moving it around and flipping it and doing all kinds of things to it. So that's not a bad thing in this. But in other data, it might be if you're working in a different domain. And so we're going to go back here, and we have our base model. We're going to do our head model equals our base model output. And what we got here is we have an average pooling 2D, pool size 7.7 head model. Head model flatten, so we're flattening the data. So this is all processing and flattening the images. And the pooling has to do with some of the ways it can process some of the data. We'll look at that a little bit when we get down to the lower level and is processing it. And then we have our dense. We've already talked a little bit about a dense, just what you think about. And then the head model has a dropout of 0.5. What we can do with a dropout? The dropout says that we're going to drop out a certain amount of nodes while training. So when you actually use the model, it will use all the nodes. But this drops certain ones out, and it helps stop biases from forming. So it's really a cool feature in here. They discovered this a while back. We have another dense mode, and this time we're using softmax activation. Lots of different activation options here. Softmax is a real popular one for a lot of things, and so is the ReLU. And we could do a whole talk on activation formulas and what their different uses are and how they work. When you first start out, you'll use mostly the ReLU and the softmax for a lot of them, just because they're some of the basic setups. It's a good place to start. And then we have our model equals model, inputs equals base model dot input, outputs equals head model. So again, we're still building our model here. We'll go ahead and run that. And then we're going to loop over all the layers in the base model and freeze them so they will not be updated during the first training process. So for layer and base model layers, layers.trainable equals false. A lot of times when you go through your data, you want to kind of jump in partway through. I'm not sure why in the back they did this for this particular example, but I do this a lot when I'm working with series and specifically in stock data. I want it to iterate through the first set of 30 data before it does anything. I would have to look deeper to see why they froze it on this particular one. And then we're going to compile our model. So compiling the model, atom, init, layer, decay, initial learning rate over epochs, and we go ahead and compile. Our loss is going to be the binary cross entropy, which will have that print out. Optimizer for opt, metrics is accuracy. Same thing we had before, not a huge jump as far as the previous code. And then we go ahead and we've gone through all this, and now we need to go ahead and fit our model. So train the head of the network, print info training head, run. Now I skipped a little time because you'll see the run time here is at 80 seconds per epoch. It takes a couple minutes for it to get through on a single kernel. One of the things I want you to notice on here while it's finishing the processing is that we have up here our augment going on. So anytime the train X and train Y go in, there's some randomness going on there and is jiggling it around what's going into our setup. Of course, we're batch sizing it, so it's going through whatever we set for the batch values, how many we process at a time. And then we have the steps per epoch, the train X, the batch size, validation data. Here's our test X and test Y where we're sending that in. And this, again, it's validation. One of the important things to know about validation is when both our training data and our test data have about the same accuracy, that's when you want to stop. That means that our model isn't biased. If you have a higher accuracy on your testing, you've trained it, and your accuracy is higher on your actual test data, then something in there is probably has a bias and it's overfitted. So that's what this is really about right here with the validation data and validation steps. So it looks like let me go ahead and see if it's done processing. It looks like we've gone ahead and gone through 2 epochs. Again, you could run this through about 20 with this amount of data, and it would give you a nice refined model at the end. We're going to stop at 2 because I really don't want to sit around all afternoon, and I'm running this on a single thread. So now that we've done this, we're going to need to evaluate our model and see how good it is, and to do that we need to go ahead and make our predictions. These are our predictions on our test X to see what it thinks are going to be. So now it's going to be evaluating the network, and then we'll go ahead and go down here, and we will need to turn the indexing, because remember it's either 0 or 1. It's 0, 1, 0, 1. So you have two outputs: not wearing a mask, not wearing a mask. And so we need to go ahead and take that argument at the end and change those predictions to a 0 or 1 coming out. And then to finish that off, we want to go ahead and let me just put this right in here and do it all in one shot. We want to show a nicely formatted classification report so we can see what that looks like on here. And there we have it. We have our precision. It's 97% with a mask. There's our F1 score, support without a mask, 97%. So that's pretty high setup on there. You know, 3 people are going to sneak into this door who are without a mask and thinks they have a mask, and there's going to be 3 people with a mask that's going to flag the person at the front to go, oh, hey, look at this person, he might not have a mask. That's I guess if it's a setup in front of a store. So there you have it. And of course, one of the other cool things about this is if someone's walking into the store and you take multiple pictures of them, you know, this is just it would be a way of flagging, and then you can take that average of those pictures and make sure they match or don't match if you're on the back end. And this is an important step because this is just cool. I love doing this stuff. So we're going to go ahead and take our model and we're going to save it. So model save maskdetector.model. We're going to give it a name. We're going to save the format. In this case, we're going to use the H5 format. And so this model we just programmed has just been saved. So now I can load it up in model. Now they can use it for whatever. And then if I get more information and we start working with that, at some point I might want to update this model. Make a better model. And this is true of so many things where I take this model and maybe I'm running a prediction on making money for a company, and as my model gets better I want to keep updating it, and then it's real easy just to push that out to the actual end user. And here we have a nice graph. You can see the training loss and accuracy as we go through the epochs. We only did only shows just the one epoch coming in here, but you can see right here as the value loss, train accuracy, and value accuracy start switching and they start converging. And you'll hear converging. This is the convergence they're talking about when they say I know when I work in the scikit with sklearn neural networks, this is what they're talking about, a convergence, is our loss and our accuracy come together, and also up here, and this is why I'd run it more than just 2 epochs. As you can see, they still haven't converged all the way. So that would be a cue for me to keep going. But what we want to do is we want to go ahead and create a new Python 3 program. And we just did our train mask. So now we're going to go ahead and import that and use it and show you in a live action. Get a view of both myself in the afternoon along with my background of an office, which is in the middle still of reconstruction for another month. And we'll call this mask detector. And then we're going to grab a bunch of a few items coming in. We have our MobileNet V2 import preprocessing input, so we're still going to need that. We still have our TensorFlow image to array. We have our load model. That's where most of the stuff's going on. This is our CV2 or OpenCV. Again, I'm not going to dig too deep into that. We're going to flash a little OpenCV code at you, and we actually have a tutorial on that coming out. Our NumPy array, our IM utilities, which is part of the OpenCV or CV2 setup. And then we have, of course, time and just our operating system. So those are the things we're going to go ahead and set up on here. And then we're going to create, this takes just a moment, our module here, which is going to do all the heavy lifting. So we're going to detect and predict a mask. We have frame, FaceNet, MaskNet. These are going to be generated by our OpenCV. We have our frame coming in, and then we want to go ahead and create a mask around the face. It's going to try to detect the face and then set that up so we know what we're going to be processing through our model. And then there's a frame shape here. This is just our height versus width. That's all HW stands for. They've called it blob, which is a CV2 DNN blob form image frame. So this is reformatting this frame that's going to be coming in literally from my camera. And we'll show you that in a minute, that little piece of code that shoots that in here. And we're going to pass the blob through the network and obtain the face detections. So facenet.setImport_blob, detections facenet forward, print detections shape. So this is what's going on here. This is that model we just created. We're going to send that in there, and I'll show you in a second where that is, but it's going to be under facenet. And then we go ahead and initialize our list of faces, their corresponding locations, and the list of predictions from our face mask network. We're going to loop over the detections, and this is a little bit more work than you think as far as looking for different faces. What happens if you have a crowd of faces? So we're looping through the detections and the shapes going through here. And probability associated with the detection. Here's our confidence of detections. We're going to filter out weak detection by ensuring the confidence is greater than the minimum confidence. So we've set it, remember, 0 to 1. So 0.5 would be our minimal confidence, probably is pretty good. And then we're going to put in compute bounding boxes for the object. If I'm zipping through this, it's because we're going to do an open CV, and I really want to stick to just the Keras part. And so I'm just kind of jumping through all this code. You can get a copy of this code from Simplilearn and take it apart, or look for the open CV coming out. And we'll create a box. The box sets it around the image. Ensure the bounding boxes fall within the dimensions of the frame. So we create a box around what we hope is going to be the face. Extract the face, ROI, convert it from BGR to RGB channel. Again, this is an open CV issue. Not really an issue, but it has to do with the order. I don't know how many times I've forgotten to check the order colors when working with OpenCV. Causes all kinds of fun things when red becomes blue and blue becomes red. And we're going to go ahead and resize it, process it, frame it, face frame setup. Again, the face, the CVT color, we're going to convert it. We're going to resize it, image to array, pre-process the input, pin the face, locate face, start X, start Y, and X. Boy, that was just a huge amount, and I skipped over a ton of it, but the bottom line is we're building a box around the face, and that box, because the OpenCV does a decent job of finding the face, and that box is going to go in there and see, hey, does this person have a mask on it? And so that's what all this is doing on here. And then finally we get down to this where it says predictions equals masknet.predict faces batch size 32. So these different images where we're guessing where the face is are then going to go through and generate an array of faces, if you will. And we're going to look through and say, does this face have a mask on it? And that's what's going right here is our prediction. That's the big thing that we're working for. And then we return the locations and the predictions. The location just tells where on the picture it is, and then the prediction tells us what it is. Is it a mask or is it not a mask? Alright, so we've loaded that all up. So we're going to load our serialized face detector model from disk. And we have the path that it was saved in. Obviously you're going to put it in a different path depending on where you have it or however you want to do it and how you saved it on the last one where we trained it. And then we have our weights path, and so finally our facenet, here it is, equals cv2.dnn.readnet prototext path weights path, and we're going to load that up on here. So let me go ahead and run that. And then we also need to, I'll just put it right down here. I always hate separating these things in there. And then we're going to load the actual mask detector model from disk. This is the model that we saved. So let's go ahead and run that on there also. So this is pulling in all the different pieces we need for our model. And then the next part is we're going to open up our video. And this is just kind of fun because it's all part of the OpenCV video setup. And we just put this all in as one. There we go. So we're going to go ahead and open up our video. We're going to start it and we're going to run it until we're done. And this is where we get some real like kind of live action stuff, which is fun. This is what I like working about with images and videos, is that when you start working with images and videos, it's all like right there in front of you. It's visual and you can see what's going on. So we're going to start our video streaming. This is grabbing our video stream source 0 start. That means it's grabbing my main camera I have hooked up. And then, starting video, you're going to print it out. Here's our video source equals 0 start. Loop over the frames from the video stream. Oops, a little redundancy there. Let me close. I'll just leave it. That's how they had it in the code. So while true, we're going to grab the frame from the threaded video stream and resize it to have the maximum width of 400 pixels. So here's our frame. We're going to read it from our visual stream. We're going to resize it. And then we have a returning. Remember, we returned from our procedure the location and the prediction. So detect and predict mask. We're sending it the frame. We're sending it the face net and the mask net. So we're sending all the different pieces that say this is what's going through on here. And then it returns our location and predictions, and then for our box and predictions in the location and predictions, and the box is again, this is an open CV set that says, hey, this is a box coming in from the location, because you have the two different points on there. And then we're going to unpack the box and predictions, and we're going to go ahead and do mask without a mask equals prediction. We're going to create our label. No mask, we're going to create color. If the label equals mask, L00225. And this is going to make a lot more sense when I hit the run button here. But we have the probability of the label. We're going to display the label and bounding box rectangle in the output frame. And then we're going to go ahead and show the output from the frame, CV2 IM show frame. And then the key equals CV2 wait key 1. We're just going to wait till the next one comes through from our feed. And we're going to do this until we hit the stop button pretty much. So are you ready for this? Let's see if it works. We've distributed our model. We've loaded it up into our distributed code here. We've got it hooked into our camera. And we're going to go ahead and run it. And there it goes. It's going to be running. And we can see the data coming down here. And we're waiting for the pop-up. And there I am in my office with my funky headset on. And you can see in the background my unfinished wall, and it says up here, no mask. Oh no, I don't have a mask on. I wonder if I cover my mouth, what would happen? You can see my no mask goes down a little bit. I wish I'd brought a mask into my office. It's up at the house. But you can see here that this says, there's a 95-98% chance that I don't have a mask on. And it's true, I don't have a mask on right now. And this could be distributed. This is actually an excellent little piece of script that you could start, you install somewhere on a video feed on a security camera or something, and then you'd have this really neat setup saying, hey, do you have a mask on when you enter a store or public transportation or whatever it is where they're required to wear a mask? Let me go ahead and stop that. Now, if you want a copy of this code, definitely give us a holler. We will be going into OpenCV in another one, so I skipped a lot of the OpenCV code in here as far as going into detail. Really focusing on the Keras, saving the model, uploading the model, and then processing a streaming video through it so you can see that the model works. We actually have this working model that hooks into the video camera, which is just pretty cool and a lot of fun. So I told you we're going to dive in and really roll up our sleeve and do a lot of coding today. We did the basic demo up above for just pulling in a Keras, and then we went into a cross model where we pulled in data to see whether someone was wearing a mask or not. So very useful in today's world as far as a fully running application.
Artificial intelligence or AI is transforming our world, making things faster and more efficient. But what happens when AI makes mistakes? When AI is biased? It can have serious consequences for companies and people's lives. Imagine missing out on a job, being wrongly identified in a photo, or being unfairly treated, all because a computer program made a bad decision. These mistakes don't just harm individuals, they can affect entire communities without realizing it. So AI bias is also called algorithmic bias. happens when AI systems unintentionally favor one group over another. Take healthcare. For example, if the data used to train an AI system doesn't include enough women or people from minority groups, the system might not work as well for them. This can lead to incorrect medical prediction, like giving black patients less accurate results than white patients. In job hiring, AI can unintentionally promote certain stereotypes, like when job ads use terms like ninja, which may attract more men than women, even though the term isn't a requirement for the job. Even in creative areas like image generation, AI can reinforce biases. When asked to create picture of CEOs, AI systems often show mostly white men, leaving out women and people of color. In law enforcement, AI tools sometimes rely on biased data, which can unfairly target minority communities. So in this video, we will explore some well-known examples of AI bias and how these mistakes are impacting people and society, from healthcare to hiring and even criminal justice. AI bias is something we need to understand and fix. So let's dive in and learn how these biases happen and what can be done to stop them. So what is AI bias? AI bias, also called machine learning bias, happens when human biases affect the data used to train AI system, causing unfair or inaccurate results. When AI bias isn't fixed, it can hurt a business success and prevent some people from fully participating in the economy or society. Biases makes AI less accurate, which reduce its effectiveness. Businesses may struggle to benefit from systems that give unfair results, and scandals from AI bias can lead to loss of trust, especially among groups like people of color, women, people with disabilities, and the LGBTQ community. AI models often learn from the data that reflects society biases. This can lead to unfair treatment of marginalized groups in the areas like hiring, policing, and credit scoring. As the Wall Street Journal notes, businesses still find it challenging to address these widespread biases as the AI use grows. So moving forward, let's see some sources of AI bias. Distorted outcomes can negatively affect both organization and society as a whole. So here are some common forms of AI bias. The first one is algorithm bias. If the problem or question is not well defined or the feedback provided to the machine learning algorithm is inadequate, the result may be inaccurate or misleading. The second one is cognitive bias. Since AI systems rely on a human input, they can be affected by unconscious human biases, which may influence either the dataset or the model's behavior. The third one, confirmation bias. This occurs when the AI overly depends on existing beliefs or trends in the data, reinforcing prior biases and failing to detect new patterns or trends. The fourth one, execution bias. When important data is omitted from the dataset, often due to the developer overlooking new or crucial factors, this type of bias arises. The fifth one, measurement biases. So this bias stems from incomplete data, such as when a dataset fails to represent the entire population. For instance, if a college analyzes only graduates to determine success factors, it would overlook reasons why others drop out. So moving forward, let's see how to avoid bias. So here are checklists of 6 process steps that can keep AI programs free of bias. The first one is choose the right model. Ensure diverse stakeholders select training data in supervised model and integrate bias detection tools in unsupervised models. The second one, use accurate data. Train AI with complete balanced data that reflects the true demographics. The third one, build a diverse team. A varied team helps spot bias, including innovators, creators, implementers, and end users. The next one, watch data processing. Bias can appear during any phase of processing, so stay vigilant throughout. The fifth one, monitor regularly. So continuously test models and have independent assessment to detect and fix biases. And the last one, check infrastructure. Ensure technological tools and sensors are functioning properly to avoid hidden biases. So conclusion is AI biases poses serious challenges by amplifying existing societal biases, affecting individuals and businesses. From healthcare to hiring, AI system can unintentionally reinforce stereotypes and inequalities.
We will discuss about booming topic of this era, multimodal AI. Let's understand with an example. Imagine you are showing a friend your vacation photos. You might describe the sight you saw, the sounds you heard, and even your emotions. This is how humans naturally understand the world, by combining information from different sources. Multimodal AI aims to do the same thing. Let's break the modal AI first. Multimodal refers to two different ways of communicating. Information like text, speech, images, and videos where AI stands for artificial intelligence, which are systems that can learn and make decisions. So multimodal AI is a type of AI that can process and understand information from multiple sources just like you do when you look at your vacation photos. Now that we have understood what is multimodal AI, let's now go a bit further. It is obvious that multimodal AI is not the only AI out there. But what is big deal about multimodal AI that everyone is talking about? That is what we will discuss in this segment. So now let's understand the difference between multimodal AI and the generative AI. While both multimodal AI and generative AI are exciting advancement in AI, they differ in their approach to data and functionality. So generative AI focus creates new data similar to the data it's trained on. And in multimodal AI, focus is to understand and processes information from multiple sources, that is text, speech, images, and videos. Data types of generative AI are primarily works with a single data type like text, writing poems or images, that is generating realistic portraits. Whereas in multimodal AI, data types works with diverse data types, enabling a more comprehensive understanding of the world. The third one is examples like chatbots, text generation models, image editing tools. Whereas multimodal AI example covers virtual assistants, medical diagnosis system, and autonomous vehicles. Strengths are can produce creative and innovative content, automate repetitive tasks, and personalize your experience. Whereas in multimodal AI, strengths are provides a more human-like understanding of the world and improve accuracy. In essence, generative AI excels at creating new data, while multimodal AI excels at understanding and utilizing existing data from diverse sources. They can be complementary with generative models being used to create new data for multimodal AI systems to learn more from and improve their understanding to the world. Next, let's understand what are the benefits of multimodal AI. The benefits of multimodal AI is that it offers developers and users an AI with more advanced reasoning, problem solving, and generation capabilities. These advancements offers endless possibilities for how next generation application can change the way we work and live. For developers looking to start building, Vortex AI Gemini API offers features such as enterprise security, data residency, performance, and technical support. If your existing Google Cloud customers can start prompting with Gemini AI in Vortex AI right now. Next, let's see what are the multimodal AI big challenges. Multimodal AI is powerful but faces hurdles. The first one is data overload. Managing and storing massive, diverse data is expensive and complex. The second one is meaning mystery. Teaching AI to understand subtle difference in between meaning like sarcasm is tricky. The third one is data alignment. Ensuring data points from different sources staying in tune is challenging. The fourth one is data scarcity. Limited and potentially biased datasets hinder effective training. The fifth one is missing data blues. What happens when data is missing, like distorted audio? The last one is black box blues. Understanding how AI makes decisions can be difficult. So these challenges must be addressed to unlock the full potential of model AI. Next, let's see what is the future of multimodal AI and why is it important. Multimodal AI and multimodals represent a leap forward in how developers build and expand the functionality of AI in the next generation of application. For example, Gemini can understand, explain, and generate high quality code in the world's most popular programming languages like Python, Java, C++, and Go, freeing developers to work on building more featured filled applications. Multimodal's AI potential also bring the world closer to AI that's less like smart software and more like an expert helper or assistant.
Welcome to our video about transformers in AI. And no, we don't mean the robot toys from the movies. We are diving into something even cooler in the world of computers and AI. Have you ever wondered how your phone knows what word you might type next, or how Google Translate works so well? That's where transformers come in. They are like super smart computer brains that can understand and create human-like text. Here's a fun example. I asked a transformer to tell me a joke and it said, "Why did the computer go to the art school?" Because it wanted to improve its draw speed. Okay, that's a bit cheesy, but it shows how these computer programs can come up with new ideas on their own. Transformers are changing how we use technology every day. They help us with things like translating languages, summarizing long articles, writing emails and stories, and even playing games like chess. In this video, we will explore how transformers work, why they are so special, and what cool things they might do in the future. So let's talk about what exactly are transformers. Transformers are an artificial intelligence model used to process and generate natural languages. They can read and understand huge amount of text and then use that knowledge to answer questions, translate languages, summarize information, and even create stories or write code. The magic behind transformers is their ability to focus on different text paths with attention mechanisms. This means that they can understand context better than older models, making their outputs more accurate and natural sounding. The basic structure of a transformer includes two main parts, the encoder and the decoder. Think of the encoder as a translator that understands and processes the input, and the decoder as the one that takes the processed information and turns it into the output. For example, if we are translating a sentence from English to French, the encoder reads the English sentence and converts it into a form that AI can understand. The decoder then takes this form and generates the French sentence. A great example of a transformer in action is ChatGPT. ChatGPT uses transformers to understand and generate human-like text. When you ask a question, it processes your input with its encoder and generates a response with its decoder. This lets it have conversations, write essays, and even tell jokes. For instance, if you ask ChatGPT what's the weather like today, it uses its transformer model to understand your question and respond it with it's sunny with a chance of rain in the afternoon. This ability to understand and generate text makes transformers incredibly powerful. So let's talk about how transformers work. Transformers are especially good at sequence to sequence learning tasks like translating a sentence from one language to another. Here's how they work. First, there's the attention mechanism. This allows the transformer to focus on different parts of input data. For example, if it's translating the sentence, the cat sat on the mat, it can pay attention to each word's context to understand the meaning better. So it knows cat is related to sat and mat, helping it produce an accurate translation in another language. Transformers also use something called positional encoding. Since they process all words at once, they need a way to understand the order of the words. Positional encoding adds information about the position of each word to the input, helping the transformers understand the sequence. Another key feature is like parallel processing. Unlike older models like Recurrent Neural Network, which is RNNs, the process text words by word. Transformers can process the entire sentence at once. This makes them much faster and more efficient. Let's compare transformers with recurrent neural networks. But first, let's understand what are RNNs. So RNNs is a type of neural network designed to handle sequential data. They process data one step at a time, maintaining a memory of previous steps. This makes them good for tasks where order matters, like speech recognition or time series prediction. However, RNNs have a problem called the vanishing gradient, which means that they can forget information from earlier in the sequence. Imagine trying to understand the sentence, Alice went to the park and then to the store. And RNN might struggle to remember Alice by the time it gets to the store, but a transformer can easily keep track of Alice throughout the sentence. So why are transformers better? Unlike RNNs, transformers process the entire sentence at once, keeping the context intact. This solves the vanishing gradient problem and makes transformers faster and more accurate to tasks like language translation and text generation. So let's talk about the applications of transformers. At first, we have language translation. They are used by services like Google Translate to convert text from one language to another. For example, translating hello, how are you to Spanish as hola. Then we have document summarization. They can take long articles and summarize them into shorter, more concise versions. For instance, summarizing a 10-page report into a few key points, making it easier to understand the main ideas without reading the whole document. Then we have content generation. Transformers can write articles, stories, and even code. They can create new content based on what they have learned. For example, you could ask a transformer to write a short story about a space adventure, and then it would come up with a unique narrative. Then we have game playing. Transformers can learn and play complex games like chess, making strategic decisions just like a human player. They analyze the entire board and make moves considering all possible outcomes. Let's talk about image processing. They are used in tasks like image classification and object detection, helping computers understand visual data. For example, identifying objects in a photo, like recognizing a cat, tree, or a car. Now let's understand the training process. The training transformers involves two main steps. Semi-supervised learning. They can learn from both labeled data where the answer is known and unlabeled data where the answer is not provided. This makes them very versatile. For example, a transformer could be trained on a mix of articles with and without summaries to learn how to summarize text effectively. Pre-training and fine-tuning. Transformers are pre-trained on a large dataset to learn general patterns. Then they are fine-tuned with specific tasks, making them highly versatile. For instance, a transformer might be pre-trained on a large collection of books to understand language and then fine-tuned to generate marketing copy for a specific brand. The future potential of transformers is huge. Researchers are continuously improving them, making them even more powerful. We can expect more advanced applications in areas like healthcare, finance, and more sophisticated AI systems that interact with humans in more natural ways. Imagine having an AI that can provide personalized medical advice or one that can help you write a novel. In conclusion, we can say that transformers are a revolutionary architecture in AI. They offer speed, efficiency, and versatility, changing how we interact with the technology. The future looks bright for transformers, and we can't wait to see what they'll do next.
Hello everyone, I am Armonk and welcome to this video where I will show you how to run Llama 3.1 on your systems, all while keeping your data private. If you are curious about AI and want to use it on your own PC without relying on online services, you are in the right place. Llama 3.1 is a powerful AI tool that can help with tasks like text generation, but instead of using it in the cloud, you can run it directly on your computer. So in this video, I will guide you through everything from setting up your system to installing and running Llama 3.1 step by step. It's a great way to experiment with AI while keeping your work private. So by the end of this video, you will have Llama 3.1 up and running on your own systems. And you won't need to worry about sharing your data with anyone else. Whether you are just learning about AI or planning to use it for bigger projects, this tutorial will make it easy for you to get started. So let's dive in, follow along, and by the end, you will have your own private AI setup. Don't forget to like, subscribe, and let's start running Llama 3.1. So yeah, welcome to this demo part of this Llama. How to install Llama 3.1 okay in your system. So I'm using Windows right now. Okay, it is available for Mac OS, Linux, and Windows. So first what we will do, we will install this Llama. Okay, just type ollama.com and I will provide this link in the description as well. Okay, then here you have to press the download. Okay, here you can choose your system. Okay, your OS, Mac OS, Linux, Windows. Okay, just follow the steps later. So I will download for the Windows. So the application will get download. Okay, it is like 625 MB. So it is downloading. Okay, till then there is no official documentation for this Llama. So here in GitHub there is one. Okay, so Llama. This is Windows for here, Windows, macOS, Linux you can download, and these are some models. Okay, see Llama 3.1, Llama 3.1, Llama 3.1, and 5, Gemma, and Mistral is there, Moondream is there, and so on. Okay, and see these are some parameters. Okay, 8B is 4.7 GB, 70B is 40 GB, and for 05B is 231 GB. Okay, so here note, you should have at least 8 GB of RAM available to run 7B models. Okay, 16 GB RAM to run 13B models and 32 GB RAMs to run 32B models. Okay, so here we will install this 8B parameters. Okay, you can choose anyone as per your specification of your system, your OS. Okay, so still it's downloading. I have already installed in this, but again I will reinstall it. Fine. So now we have Llama setup. Okay, just double click on this and install. Okay, see why it is showing this error and why it is showing this error. Why? Because the following applications are using files that need to be updated by setup. It is recommended that you allow setups to automatically. Okay, it is automatically installed. See, so simple steps. There are 3-4 steps that you have to do. So yeah, the setup is done, and now what you can do, I am using PowerShell. You can use your command prompt as well. So here I will write Olama. Okay, so here you can see these are some available command I can do. Okay, so to run a model you have to just write run and this. Okay, now if you will see here, to download Llama 3.1 8B parameter 1 4.7 GB will be the size. So this is the command. Just copy it and paste it here. Okay, and enter. So why it is coming like this? Because it is already installed on my system. Fine. So now Llama 3.1 is installed. Okay, so here you can write your questions. Okay, what is Llama 3.1? So see, it is start generating the output. So this is how you can privately run or install Llama into your large language models applications into your system. See, it is like ChatGPT. If you are looking for more details, can you please provide context or more background about why you are interested in Llama 3.1? That would be me try to find more relevant information for you. Okay, so here what I will write what is ChatGPT. Okay, so it will give you the answer. See, ChatGPT is a conversational AI model developed by OpenAI, a leading artificial intelligence research laboratory. Okay, what you have to note, just you have to note what's the size of your RAM. Okay, I have 16 GB of RAM, that's why I installed this 8B one. Okay, and if you have 8 GB RAM, there is no model of 7B. 7B we have Lava, and we have Code Llama, and we have Mistral. So if you have 16 GB of RAM and this one Llama 3.1, the latest one, is enough. Okay, so let's check. Yeah, see, ChatGPT stands for Conversational Generative Pre-trained Transformer. It is an AI chatbot designed to understand and respond to human-like language input. And some key features are this. So this is how you can be protected from your data as well, and you can ask anything to this. Okay, and there is one more thing. If you will go here, this API section. Okay, yeah, so there is one thing, I guess here is a thing. So yeah, if you type this localhost 11434, so this is an API for the Olama. See, here you can see Olama is running. Fine. So this is how you can do this, perform or install your Llama 3.1 in your local system. See, it is now asking me, how is that? Did I cover what you wanted to know about ChatGPT? Okay, and you can give your prompt, and again you can do something. So okay, I will write what is hello world. See, hello world is a simple phrase that has become iconic in the world of computer programming. Everyone know to print hello world, I guess so. So this is how you can install Llama 3.1 in your local system. Okay, just you have to install Olama first, then search this Olama run 3.1, or if you want to explore more thing, you can write version, so the version, server, create, and all this thing. Okay. Today we are talking about must-have Python AI projects and how to build them so that can really help you sharpen your skills and stand out in the growing field of artificial intelligence. So let's quickly see what is Python. Python is one of the most popular programming languages for AI because its simplicity and the powerful libraries it offers, like TensorFlow, Keras, and PyTorch. Building projects using Python is a great way to get started if you want to break into the AI industry. Whereas artificial intelligence is transforming industries like healthcare, finance, and even entertainment. Companies are now looking for experts who know how to apply AI to real-world problems. In this video, we will explore beginner level to advanced level projects. So these projects are designed to give you hands-on experience in building intelligent systems, analyzing data, and even automating tasks. So without any further ado, let's get started. So let's start with beginner level projects. So number one, we have fake news detection using machine learning. So in today's world, fake news is a major concern, causing misinformation to spread rapidly across social media and news platforms. Detecting fake news is crucial to maintaining the integrity of the information we consume. So these projects aim to build a machine learning model that can identify fake news articles by analyzing their textual content, by learning from existing datasets of real and fake news. The model will be able to classify articles into these two categories, thus assisting media outlets and social media platforms in reducing the spread of misinformation. This project is perfect introduction to natural language processing (NLP) as it involves text data manipulation, feature extraction, and supervised learning. It can also be adapted for real-time use on website or social media platforms to flag suspicious article and provide more reliable information to users. So now let's see how to build this. In this, first step is data collection. Use dataset like LIAR or fake news net that can contain label, real, and fake news articles. You can find dataset from the Kaggle. The second step is pre-processing. Clean the text by removing stop words, punctuation, and special character. Tokenize and stem words using NLTK or spacing. The third step is feature extraction. Use TF, IDF, or bag of words to convert the text into numerical data for machine learning models. The fourth step is model training. Train a classifier like logistic regression, naive Bayes, or random forest on the dataset. The fifth step is evaluation. Evaluate the model using accuracy, precision, recall, and F1 score metrics to determine how well it classifies fake and real news. Tools you can use is NLTK, Scikit-learn, and Pandas. Skills you will gain from this are text preprocessing, NLP, classification models. And if you want to make us video on this project, please comment down below. In number 2, we have image recognition using CNN. Image recognition is one of the core applications of deep learning and computer vision, used in a variety of industries ranging from healthcare to autonomous vehicles. This project will guide you through building an image classifier using CNNs, a deep learning architecture designed specifically for image recognition tasks. The goal is to create a model that can accurately classify images, such as differentiating between cats and dogs. By working on this project, you will gain a solid understanding of the fundamental concepts of CNNs, such as convolutional layers, pooling, and activation functions. This project not only introduces you to the basics of CNNs, but also teaches essential skills like image preprocessing, dataset handling, and model evaluation, which can be applied to more advanced computer vision projects in the future. So now let's see how to build this project. In this project, first you have to import dataset. So use a dataset like CIFAR10 or Kaggle cats versus dogs with labeled images. The second step is pre-processing. Resize, normalize, and augmented images using libraries like OpenCV or PIL to prepare the dataset. The third step is model architecture. Design a basic CNN model with convolutional, pooling, and fully connected layers using Keras or TensorFlow. The fourth step is training. Split the dataset into training and validation sets and train the CNN model to classify images. The fifth step is model evaluation. Use accuracy, precision, and confusion metrics to evaluate how well the model predicts the correct class label. Tools you will use in this project are Keras, TensorFlow, OpenCV, Pandas. Skills you will gain after doing these projects are image preprocessing, CNN architecture, model evaluation. And if you want to make us video on image recognition using CNN, please comment down below. Second, we have intermediate level projects. In this first, we have AI-based recipe recommendation system. Recommendation systems have become an integral part of modern digital platforms. From e-commerce website suggesting product to users to streamlined services recommending shows and movies. So in this project, you will build a recipe recommendation system that suggests dishes based on the ingredients a user has on hand. This project demonstrates how recommendation algorithms such as content-based filtering and collaborative filtering can be used to provide personalized suggestions. You will also learn how to pre-process data and clean textual data, such as ingredient lists, and implement a machine learning algorithm to match user inputs with recipe databases. This is an excellent project for understanding how recommendation systems work and how they can be applied in various industries, from food tech to personalized content recommendations. So now let's see how to build this. In this project, first step is data collection. Use web scraping tools like Beautiful Soup to scrape recipes from websites, or use datasets like Recipe 1M. The second step is pre-processing. Normalize and clean ingredient data by standardizing ingredient names and handling missing values. The third step is recommendation algorithms. Implement content-based filtering and collaborative filtering to recommend recipes. Content-based filtering matches ingredient list, while collaborative filtering uses user preferences model. Fourth step is model training. Use cosine similarity to match user-provided ingredients with recipe ingredient in the dataset. And the next step is interface and tools. So create a simple web interface using Flask where users can input ingredients and receive recipe recommendation. Tools you will use: Beautiful Soup, Pandas, Scikit-learn, and Flask. So you will gain skills like web scraping, data cleaning, recommendation systems using this project by doing this project. And if you want to make us video on this project, please comment down below. Number 4, we have chatbot with sentiment analysis. Chatbots have transformed how businesses and services interact with users, providing 24/7 support and personalized responses. In this project, you will build a conversational chatbot that can analyze the sentiment behind user inputs and respond accordingly. By incorporating sentiment analysis, the chatbot will not only understand the content of the user's messages, but also the emotional tone, such as whether the user is happy, frustrated, or neutral. This allows the chatbot to adjust its tone and responses to improve user satisfaction. For example, a chatbot could offer a more empathetic response if it detects a negative sentiment. This project will give you hands-on experience in building a conversational AI system while learning how to integrate machine learning techniques like sentiment analysis. The skills you develop in this project can be applied to customer service, healthcare, education, and more. So now let's see how to build this project. In this project, the first step is chatbot framework. Use tools like Dialogflow or Rasa to build a conversational chatbot capable of handling various user intents. The second step is sentiment analysis. Integrate a sentiment analysis model using pre-trained models like VEDA or BERT. The third step is conversational flow. Adjust the chatbot's responses based on the sentiment, positive, negative, or neutral, detected in the user's input. The fourth step is integration and deployment. So build an interface, website, or messaging platform where users can interact with the chatbot in real time, and deploy the chatbot on a website or app, allowing user to engage with it and receive sentiment-aware responses. So you will use tools in this are Dialogflow, Rasa, Vader, Transformers, Flask. And you will gain skills like sentiment analysis, chatbot deployment, conversational AI. And if you want to make us video on this project, please comment down below. So now let's see some advanced level projects. In this we have AI-powered image colorization. Image colorization is a fascinating application of deep learning that transforms black and white images into color by predicting and applying realistic colors to grayscale images. This project explores how CNN and GANs can be used to learn mapping between grayscale and colored images. You will gather dataset of colored images, convert them into grayscale, and train the model generate color versions. This project is especially useful in areas such as film restoration, photography, and artistic creation, where colorization can breathe new life into old black and white images. Moreover, it highlights the power of deep learning in understanding and generating complex visual data, giving you insight into how these models work for tasks like image generation, video prediction, and beyond. The skills you learn in this project will also be useful for other creative AI applications like style transfer and image synthesis. So now let's see how to build this project. So in this project, first step is data collection. Use dataset of colored image, convert them into grayscale, and use the grayscale images as inputs while training the model to output colorized version. The second step is pre-processing. Normalize images pixel values and resize them for training. The third step is model architecture. Implement a unit model or generative adversarial network (GANs) which are well suited for image generation tasks like colorization. Fourth step is training and evaluation. Train the model on grayscale images as input and colored images as output using mean squared error method for guidance. Evaluate with visual inspection and peak signal to noise ratio. The last step is deployment. So create a web interface where user can upload black and white images and get them colorized. So you will use tools like TensorFlow, Keras, OpenCV, and Flask. So we'll gain skills like deep learning, CNNs, JNs, and image pre-processing. And if you want to make a video on AI-powered image colorization project, so please comment down below. And the last we have object detection using YOLO. You only look once. Object detection is one of the most popular computer vision applications, allowing machine to recognize and locate multiple objects within an image or video stream in real time. YOLO is a state-of-the-art object detection algorithm known for its speed and accuracy. This project involves building a real-time object detection system capable of identifying multiple objects in images or videos feeds by drawing bounding boxes around them. Object detection has widespread use in fields such as security surveillance, autonomous driving, and augmented reality, where systems need to understand and interact with their surroundings in real time. By working on this project, you will learn how to pre-process image data, format bounding box labels, and train a YOLO model using a dataset like Coco or Pascal. You will also gain a valuable experience in deploying object detection systems that process video streams, giving you the skills to build application in dynamic environment, from traffic monitoring to industrial robotics. So now let's see how to build this project. So in this project, we will first import dataset. So use a dataset like Coco or Pascal VOC, which contains label objects in images with bounding boxes. The second step is pre-processing. Resize image and normalize pixel values, ensuring bounding box labels are appropriately formatted. The third step is model architecture. Use the YOLO, you only look once architecture, which splits images into a grid and predicts bounding boxes and class probabilities for each object. The fourth step is training and evaluation. Train the YOLO model on labeled data using a framework like Darknet. Evaluate the model using metrics like intersection over union and mean average precision. The last step is deployment. Develop a system that can process video streams in real time, detecting objects and drawing bounding boxes around them. Tool you will use OpenCV, TensorFlow, and Darknet. You will gain skills like object detection, YOLO architecture, real-time video processing. And if you want to make videos on this project, please comment down below. So in conclusion, these Python AI projects not only help you build hands-on skills, but also provide a solid foundation for advancing your career in artificial intelligence. Whether you are working on fake news detection, image recognition, or developing advanced tools like chatbots and object detection systems, these projects offer real-world applications that companies are looking for. Start small, keep learning, and as you complete each project, you will get better prepared to take on the challenges in the growing AI field. By 2025, if you are not using AI to code, you might be falling behind. That might sound extreme, but the truth is, AI is changing how we develop software at lightning speed. Whether you are a beginner or an experienced programmer, AI tools are opening up new opportunities you might not have thought possible. In this video, I will show you the top AI coding tools that will make you feel like you have got a full team of developers at your disposal. No matter if you are working on web apps, mobile projects, or data science, AI coding assistant can seriously boost your productivity. Before we get into the list, let me quickly explain what AI coding tools actually are. These tools use advanced machine learning to enhance your coding experience. They can suggest smart code completion, generate full code snippets, and handle repetitive tasks for you. Think of them as a helpful assistant, always there to make coding faster and easier. So now let's check out the best AI coding tools used in 2025.
So welcome to the demo part of best AI coding tools for 2025. So in this, I will show you top 5 coding AI tools, right? First, we will start with ChatGPT. So I'm not talking about the simple one because simple one is everyone know, but recently ChatGPT launched GPT-4o with Canvas. So we will open this. Here I will write, give me login page code using HTML, CSS and CSS. Okay. See the magic. See, like that. So right now it's in beta version. Okay. So I guess those who have paid version, so they can, use this. So now, see here. What if I want to change these background color, only particular background color? I don't want to change all the code, but I just want to change these color, H2 color, or you can say display, it will block or something else. Okay, I want to change the padding of this particular, class, right? So here, what I will do, I will select this and one pop-up will come, ask ChatGPT. So now you can just, here you can write, please change background color to blue. I don't know which color is that, but again I want to change it to blue. See, it will change only the background color. See, rest will be the same, right? See here, edited. So this is the best upgrade I can see with ChatGPT with coding, for coding. Okay, so let's see one more. Okay, so here what I will do, let's change the padding. Okay, here I will write increase, what is this, border radius, border radius. Okay, see here is 8, it will increase. See, it did 16, and the rest all is same. So this is one tool. Okay, ChatGPT 4o with Canvas. The second is Gemini. Okay, I am not going to use Gemini into Gemini prompt, but I will open one thing, Google Colab. Okay, so here is Google Colab, and I will open new notebook. So here you will get Gemini inbuilt. Here you can see Gemini inbuilt. But first you have to log in. See, start coding or generate with AI. If I'll click on generate with AI, so it will ask me like this. So I will write, okay, give me code to find odd and even in C++. Okay, you can write anything. So I will write enter. See, it's generating and code is here in minute of seconds. Okay, if I will write in Java, the code is here in minute of seconds. Okay, in seconds it will give you. So this is the second. You can use Gemini as well in the, see, while giving prompt here, or you can open Gemini, right? You can open Gemini as well, but it's better if you are using Gemini for code, so use in Google Colab. Why? Because you can use or you can run code directly. Okay, let's try to run it. Let me run it. See, it's running. Wait. Okay, some error is there. Invalid syntax. Why? Okay, why it's giving error? Because I opened this, it's notebook only. Okay, this is the Python notebook, right? That's why it's giving error. Okay, let me run this in Python. Oh my god. See, it's running nicely in Python because it's Python notebook. Okay, so these are the odd numbers and these are the even numbers, and numbers are already given here, right? So this is the second one, and the third one is Claude. Okay, I have to log in it first. So here, so in Claude as well, we have, many models. You can say Claude 3.5 Sonnet and Haiku is there, and some more things are there. Okay, and here I will write, okay, please give me code to make snake game in Python. Okay, so see, now it's generating. So some tools are, to generate code from the scratch, and some tools are the, suggestions tools. Okay, we will see the next one, the suggestion tool, what I am talking about. Okay, so here all the details for this particular code, and yeah. So third model is Claude. So this is how you can use Claude. So there are many models of Claude, like I told you already, 3.5 Sonnet is there, Haiku is there, and there is one more. Okay, where I can't see. Okay, but again, it's, it's paid thing. Okay, and the next is Codium. Okay, So I will show you Codium. This is the Codium, right? This Codium is this. So I have already installed this Codium into my, VS Code. Okay. See, Codium generate control plus I. See, this is the command. Just write. This is again Python one. Okay. Give me code to find the prime numbers in Python. Okay, just submit and the code will be here. See, okay, code will be here. Or if you write here, find the prime numbers. See, it will give you suggestion. Okay, if I will write define prime and then see again suggestion. If I will write this again suggestion, then yeah, code is complete. Okay, so it will give you suggestions as well. Okay, this is a Codium. So just like Codium, so this is our fourth tool, Codium, and just like Codium, there is one amazing tool which is called AWS Q Developer, Amazon Q Developer. This is the amazing tool. Okay, so recently they jumped into this thing, AI coding, and you can install it to Visual Code directly as well. Okay, you can go here and from where the extensions are there, you can write Amazon Q here. Okay, this thing you can install. Okay, it's like this Codium only. Let me show you some videos. Where are the videos? Okay, so how Codium works. Okay, not here. I will show you in this. See, this is how Codium works. Again, same thing. See, if you write this, again the suggestions will come. Okay, lambda function to publish user, like Codium. Okay, so the fifth one is our Amazon Q. Okay, so there are many models like Copilot. This GitHub Copilot is there. GitHub Copilot is there. GitHub Copilot is there for this AI coding, AI developer tool. And if you are curious to make a website within a second, so there is one more app called this tool, you can say WebSim. Okay, see what you like to create today. I will write here Amazon, but okay, let me first but they use Sonnet 3.5, means Claude. They are using Claude. So I will write here, I want to create Amazon.in. See, it will create website for you. No coding, nothing, all. Directly it will give you website. Okay, it's loading, I guess. So this is how you can use WebSim. Right? See, OnePlus Node, this came. Okay. I just gave Amazon.in and the website is here within a second. Okay. So these are some, important tools to learn or how to use them in 2025 for 2025. Using AI tools for coding is essential to be in the race. Okay, so these are some coding.
Thank you for joining us on this journey. If you have enjoyed the course, please share it with others and don't forget to subscribe for more courses on AI and other cool technologies. Keep learning and we will see you in the next course.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts. Choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.